Hey everyone, welcome to the Ultimate MySQL Developer Bootcamp. I know it's a bit of a mouthful of a title. My name's Colt, I'll be your instructor for this course. So in my experience, the first couple minutes of any course, sometimes the first day of a college lecture, is all devoted to introducing the instructor, talking about the syllabus, and talking about TAs and exercises and turning in assignments, and you don't actually get to cover much of the content that you care about. But this is a MySQL course. I want to talk about MySQL as soon as possible. So here's the promise I'm going to make you. I'm going to talk about who I am and my background, if you care about that. I'm going to talk about what the course covers, what it doesn't cover. I'll show you the projects and the assignments, all of that fun stuff in just the next 4 minutes. And then by the next 5 minutes, by the 5th minute of this course, we'll be typing SQL code. We won't have to install anything, we won't have to get set up. We have this nice workaround in the browser where you'll be able to actually run code immediately. Okay, so that's my promise to you. With that said, I'll shut up. I'll start talking about myself and who I am in the next video, and then we'll move on with the syllabus and so on. But remember, end of this section, we'll be typing code. All right, let's get started. Hey there, welcome to the next video. So in this video, all I'd really like to do is spend a couple seconds introducing myself, as well as introducing Blue. This is our course TA. You'll see her pop up a couple times in the course. Hopefully you don't have a problem with cats. Anyways, so my background really is that I've been teaching people to program in person for the last 5 or so years. I've been teaching web development boot camps in the San Francisco Bay Area, pretty much nonstop. So if you're not familiar with boot camps, web development boot camps that is, the way that they typically work is that they're 3 to 6 month long programs where students basically commit their lives for that duration to learning to code and nothing else. It's a very, very intense program. We take students who have 0 programming experience all the way up to the point where they get web developer jobs. So really rewarding work. I fell in love with teaching 5 or so years ago, and recently I decided to try my hand at taking my in-classroom approach and trying to bring it online. So this is my second course, and this course, as you know, is on MySQL. It's kind of the next logical step to teach online. So I used to teach this in person as well. I'm now trying to take my curriculum and bring it to the classroom online. All right, so that's enough about myself. If you do have any questions, if you're curious or you're actually interested in in-person boot camps, you have questions, absolutely reach out to me, send me a message or post a question on the discussion boards. All right, see you in the next video. So what I'd like to do in this video is take a quick tour or walkthrough of the syllabus, talk about the curriculum, what the course covers and what it doesn't cover. And at the same time, it's a good place to talk about prerequisites, if there's any experience you need for this course. And the short answer is no. But there's a longer answer. There are a couple things that might be helpful. So the way I'd like to do this, rather than just talking to you sitting at my desk, is to actually use the magic of editing, very high-tech, fancy skills here, and hop into the syllabus now and just go over some of the details with you. All right, I'll see you there. Okay, so I'm looking at the syllabus here. There's currently 300 or so different lectures across 17 different sections. And I won't waste your time going over every single section. I just want to point out some of the big trends and kind of where we're going based off of where we are right now. So the next section is really focused on setting the stage for what MySQL is, how it compares to other databases, what makes something a database, what's SQL compared to MySQL, and then we shift focus to installing. So by the end of that section, you'll have your own copy installed. And then from there, we really dive into code. We see how to create databases, how to put data in there, and then we focus a lot of time on how to get data out. How do we write complex queries? And along the way, there are dozens and dozens of exercises, including section 6, which consists entirely of challenges. It's the CRUD exercise challenge, where we spend a lot of time working with one data set in detail. Then we keep moving on, basically working our way up towards more complex queries, asking more complex questions of our data. So all of this contains things like aggregate functions, learning about string functions, learning how to work with dates and date times, how to sort our results, and then also working with logical operators. And if none of that means anything to you, don't worry. But if it does, you're looking for it, you'll find it in this syllabus. And then we move on to our next chunk of content, which has to do with interrelated data. With more complex data structures, how do we represent them with MySQL or with SQL? So we start talking about joins. If you've heard of joins before, sections 12 and 13 focus on joins. And then in section 14, we start working with our Instagram database clone. So what we'll do here is actually set out to come up with a clone of an Instagram-like database. Obviously, it won't be as complex as Instagram, but we work with things like photos and users and comments and likes and hashtags and followers and friends, all that fun stuff. So we'll set up our database here, we'll design it, and then section 15 is all challenges using that Instagram data. So it sort of serves as a final exam to the course, although it's not a test. There's solutions immediately after, but it sums up everything we've done until this point. You'll have a bunch of data, thousands and thousands of rows of data that I'm going to provide you. You'll put it in your database, and then you'll write code to answer a bunch of real-world questions that someone or some company might have about the data. But that's not the end of the course. We move on at the end into kind of a broader section where we start talking about MySQL plus other languages. So we see how to interact with Node in MySQL, and then finally, the course ends when we build a simple web application using MySQL and Node.js together. So that's a rough overview of all that we cover. One thing you might be wondering about are the prerequisites. And I did say earlier that there are no prerequisites. You don't have to have any experience aside from being able to work with a computer, being able to work with the internet, download things. But I should note that towards the end, well, at the very end, when we start talking about Node.js and building a web app, it definitely will help if you're familiar with things like JavaScript, HTML, and CSS. This isn't a course on those topics, so I don't spend hours and hours going over them like I could. However, I do spend a little bit of time introducing them in a couple minutes doing a crash course. But that's not the focus of this course, so that's the only note I would add. If you're here just for MySQL and that's what you're concerned about, there are no prerequisites. But if you really want to be able to understand Node.js at the end and the web app that we build, it will help if you have a little bit of experience with HTML and CSS and JavaScript. Other than that, though, no prerequisites. All right, I mentioned I wanted to get us writing some code as soon as possible, so that's what we're going to do in this video. Obviously, it's super early on in the course, so don't get your hopes up for doing anything crazy impressive. It's going to be pretty basic, but the idea is that I just want to introduce you to writing some SQL, show you what it's like. So the first thing you'll need to do is click on this link if you want to open the slides. I've included them with this lecture, or I've included the link itself as a resource with this lecture. So however you would like to get there, go to this link, which takes us to this page right here. This is the Try SQL Editor. And I'm going to make my screen a little bit bigger just so that you can see it. Here we go. And I'll start by just deleting what's already in there. So you might be wondering, what is this place? That's a good question. It's an interactive browser-based SQL environment. And what that really means is that think of it as your own personal SQL sandbox in the browser, where you can go try some things out and play around. It's purely for educational purposes. So this is not what you would be doing if you were actually working with a real production database. But what it lets you do is type some SQL queries and run them by clicking this Run SQL button, and you'll get a result. And that's fundamentally the process of working with SQL. You type something, and then you run it, and then you get something back. Oh, and before we go any further, I should point out that we're talking about SQL here, not MySQL yet. And if you're confused about that distinction, totally normal question to have, wait until the next section when I go into detail about the differences. But for now, I'd like you to try running some code. So here's the first line of SQL that we can try running. Select star from customers. So you can either type this or copy it from the slides or from the included code file after this lecture. So I'll just copy it from the slides here. And then back in the editor, I'll paste it in and click run. So the first thing you'll notice is that we get a bunch of data back. So I'm not going to go into the details of the syntax and what all of this means for every command we run. It's really more about just giving you an experience of running commands. The rest of the course talks about the details and the syntax. But what this does is it gives us all of the data about customers in this database. So you can see we've got 91 customers, and every customer here has a name. So these are stores or restaurants. There's the contact at the restaurant or at the business, the address, the city, the postal code, and the country. Okay, so that's all I'll say about that. Select star from customers. That gives us all of our customers' data that are in the database right now. So here's another thing we could try. It's very similar. Select star from orders. So we'll just copy that. And back here in the editor, I'll paste it in and click Run SQL, Run SQL. Same thing happens, but this time we get all of our data printed out for our orders. So you might be wondering, where is this data coming from in the first place? Very good question. It's pre-programmed in here. So every time you open this in your browser, you have this preloaded data set that you can work with. And just by taking a quick look at our order data, you can see we have things like an order ID, a customer ID, an employee ID, an order date, and a shipper ID, but there's really not much descriptive information here, and that's actually why I chose this table. I wanted to make the point that a lot of the data you'll be working with on its own, or like a snapshot like this, isn't very meaningful. What we actually want to do is start combining it with other tables. So we're not going to do that now, but that's what we're building up towards the end of the course, is how do I combine customers with orders and products and shippers to get some meaningful answers out of my data. So here's another thing we can do, very similar to what we've done already, but there's a little bit extra. So select star from products, order by price, descending, DESC. And if I paste that in here and click run, what I get now are all of the products in my database. So they have a product ID, a name, a supplier ID, category ID, a unit, and then a price. And they're currently sorted by most expensive down to the cheapest all the way at the end. So I won't force you to listen to me trying to pronounce some of these, but these are our products and they're currently sorted by price. So just a simple modification to the query yields radically different results. And if we just get rid of that order by price, we get the same data back, but now it's ordered by product ID rather than the price. Okay, and stepping up in complexity a little bit here, here's another query, this one significantly longer. And this one actually involves two different entities. So we saw customers, we saw orders separately. If you try copying this and pasting it in, and you click run, what we actually get here is a list of records for a customer, and then the number of orders a given customer has placed. So remember, this data is stored in two separate places. We had the customer's data that had nothing to do with orders, and then we had the orders data, and all that it contained was customer ID, and then we've combined them with this query. So do not focus on the syntax, don't panic about that. Of course, we'll get there. We'll talk a lot more about how to structure queries. I mean, most of this course is about structuring complex queries. In fact, here's a quick preview of some of the things we'll be doing. So here's an example of a slightly more complicated query. This time we're working with photos and images. We're working with users and likes and putting them all together to get some information out. And here's another one, a little bit crazier, where we're working with ratings or reviews and TV shows and reviewers. So think of like a Netflix or iTunes where you could rent or watch a TV show and then rate it from 1 to 10 or 0 to 5 or whatever the rating scale is. Here we're working with that data to figure out who our power users are, who are the most active users who are reviewing the most things. So we'll be building up to these sort of queries. And by the end of the course, you should be able to make sense of this and do a lot more, by the way. Okay, so that was a taste of SQL. Hopefully it didn't taste too bad. So in the next section, we'll dive into the nitty-gritty of what SQL is and how it compares to MySQL. We'll get everything installed, and then finally, we'll have our first set of exercises. All right, so I have some good news, which is that in the next video, we're gonna start typing code. We're gonna start with SQL. The bad news is that we still have to make it through this video. Hopefully it's not too painful. Essentially what I want to talk about is different types of content in the course and how the course really works. It might be a little different than other courses you've taken online, depending on how they were structured. Basically, I break the content into a couple different categories. The first are things like this video, where it's a video of me talking, usually with Blue, and you know what, you don't have to watch them. They kind of just serve to introduce content. It's a way for me to kind of interact with you, to say hello, and to set the stage for what comes next. And if you're someone who has no patience for that sort of thing, absolutely skip it. So then after that, we've got the actual content of the course, the lectures. So there are a ton of videos where it's mostly a screencast, and I'm explaining concepts. I usually make a bunch of diagrams, slides. I try and make things somewhat visually interesting. I'm not a great graphic designer, but I try and keep things interesting to look at. And then I also, type code. And there's a lot to watch there, ideally. So it's a combination of slides with me talking over it, as well as diagrams and animations, and then most of the time typing code in our text editors and running SQL code. So those are the lecture videos. But then we've also got, and this is probably the most important part, more so even than the lectures, which are the exercises. So one of the things that I think makes my courses stand out a bit, some of the feedback I've gotten, has to do with exercises and activities. And I think they're really, really central to making a good course. So I kind of throw them everywhere in the course. And then within those exercises, we've got a couple different categories of challenges. The first are what I would call rapid fire, basically pause the video, I'll ask you a question, very short quiz type questions. And then there are the second type of exercises, which usually come at the end of a section, the last video typically, and it's an entire video dedicated to exercises. Usually there's like 5 to 10 challenges in that video. And then following that, there's always a solution video where I go over the solutions, I tell you the answer, and then also show you myself coding them. And as always, the solution code is available if you don't care to see me explain it. If you just want the code, you can get that at any time. And the final type of challenge is more comprehensive. It's essentially, there are a couple of sections that are entirely devoted to exercises. So they might have 7 or 10 different videos, but they're all about one set of problems. So there's not many of these in the course, they take a while, but there are a couple of these challenge sections. So just to reiterate, we've got quick rapid fire questions, we've got more general kind of summation quizzes and exercises at the end of a section, and then we've got entire challenge sections. And of course, after every lecture, I include the code, all of the commands that I type. They're in a file that always comes after the lecture, and it always starts with the word code in all capital letters. So the last thing I'd like to add is a piece of advice, I guess, which is that I highly recommend you do the challenges and do these exercises. Obviously, I have no control over that. You can just skip through everything and just take the pieces of the course you need. But if you're trying to get the full experience, kind of the way that I designed it, I would do all the exercises, do the challenges. Even if that means, going at a slower pace. It definitely means you'll go at a slower pace. But you'll learn much better, and hopefully you'll have a better experience. And with that said, the other component that's really important are the discussion forums. We have a full-time TA in the course, as well as myself, who are here to help you at any point. So absolutely lean on that. Ask any questions you can come up with. We're here to help. All right, on to the code in the next section. Hey there, welcome to the next section. So this section is really important. It's where we actually start talking about code. It's where we install everything. And by the end, you'll be running your own SQL commands. So some big things we're doing. To start off, we're just going to talk about what makes something a database. What makes something a database compared to, just a programming language. What's the difference? And then we talk about the difference between SQL, and MySQL, a really common question, and something that's basically fundamental to all databases or all relational databases, at least. And then from there, we're going to move into installing stuff. Really important step for this course. You'll install MySQL, get it up and running. And by the end of the section, for some of the challenges and exercises, you'll be running your first bit of MySQL code. So nothing crazy. We're not working with any complex data yet. We will be, but not yet. We're starting off nice and easy, just some simple commands, but still it's something. So by the end of the section, we'll be doing that. All right, let's get going. All right, so we're going to start off by taking a bit of a step back and talking about two very high-level general questions that are pretty central to everything this course is about. And they are, first off, what is a database? Seems like it's a pretty straightforward question, but there is a little bit of terminology we need to discuss. And then secondly, why do they matter? So let's start off with the first one. What is a database? What actually makes something a database? And there are a couple of definitions that we could go with here. I kind of synthesized some of them into my own definition that has two parts. And the first part is that it's a collection of data, which seems pretty straightforward. There are all sorts of collections of data around us in the real world. Things like when you go to your doctor's office and there's a filing cabinet full of medical records, or even just a to-do list or a list of things to buy at the grocery store qualifies as a collection of data. Or going back a little bit in time, if you remember what Rolodexes were, a Rolodex full of different people's contact information, that qualifies as a database under this definition. Speaking of archaic technology like a Rolodex, another example of a database is a phone book. So I say this mainly jokingly, but I actually have some siblings who don't know what a phone book is, or they've never seen one or used one before. It's a gigantic book, basically, that lets you look up people's phone numbers based off of their name. So it's usually organized by last name alphabetically for people. So you would flip through the book until you find someone's last name, and then you would try and match their first name, and then you find their phone number. So let's take a quick example here. This is a fictional phone book. Think of it as just a little section of a phone book that has tens of thousands of entries. And these are fictional characters, alphabetically organized by their last name. So Archie Andrews comes before Betty Cooper, who comes before Ned Flanders, and so on. And then we have corresponding phone numbers. So imagine you have a gigantic phone book with this information in it, and I asked you to do something like find Ned Flanders' phone number. Well, it's actually pretty straightforward as long as you're comfortable using the alphabet in alphabetical order. You flip through the book until you find F, FL, and so on until you find Ned Flanders, and then you find his phone number. It's what the phone book is made for. However, it gets a little trickier, or a lot trickier really, if I asked you to do something like find everyone in the phone book who has the first name Ned. There isn't an easy way to do this. You basically would have to go through every entry in the book and check for however many thousands there are. Is this person's name Ned? So I have a couple other questions that are similarly difficult. So the point here is just if you were to find all phone numbers with a particular area code or to find all people who have a 3-letter first name, it's not easy. And it would take a lot of time, like a ton of time. So that brings me to the next component of the definition of what makes something a database, in my opinion, which is not just a collection of data, it also contains a method for accessing and manipulating that data. So going back to this phone book, we would want a way, some sort of program or code that would allow us to do things like find everybody with the first name Ned, or find all people who have a 3-letter first name, or even do things like add a new person into the phone book, or change area codes or change phone numbers, or get crazy and just delete people from our phone book or delete everybody if we wanted to. We would have some sort of program or code as part of our database that would help with that would allow us to interface with the data. So I did say we were going to dive a little bit into jargon and terminology. I usually try and stay away from that early on. Well, I try and stay away from that in general, but especially early on in a course. Basically, if you've read about databases, if you've used one before, if you've read a blog post about them, you may have come across the term database management system, or relational database management system, or DMS, or RBDMS, all these different acronyms. Basically, this right here, what I have on the screen, database versus database management system, refers to the fact that what I just talked about, having data, a collection of data, and then having an interface for that data, are two different things. So let me show you a quick example. Imagine that you have an application. Let's say it is a dating app. And then you have a database, and you're storing all sorts of information, all the different users, all the different messages that have been sent, the photos, whatever else goes into your dating app. But on its own, the database here is basically like our phone book. It's a gigantic collection of data, which is great for storing data, but it really doesn't let us do very much. You can almost think of it as if it was a gigantic file on your computer. So for our application to be able to do things like update somebody's username in the database, or edit their profile photo, or delete a user if they want to leave our application, whatever it is, there's a database management system that allows us to interface with that database. So it's just the code or the program that does the talking to our database for us. So we talk to our database management system and it talks to the database. Okay, so for the most part, we're out of the weeds with the jargon here. The reason I brought this up though, is that oftentimes when people talk about a database, you actually hear them referring to both of these things, the database management system and the database together, just as a database. So what I have right here is a list of some of the more common databases you'll run into. And actually, I just did it there, what I was just talking about. These 4 things, Postgres, MySQL, Oracle, SQLite, they're not technically databases. They're actually database management systems. But for the most part, people just call them databases. So when we say things like, MySQL is one of the most commonly used databases, it's actually one of the most commonly used database management systems. So it's not the end of the world if you forget about that, but it is important because it will help you understand later on when we actually start talking about SQL, when we start talking about some of the code that you write to interact with the database. I think it will help you understand what you're doing and that you're giving commands to this database management system which then goes and gives commands to the actual data itself, or to the database itself. Okay, so to wrap everything up, here's a little bit of a synthesized definition. What is a database? Well, it's a structured set of computerized data with an accessible interface. So in this video, we're going to talk about one of the more common questions that comes up early on, which is, what is the difference between MySQL and SQL? Or I usually just say SQL, but what's the difference between these two? Obviously, SQL is contained in the name of MySQL. What's the significance of that? So let's start off with discussing SQL, which stands for Structured Query Language. So SQL is the language that we use when we talk to our databases. It's the way that we interact and access the data, update data, delete things, and basically manipulate the data in our databases. It's the language we use. So it's how we do things like find all users. Now, what I'm showing you here is not actual SQL code. You'll see that in just a second. These are just humanized versions. Find all users who are 18 years old. Add a new user with username Jumbo Jim, or if we want to get crazy, delete every single user. So these are the sort of things that we use SQL to do. So we write these lines, which are called queries, structured query language. And once we hit enter, or once we run that SQL code, it's executed and it goes off and it talks to our database and it does it for us. So if you are curious of what it looks like, here's a really quick one-line preview. The English version, find all users who are 18 or older, is translated into this. Select star from users where age is greater than or equal to 18, semicolon. So hopefully that actually seems pretty straightforward. Now, we're going to dive into SQL all throughout this course. You don't need to worry about this exact statement. What's important, though, is that you can see there is a special syntax we use, and that this query here is going to be sent off to interact with the database somewhere. So the next point I want to make is that when we work with MySQL, we're actually writing SQL all the time. So MySQL is what we talked about earlier, a database management system, and there's a bunch of them out there. Here's some common ones: Postgres, SQLite, Oracle. There's hundreds of others. And there's dozens of popular ones, but hundreds of them all over the world that maybe aren't as popular. So all of these ones here that I've highlighted use SQL or SQL. That doesn't mean every database ever does, but what are called relational databases do. And we'll talk more about that later when we discuss tables. But for now, the point I want to make is that SQL is not unique to MySQL or to Postgres. That's why they all have this SQL in their name. They share this language. So structured query language, SQL, is a standard, basically, that these relational database management systems like MySQL implement. So it's kind of a lot of jargon and terminology again, but the main takeaway is that when we use something like MySQL, we'll actually be writing SQL all the time. So here's an example of what a line of SQL code looks like to do the exact same thing in a MySQL database and a Postgres database. Here's the MySQL, and here's the Postgres. And hopefully you notice they are identical. Both of these are different database management systems. They have differences to them, but they both use SQL. You will be writing SQL when you interact with these databases. So just to hit that home, there are slight differences in the syntax. They are not identical, but they're very, very similar. Oh, and I better not forget to mention the SQL standard. So the way that this whole thing works is that there is a standard for how SQL should work. It's actually written down. You can read it online. And all of these different database management systems basically are tasked with implementing that standard in their own database and making it work. And they deviate sometimes a little bit, but for the most part, they're very, very similar. So the two takeaways here. One is that once you learn SQL, it's really not that hard to switch to another database that also uses SQL. So you're learning MySQL, you could pretty easily switch to Postgres or to SQLite with not a lot of time needed to get up to speed. And the second thing is that what makes databases or database management systems, to be specific, what makes them unique are the features that they offer, not the SQL or the language itself. So if we go back to this diagram, all of these use SQL, but that doesn't mean that they're identical. And yes, you might write the same line of code to do the same thing here. So what makes these different are the features that they implement. Things like how secure is one versus the other, or how fast is it? How big is the download? How do user permissions work? And on and on and on. And we'll talk more about what those differences are when we get to a point where they actually make a little bit more sense. I don't want to just talk at you. Okay, so this was about MySQL versus SQL. SQL is structured query language. It exists separately from MySQL. And MySQL is a database management system that implements SQL. Alrighty, so we've spent a healthy amount of time talking about the higher level things, kind of setting the stage for this course. Why should you care about databases? What are databases? What's MySQL? Where's that fit in? What's SQL? And so on. Now it's actually time for us to really get going. So hopefully that's a little bit exciting. Unfortunately, the first thing we have to do is install the tools, install MySQL on your computers. So I want to add a note really early on, which is that in my experience, installing anything can be a pain. And that's true for someone who is an experienced developer all the way down to a complete beginner. It's always a potential point of friction where things can go wrong. And nothing is more frustrating than being excited to do something, being excited to learn something new, and then have it not work, or have to spend hours trying to figure out why it's not installed correctly and what's going on. In my opinion, it's one of the worst parts of being a developer. And then also in my experience teaching, I've seen a lot of people get discouraged really quickly when something doesn't work out. If you're unable to install MySQL when you want to learn MySQL, it might just send you in a different direction, and you might end up learning another database like SQLite that doesn't require as much setup and that's easier to install. So we don't want that to happen. Nothing against SQLite, but this is not a course on SQLite. So I just wanted to put that out there, that keep in mind, installing can be a pain, but I'm going to do my best to try and make it painless. So we have three options. The first one for installation is to install it on a PC. So if you have a PC, if you're a Windows user, you can follow those instructions. The next option, as you probably guessed, is that you can install it on a Mac. So if you're following along using a Mac, this would be a good choice for you. But there's also a third option, which is to install it using a service called Cloud9. So if you've taken my other course, you may be familiar with Cloud9. It's basically an online interactive development environment. In just a couple of videos, I'll go into some more detail about it. And before we go any further, I just want to highlight that installing using Cloud9 is without a doubt the best and easiest way to get started, and it's what I recommend that you use, which is why I spent so much time drawing this little box around it. Install on Cloud9. So why is that? Why do I recommend that you use Cloud9? There's a couple reasons. The first is that it's what I'll be using in the course. So rather than doing everything on a Mac and confusing the Windows people, or doing everything on a PC and confusing people on a Mac, I'm going to use Cloud9, which is something that anybody can use regardless of the type of machine that you own, how old it is, how much RAM you have, what operating system. That doesn't matter. It levels the playing field. So because I'll be using it in the course, I think it makes it a lot easier for you to follow along. Now, if you're someone who's pretty confident as a developer, of course, feel free to install it however you'd like. But I highly, highly recommend that you use Cloud9, at least early on, because you'll be able to follow along much, much easier. And the second reason, equally important, is that it's way easier for you to get help if something goes wrong. If you're doing a project or an exercise and something doesn't seem to be working the way you expect, or you hit a bug, or you're just not sure what you did wrong, you can easily share a link to your environment through Cloud9 and post that on our discussion boards, and either me or one of the TAs can help you out. So it's way easier for you to get help. If you were just working on your PC or Mac and you're trying to explain what's wrong, you're going to have to take some screenshots, you're going to have to upload them, you might have to copy and paste some stuff from your terminal. But if you use Cloud9, and I'll show you this when we talk about Cloud9 in more depth, you can just take the link of your workspace and share that, and anyone will be able to look at your code and diagnose a problem. And the third reason that I didn't write down, and this is a really important one, is that installation is basically painless. You have to sign up for an account, and that's about the worst part. Once you're past that, it's one command to get MySQL working, which is pretty amazing. So with all of that said, this is my recommendation or prescription for how you should go about this course. Use Cloud9 to follow along throughout the course. So everything that I do in Cloud9, you'll be able to replicate yourself in Cloud9. And then once we finish the course, you can return back to the installation instructions and then install it on your Mac or your PC natively. So I'll talk about what that means, what's the difference between installing natively versus Cloud9 when we talk more about Cloud9 in just a little bit. So that's my recommendation. I highly, highly recommend that you start with Cloud9 and then later on, if you'd like, move to working on your PC or your Mac. All right, so enough about that. Let's get down to business. All right, so in this video, we're going to go over the specifics of setting up Cloud9. Now, just to recap, Cloud9 is a cloud-based developer environment. So what that means is that it contains everything you need to create applications and have databases, basically a terminal alongside of a text editor, all in one inside of your browser, so that you can instantly get, and I know I sound a bit like a marketing shill for Cloud9, I promise I'm not, we don't have any sort of deal, I wish we did, but what it lets you do is get something going really quickly and very, very painlessly. So the first step is to sign up for an account. So if you visit the URL c9.io, or you click on the link in the description, but it's a pretty short URL, c9.io, you should see this page if it's your first time visiting and you don't already have an account. If you already have an account from another course, you can wait until the next step where we create our new workspace. So if you don't have an account, all you have to do is enter your email, hit sign up. You'll have to fill in some information, pick a username, choose the kind of developer that you are, choose how you'll use Cloud9, click next. Make sure your details are correct. Now this is where some people may panic, but don't panic. It asks you for credit card information. Now, if you notice here, it does say that you will not be charged. So there is a perfectly functional free tier of Cloud9, but you do have to have a credit card to sign up this way. Now, as I said, don't panic, because if you don't have a credit card, which I know a sizable number of my students actually don't have credit cards. You may come from a country where credit cards aren't as prevalent. You may be too young to have a credit card, or you just may not have one for some other reason. And that's totally fine. It's not a barrier to using Cloud9. It's a little bit of a tiny hurdle. So there's a workaround. So Cloud9 offers educational accounts for teachers and instructors. And what that allows me to do, or allows you to do, is to sign up without having to use a credit card. Now, the only problem is that I have to manually add you in as a student under my educational workspace. So again, it does take a bit more time because either me or one of the TAs will have to manually add you in, but we're committed to doing that. We want to make sure that everyone can follow along, even if you don't have a credit card. Now, if you do have a credit card, I do recommend that you just fill this out because you will not be charged. And it's just going to be faster. You won't have to wait for me to wake up in the morning and check the discussion boards on Udemy. You'll just be able to get started right now. So once you've filled all that information in and completed the sign up process, you should see a screen like this, although you won't have any of these workspaces here. So in Cloud9, when you create a new workspace, what you're actually doing is creating a new developer environment, separate partitioned off environment that you can work in. So actually you can see here, I have a couple of different environments going. Some of these I use all the time, like the one for my Web Dev Bootcamp course. Some of them are just, here's a test that I made to see how a Ruby environment works in Cloud9. Or here's one where I installed MySQL, which is what we'll be doing in just a moment. So step 2 is to actually go ahead and create a workspace. So we click create a new workspace, and you're welcome to call your workspace whatever you want. I'm going to call it MySQL _course. And then I'll go ahead and set it to be public. It's up to you if you want your work to be private or public, but you don't really need to worry about anybody seeing what you're doing anyways. But if you do want to make it private, that is how Cloud9 makes some of their money. But I'm going to make mine public. Then we have these templates down here that we can choose from. So there are these presets that allow us to create a new developer environment really quickly. And that doesn't really matter for us in this case. So you can pick any of them, but I recommend you just pick HTML5. It's the simplest one. Basically, it's going to be an empty workspace for us. So then we click Create Workspace. We wait a little bit and wait a little more. And finally, once it's done, you should see something like this. So that's it for this video. In the next video, we're going to talk about what this interface means and how we navigate it. All right. So now that we have our workspace set up, the next thing we want to do is take a really quick tour, 2 to 3 minutes, of how the interface for Cloud9 works. So once you've created the workspace, you should see a window that looks something like this. I did increase my font size to make it a little easier for you to read. So yours will probably look a little nicer, but otherwise they should look the same. Before we actually dive into the interface, I want to emphasize what actually happened when you created a workspace, because I think it's pretty cool. I mentioned that Cloud9 is a cloud-based developer environment. When you created that workspace, Cloud9 has a computer somewhere, a server, that made you a little bit of space just for your little developer environment and basically made you a section on a computer that's private for you. It only holds your stuff, your files. And right now, there are only 2 files in there, which we can see over here, helloworld.html and readme.md. Those are both just automatically created. The HTML file is created because we chose that HTML template. If we had chosen a Python, or let's say we chose a Ruby template, we would have a hello-world.rb file. But that doesn't really matter because we're going to get rid of both of them anyway. But the idea is that there is space actually on a computer somewhere that is running all of this. It has these files on it. When we install MySQL and get it running, it's not actually going to be running on your machine, or in this case, on my machine. It will be running on Cloud9's machine, and this is just a browser interface for me to talk to that machine, which is pretty amazing when you think about it. So that's enough of that. Now let's take a look at the interface. We have 3 main sections. The first one is what I'll call the file tree. It's basically a visual representation of the contents of your workspace. So as we already talked about, there's 2 files there right now. As we create new files and directories or folders in this course, you'll see them pop up over here. The next area I'll call your attention to is this middle area. I'll call it the text editor. So if we open up one of these files, like readme.md, which is what is currently open, if I double click that, it opens up, as you can see here, readme.md. Don't worry if you've never heard of Markdown. That's not super important at this point. But I can now go in and edit things. And if I hit save, on Mac it's Command S, on a PC, Control S. So I can switch files to the HTML file by double clicking. And now opens up a tab here. I can go back to that other file. I'll close out of it. Now, you don't need to know HTML, of course, for this class, but the point here is that we have files, we can double click, and we can see them over here. The last thing that I'll show you before we move on to this bottom section is how to make a new folder or a new file. So what you can do is right-click on this space right here, and you can scroll down and find new file or new folder. So let's make a new folder, and I'll just call it testing. Then I can right-click again and go to new file. You can also do file, new file, just like you were working in a real text editor natively on your computer. But I tend to do this here, new file, and then I can call this whatever. I'll just say hello, and I'll make a txt file. Now to open it, I can double click, put whatever I want in there, Now, if I switch, you see that little dot? That means it's not saved. I can go back and save it and close out. And now we have 3 files over here, as well as a new folder. So that's pretty much all there is to the text editor area. And we'll be working with this later on when we're creating SQL files that we're writing our code in and then running all at once. Then the last section that I'll expand down here is the shell, or the terminal. If you're familiar with any sort of bash shell, this is exactly a bash shell. And if you're not, don't panic. I'll throw up that little don't panic thing again. You don't have to know that for this course because of the way Cloud9 works. We have this visual interface for navigating our folders and files. But it definitely is not a bad idea to learn some basic terminal commands. I'll include a link to some of my favorite resources for learning that if you'd like. But again, you do not have to know how to navigate the terminal to do this course. But just to show you that this is a full-fledged terminal, I can do things like ls to list all the files in my current directory. And you can see I have readme, hello world.html, and testing. I can change directory into testing. And now if I type ls, I get hello.txt. So I'm inside this directory. And I can do things like print working directory. Now we will be running commands from this terminal mainly to initialize MySQL, as well as work with the MySQL interactive shell, and a whole bunch of other things. But those will be MySQL specific commands, not the general bash commands. So that's pretty much all there is to the interface at this point. We have the file tree, where we can double click to view files over in the editor. We can make changes there. And then we also have the terminal down here, which we'll be working with quite a bit as well. Next up, we have an optional, really quick activity. If you just want to get a little bit of practice with Cloud9, if you're feeling a little bit out of your element or uncomfortable with the interface, here's a really quick activity. So there's just 5 steps. Make a new folder in your Cloud9 workspace, call it whatever you want. Then inside of that folder, create 2 new files, whatever type of file. TXT is probably easiest, and name them whatever you'd like. Add some text to one of the files, and then delete both the files, and then delete the folder. So not the most exciting, I know, but it's good practice. If you'd like to do that, go ahead and do it now, and then in just a couple seconds, I'll have a solution.
In 3, 2, 1, pencils down.
All right, so to make a new folder, we can just right click, new folder, and we'll just call it my folder. Then to make a new file in that folder, we can right click again on the folder this time, and we'll just call this one 1.txt, and we'll create another one. And actually this time, I'll show how to create it using the terminal, which is not a requirement. So I will navigate using cd and ls to the my folder directory. Then inside of here, I will create a new file called 2.txt, and I use the command touch. Again, don't freak out if you're not familiar with that. I'm just showing it to you just in case you are someone who likes to use the terminal. Okay, so that, as you can see, made a new file up here. Let's go into one of them, double click, add some text, blah, blah, blah. We'll save, close out of it, just to make sure it's there. We'll double click again. This other one's empty, looks good. Now the next step is to delete the files. And this is not something that I actually covered in the previous video, but I do think it's pretty self-explanatory. You right click, you'll scroll down and click on delete. That's one way of doing it. It's going to ask you if you're sure you want to remove it. It can't be undone. We'll click yes. You can also use the command line if that's something you'd like to do. Use the rm command, and you can see it disappeared. And then lastly, delete the folder, right click, and we can click on delete. You could also do it from the command line as well. And that's it. So we finally arrived at the moment where we actually start working with MySQL. And by start working with, I mean we're just going to install it and make sure it's running correctly on our Cloud9 instance. but still, it's something. So before we dive into that, I just want to show you a post on the Cloud9 community. This is written by one of the employees at Cloud9, and he's explaining how to use MySQL inside of Cloud9, inside of a workspace. And basically what it talks about is that they've created at Cloud9 a really quick and easy way to get MySQL running in one of your workspaces. It's much, much easier than what you would need to do to install it on your own. They have a nice little shortcut. There are 3 commands that we'll talk about. They're the 3 that are here. Basically, start, stop, and CLI. But before we go any further, I just want to point out that these are not general MySQL commands that you can run on any machine anywhere. These are actually Cloud9 specific. So the upside of this is that they've made it really, really easy, like almost too easy to get going with MySQL. You just run these commands and you're there. It's kind of magical. The slight downside of that is that it doesn't work on every single machine, and it is Cloud9 specific. So when you do install on a Mac or on a PC, you'll just have to relearn a new command to do basically the same thing. But for now, since we're in Cloud9, we get to appreciate how easy it is. So the first command is mysql-ctl space start. And you'll notice that the 3 commands we're going to take a look at all start with this mysql-ctl. And I believe it stands for Command Line Tool, CTL. It's just the abbreviation that Cloud9 came up with. So this first one, if we look at their documentation, it tells us it starts MySQL and it will create an empty database the first time you start it. So let's give it a shot. You might notice that I cleared out everything in this directory. I got rid of those 2 starter files. You don't have to do that, but I just wanted to get rid of clutter. So we're going to write mysql-ctl space start. You can see it's hard at work installing MySQL. It's starting up a server. It's doing a few other things. Don't need to worry too much about that. It tells us a root user is my account name. Our database name is C9. It created a database for us. Again, we'll dive more into this in the next section when we actually start talking about databases and how you create them and work with tables and write SQL. For now, all that we really care about is that something happened, which is good. So the next command is the same thing, mysql-ctl space, this time CLI, and that stands for Command Line Interface. And what this will do is it will start up the MySQL interactive shell. And if you've worked with any database before, usually there's an interactive shell that goes along with it. Or if you've worked with things like Ruby or Python or Node, there are usually terminal or command line based interactive environments. If this is all new to you, I think it's easiest to understand it just by using it and taking a look at it. So now let's try this again. This time, mysql-ctl space CLI. And we hit enter. So now we have a bunch of new text. Welcome to the MySQL monitor. Commands end with semicolon, and we'll come back to that in just a second. Tells us our MySQL connection, server version, copyright, gives us a little copyright notice here. And now we're inside of what's known as the MySQL interactive shell or the monitor. So this is where we can go to actually type commands. So if you think back to the telephone book example, this is where we would go and say things like, find me all users in our database who have a first name that is 3 characters long, or find me all users in our database who are 18 years or older. So this is where we can go to type code to interact with and access a database, but it's also where we can go and type code that works more on like a meta level. You can think of it as doing things around permissions, creating entirely new databases, transferring data from one database to another. There's a whole bunch of things we do in this shell, and we'll be working with this quite a bit. So for now, we're not going to do that. We're going to wait until the next section. All that we're going to see right now is that you can quit this. There are quite a few ways of quitting the shell. We can use exit, notice a semicolon, quit, also notice a semicolon. We can use \q. I always mix up forward and backslash, but this slash pointing down Q, or what I usually use, Control C. So whatever works best for you. I think there are actually a couple more different ways of quitting, depending on the platform you're using. But for me, I usually use Control C. But just to illustrate that, I'll do 2 of them. So let's do quit, semicolon. We get a nice message, bye. Seems a little sad. We can restart the CLI by either retyping that whole thing or just hitting the up arrow. So I'm going to do that now and hit enter. We get this exact same message. You'll see it every time. This time I'm going to use Control C. You'll just have to trust me I did it. Actually, you won't, because you can see it here. Control C. This time it says aborted. So it turns out there actually is a little bit of a difference. If you notice up here, it said bye. It kind of was expecting to quit because I used the quit command. And here I just ended the process, which is why it says aborted. So technically there's a difference, but I just used Control C because you don't have to really type anything. It's much easier. You don't have to hit the enter key. You don't need a semicolon. Really, whatever you prefer. Some people like to be more explicit and use quit or exit. Okay. So the last command that we're going to take a look at is MySQL-CTL space stop. And you're really, really rarely going to use this one, but what this one will do is stop the MySQL process completely. So to understand what that means, it helps to understand what happened when we typed this first command here that started everything. So what that did is that it started up a new instance of MySQL. Then that's running constantly in the background at all times until we stop it. When we use this second command, MySQL CTL CLI, I know it's a lot of abbreviations here, but when we use that CLI command, it is connecting to the instance of MySQL that was started up from the first command. So just to reiterate, this CLI, when we do this and start it up, it is connecting to the MySQL connection that we started up earlier. So I'll exit. And if we wanted to, we can stop that background process. We can stop MySQL from running completely. So we're not just stopping the CLI. This is already stopped here, but we can stop everything related to MySQL using MySQL-CTL stop. And it just tells us stopping MySQL database server, blah, blah, blah. Okay, so 3 commands. Realistically, the way that this will work is that we'll start it up and we're going to leave it running for basically the entire course. And we're going to start and stop the CLI all the time. Pretty much every other video will be starting up the CLI, typing some code, quitting. So you should get used to that, but you don't really need to worry about stopping it all that often. Okay, so next up, we just have a quick little exploratory activity where you'll be able to type some new commands into the CLI and see what happens. Okay, so as I mentioned in the last video, we're going to do a really quick activity where you're basically going to try experimenting with these 3 commands and enter them into the MySQL CLI. So if you stopped it, if you quit, make sure that you open it back up using the CLI command, and then try running these one at a time and just see what happens. So pause the video if you'd like and do that, and then come back, and in a few seconds, we'll go over what happens. All right, so let's start with the first one, help. So I'm going to clean up my terminal here just by using the clear command. Then I'm going to access the CLI. I'll just use the up arrow. So now I have this CLI, command line interface, ready for me to type some commands. So I will do that first one, which is help. And you can see we're actually prompted to type that. So when I hit enter, all it does is give me a list of commands of things that I can do. You can see we've got things like clear, help, which we just used, print, prompt. We've got quit, which we already used as well. Basically, it's just a list of things that you can do. As you can see, we can also try help contents. And we basically get a list of categories that we could access. So if we wanted to know more about, let's just pick one of these at random. Don't worry, let's try data types. We can do help data types. And it kind of dives down further and gives us information about what those are. We haven't talked about data types, so don't stress about that. The next command to try is show databases. So we'll come back, try that, show databases. And it gives us this nice little representation here of the current databases that we have in this instance of MySQL. So we haven't talked about how you make a new database. You might be wondering what's going on. There's already 5 of them here. All of those were created automatically when we created this MySQL instance. So don't worry, it doesn't really matter what they are right now, but they're there automatically. There are 5 different databases. In the next section, we'll actually talk about what a database is, when you create a new database, why you create a new one, when you use the same one. But I just want to show you this command because you'll be able to use it in the future. When you create a new database and you want to make sure it worked, you can type show databases and you should see a new one added below. And the final command here is select @ hostname. This is also kind of a weird one that most likely you will never type after this, but I just wanted to show it to you. Not because it's something you need to do, but just it's something that you can do quickly and immediately. And all of this here is just to illustrate the point that the CLI works by you typing commands, hitting enter, and getting some text back. So that process over and over and over. So here it tells me that my @hostname is this string here, basically my username. Yours will be different depending on your workspace and your username. So as I mentioned, it's honestly not important what it is or why it's there at this point, but I just wanted you to see that you can type these commands in and get something back out. So that's it for this really quick, kind of silly exercise. But in the next section, we're going to start actually learning SQL commands. So you'll be able to start interacting immediately, creating databases, creating new tables, adding data into those tables. And it gets a lot more interesting there, I promise.
Warning. This video may contain extremely frustrating installation instructions and is for experienced developers only. It's advised that you install using Cloud9 to avoid needless pain and anger.
Okay, welcome to this video on installing MySQL on a Mac. And again, I'll warn you, this can be painful. And this lecture and doing this, all these steps are 100% optional. In fact, if you don't have a good reason, if you're not sure if you should do this, then that means that you shouldn't do it. At least not until you get to the end of the course. Of course, if you're somebody who is an experienced developer and you know you want to get this running locally at the beginning on your Mac, then go ahead, follow these instructions. But I would definitely recommend that you go through the course. For 99.9% of the people in this class, go through the course with Cloud9 and then install this on your Mac at the end. It just makes everything so much easier. Okay, so if you're still here though, the steps to actually install it are surprisingly simple. The problem is once you install it, you run into issues depending on your developer environment, depending on things like if you're using Bash or Z Shell, if you have permissions issues and passwords, and it just turns into a nightmare a little bit. Well, not just a little bit, a lot. So the first thing we need to do, like I said, is actually nice and easy. Just go to mysql.com, go to the Downloads tab, and what you'll see here are a bunch of the basically like the commercial services and MySQL enterprise software that is not free. We want the community section. And then we want the first thing here, MySQL community server. Then at the very beginning, this is kind of just a blurb about it, some documentation, instructions. But if you keep scrolling down, you'll see the download links. So you'll need to select the one that corresponds to your Mac, depending on how old your Mac is, how new it is, what version of Mac OS it's running, all of that. You'll have to make a decision. But for me, it's this first one here. So I'll click download, and it looks like you have to type or you have to sign in or create an account, but that's not true. You scroll down and there's this link, no thanks, just start my download. Of course, if you want to, you can sign up, but most of you probably don't care. So just click no thanks, just start my download. And I'll see you in just a second once I edit this download timeout. All right, now that's completed downloading. So I'm just gonna open it up. Might take a second to open, But once it does, you'll see a single file inside of this. And we'll just double click, follow the steps, continue, read every word of this. Of course, I've already done it, so, I know everything it says. Click agree. Tells you 1.13 gigs of space needed, so make sure that you have that available. Then we'll click install. Then it will ask you for your password for your computer. Fortunately, I guess I can use my thumb or my finger. That way, you don't have to watch me type my password. I don't have to edit that out. It's always a problem. I don't want people to see my passwords. Okay, so here's an important part. I mean, it's all important, but this in particular, it gives you a little pop-up here that says a temporary password is generated for root at localhost, and then it gives you this password. So I don't highly recommend it. You need to copy this. Technically, if you forget it or you lose it, you can reset the root password. It's just another set of steps and complications. So copy this, save it. Okay, we're now done installing it. I'm going to move it to the trash. So we're done with the install, but that's the easy part, just a couple of clicks. Now we need to do a couple things. The first is start up the server. So to do that, we go to System Preferences, and it should be down here. There should be a new icon somewhere, at least depending on how you have yours set up. For me, it's the bottom left, MySQL. I'll click on that, and we should see MySQL server status, blah, blah, blah. The server instance is currently stopped. There's a button to click to start it, which will start it. And then there's also this checkbox, which I'll address now. Depending on what you want, you can have MySQL server start up every time you start your computer. I'm not going to do that. You have to type your password again. I have like 6 or 7 database servers on here, and I just don't want any of them to start up on this machine, at least. This is not my developer machine. This is what I use for teaching. Totally up to you. Just depends on how you're using it. But if you're just learning MySQL now, it might actually be good to leave that on so you don't have to continually start it. But either way, it's not that hard to start. It's just a button here, which we'll click now. And there we go. If you didn't click this or uncheck this, you may have to type your password when you click that the first time. Okay, so now what we have left to do is open up our terminal and start interacting with this. So I'm going to bring the font size up a bit. And theoretically, you should be able to type MySQL. But this is where we start running into issues. So I'm getting this command not found. And if you get this, again, this depends on how your Mac is set up in your developer environment. And this is where it's annoying. But for me, I'm using something called Z shell. I'm getting command not found. And that's because the MySQL command is not in my path. So what I need to do now, I'll open up my ./.zhrc file, and I'll paste this line in here just so you can see it. I'll include this in the instructions for this lecture. You can find this on anywhere online. It's a very common error when people type MySQL and you get command not found. In fact, if we just did that right now, I went to Google, you can see, depending on what version of OS X you're running, there's all sorts of replies that are basically exactly what I just did. In fact, that's where I got the line originally. It just depends on if you're using Bash, and if you are, then you can use a line like this. But essentially, there's all these possibilities depending on your environment, so I can't cover all of them here. But find the correct command for you to run, and that's only if you're getting command not found. All right, so we need to save this file, close it down, go back to terminal. Then the next thing, I'm just going to close the window and reopen it. Or you can quit terminal, or you can source your profile. Now what I need to do is try MySQL again. Okay, so now we have a different problem. And it's not a great problem, but this is the problem we should have. Access denied for user Colt Steele at localhost. Using password, no. The problem is, if you remember, well, first of all, this means that MySQL, the command is found, it's running, but we're getting a result now. And the problem is that I'm trying to start MySQL and I don't have permission. I need to log in as the root user. And remember, we saved that password. So I went and copied that password that we were told to save. It's on my clipboard now. I can paste it, but that won't do anything. What we need to do is run mysql-u space root-p and hit enter. And it should prompt you for the password. You can paste that in. And we're in. All right. So if you get this far, congratulations. Everything's working. If you didn't get to this point, it's likely because of a couple reasons. One is that you're still getting that command not found issue. That one is relatively easy to fix. The problem is you have to be comfortable using your command line and opening up hidden files like a bash profile or your zhrc file. The other problem you could run into is this permissions thing. And if you didn't save that password that I told you should save, but if you didn't, or you close the window accidentally, you can reset the root password. All you need to do is go online and Google it. There's a couple of posts online about it. Basically, what you do is you run mysql-u space root, and there's something called flush privileges, a command, and you can update your password with a new password. There's a couple things you can do like that. Basically, rather than me making a video for every possibility, it's much better if you just find it out online. And this is why I recommended that you use Cloud9. I promise they're not paying me. It's just that this is difficult, especially in an online setting. Okay, so you might think we could start running some MySQL code. Like if you tried, here's something we haven't actually seen yet, but if you tried this, or actually, how about show databases? So this would show us a list of databases, and if there are no databases, it should still show us something. But instead, we get this. You must reset your password using alter user statement before executing this statement. Okay, so our final hurdle here. What we need to do is, I have a command that I just had on my clipboard, but it looks like this. Alter user, in quotes, root at, and then in quotes, localhost, identified by, and then all you need to do is provide a password here, in quotes, that you would like to use for the root user for your MySQL install, or for this server instance. And so just type something. I'm just going to make mine password. There we go. And hit enter. Oh, with a semicolon. Now, if we get the query okay, things should be working. If I try my show databases command, this time we're in. I don't get this permissions problem. Phew. Okay, it worked out. So again, that command I'll also include in the instructions if you need to do that. It's just alter user root at localhost identified by password. Okay, so then the last thing is, if you want to close out, by the way, it's Command D, which we'll be covering all this. If you're going through the course for the very first time and this is how you decide to start, we'll actually go over these commands in the next section when we install everything, or once we have everything installed and we start talking about MySQL. But we need to be able to verify the install, so there's a couple commands. Okay, so now if I wanted to try logging in again, I shut it down. It's mysql-u root-p, and then it will ask me for my password, which I changed to password. So you'll type that. You won't actually see it, but if you type it correctly, you're in. Okay, so that is our journey to installing MySQL on a Mac. Great time. Hopefully, if you got to this point, you made it through and everything worked out. If not, if you're just starting this course off, I still highly recommend that you switch to using Cloud9. Avoid all of these issues and then come back to this when you feel more confident. Otherwise, if you absolutely have to use a Mac, we'll try our best to help you out. Anyways, moving on.
Warning. This video may contain extremely frustrating installation instructions and is for experienced developers only. It's advised that you install using Cloud9 to avoid needless pain and anger.
All right, if you're still here after the stern warning, I'll talk about how to install MySQL on Windows. Of course, remember, you will probably run into some sort of issue depending on your computer and what you have installed already. It can be difficult. So that's why I really recommend that you use Cloud9. Skip Windows until the end of the course. Okay, that's enough. I'm a broken record. Let's get started. So to install MySQL on a PC, we need to go to mysql.com and then click on the download section and then click on community. And under community, you can actually click on any of these. If you click on download, what it's going to suggest for you if you're a Windows user is that you actually use the MySQL installer rather than downloading things individually. Basically, it's a package that will help install a bunch of MySQL things all at once that you may or may not use, that you may or may not need. Make sure that you have the correct version selected depending on your architecture, then click download. And it looks like it starts downloading, but it actually doesn't. You have to click another button at the bottom, no thanks, just start my download. And then I'll fast forward through this. It takes a little bit to download depending on your internet, but then once it's done, all we want to do is open it up, run the installer. Okay, so then we have a couple options. We're going to select developer default and then click next. And then depending on what you have installed on your computer, you may need to actually install some other requirements. So I did here. So I basically had to go through a couple times, double click, click execute, wait for something else to go install, in this case Visual C++, and then I had to repeat that a couple of different times. Now that will probably be different for you and your machine. But then once that finishes, click on execute again, and this will actually start the installation process. So there's a bunch of components installing, but once they're complete, click next, and then we move on to configuration. And all we really care about is configuring the server. So we'll click next again, basically click next another time. We don't need to change anything. And further, another time, click next. Okay, so we're now at the point where we need to decide on a root password for MySQL. So you can decide on whatever you'd like. I just chose password, the word password. It's not a good password, but I wanted to make it simple, easy to remember. So you type it in twice, tells me that it's weak. And then I'm also going to add a user here. You don't have to do this. I'm just going to make one with the name Colt, and also the password will be password. And then confirm the password, also tells me that it's weak, and I'll click OK. So really all that you need to do is remember whatever password you typed for the root, and then click next, and then we'll click next one more time, and then finally again we'll click execute, and it will start to apply the configuration, and it may take a moment or two, but then once it finishes, everything should be installed. So we'll click finish and then get out of here. So that's how we install. The next important thing is starting up the command line client, which you can find just under MySQL command line client. Click on it, and then you'll need to enter your root password, which in my case was password. And now we're able to actually type some code, something like show databases, which we haven't talked about, but you can type code in there. You can also try typing things that aren't SQL, and you'll see you get error messages, but all that we really need to care about is that we have the command line client up and running, and we can type stuff into it. Hey there, it's me again. It's time for yet another one of these videos. This time we are diving into section 3, a really important section. And yes, you could probably say that about everything in this course, but this is where we really get going. It's really crucial. In the last section, it's true, we did run our first MySQL commands, but if we're being honest, they're a little bit underwhelming, kind of lame, they didn't do much. In this section, that actually changes. We see our first commands around data. So we'll be able to make a new database or delete a database, and then inside of those databases, we'll start working with tables, which are kind of the fundamental structure in all of SQL and MySQL. So really important stuff. And by the end of the section, well, actually throughout the entire section are sprinkled a bunch of exercises around commands that we'll learn, things like creating databases, using and switching to databases, and then creating tables and describing tables. So a bunch of challenges coming up. But like I said, this is a really important turning point where we actually get past all the garbage around setting stuff up, installing. Now we're actually doing real MySQL stuff. So let's get going. Okay, so in this video, we're going to talk about how you actually create new databases in MySQL, finally. So before we go into the code, let's set the stage just a little bit. Currently, we have a MySQL database server represented by this box that's running on our Cloud9 instance. So that's what happened when we did the MySQL-CTL start. That started up the database server. So now the command that I'm going to show you is what allows us to create individual databases inside of the MySQL database server. So hypothetically, we could have a database for a dog walking app, another one for a soap shop. We could have a practice database if you were just practicing some new code, some new lines of SQL you wanted to try out. And maybe there's a news site database, and they're all hosted, they're all part of the same database server, but they're individual databases inside. And that's really important. And to understand why, let's zoom in a little bit on two of the databases, our dog walking app database and a soap shop database. So inside of those two databases, we'll store various entities or different data. So in the dog walking database, we'll probably need to store information about dogs. And in our soap shop database, we'll need to store something about soaps. And then here's where it gets really important. Our dog walking app likely has users, but so does our soap shop app. And our dog walking app has payments, and so does our soap shop app. So they have to be separated. If we just had one database that everything was using on this server, there would be a lot of crossover and there would be issues. What if you had somebody who had the same name who used your dog walking app and they also used the soap shop app, and the streams got crossed, if you will? That's problematic. So what we're going to learn now is how to create these individual walled off databases inside of the MySQL server we have running. Okay, so let's take a look at some code. This first line here, we've already seen before. All that it does is list the current databases that exist in the MySQL server. So when we do it right now, I need to start up MySQL, CTL, CLI, and I type show databases. We get this list of the 5 pre-existing ones that we have nothing to do with. We didn't create these manually. The next piece of code is create database, followed by the name of the database you'd like to create. So in this course, whenever there's a variable, I'll use these brackets to signify that it's just a placeholder. So in this case, whatever the name of your database is, and then a semicolon. So to make a database for our soap store, we might name it soap_store. Or for our dog app, we could use dog app, and you don't have to use underscores. You can capitalize things if you would like. There's no rules governing that exactly. However, if you did something like this, while it can work, it's just not a good idea to do it. So that gets X'd out. I don't recommend doing it. Actually, my recommendation is to stick with this here, what's called snake case. Everything's lowercase and just use underscores instead of spaces. But it's totally up to you. Like I said, there's not a hard rule. And what's more important is that you are just consistent. So whatever you choose, just make sure that you continue to use that just to avoid any confusion. So let's hop over to our terminal and give it a shot. So I'm going to just make my first database, and I will call it Hello World DB. And remember that semicolon. And if we wanted to make sure that it worked, we can just run that show databases command again. And now you'll see a new addition, Hello World DB. A note about capitalization. When I wrote create database, yes, you can get away with doing create database. Hello, and let's call this one testing DB. That works just fine. So whenever you see those capitalized letters in SQL commands, you do not have to use them. But I like to use them, and a lot of people like to use them just to signify what comes from SQL and then what is a custom name. So in this case, testing DB is something I wrote, or Hello World DB is a database name or a table name down the line, or a column name once we get there. And we can tell that because it's not capitalized. And then create database is in all caps. It tells us that's just regular old SQL. Okay, so that's pretty much it to creating a database. That doesn't really give us very much, but we've basically made a space on the server where we can add data. We just don't know how to do that yet. So we've just partitioned off a little area and we've given it a name of Hello World DB, or in our second example, testing DB. So we've seen how to create a database, and the natural next step is to see how to delete one. It's pretty simple. The command is drop database, and then whatever the name of the database is that you're looking to delete. So we'll come across this term drop here a couple of times in the course. It's basically the SQL version of delete, and we'll be able to use it to drop things other than just a database. We'll be able to delete tables, for instance, once we get there. So let's try it out. Back in Cloud 9, when I ran show databases, here are 2 that I created. I'm not going to delete any of the pre-existing ones. I just don't want to mess with that. So we will delete both of these though, Hello World DB and testing DB. So let's do that now. Drop database, Hello World DB, semicolon. And you can tell that it works, first of all, because it said query OK. But then also, if I recall show databases, this time hello world DB is gone. Let's do the same thing, drop database for testing DB. This time I'm going to leave off a semicolon, not because it's a good idea, but just to remind you that your code will not execute until you add that in there. It doesn't matter that it's on a separate line. We'll be writing multi-line queries just a little bit. What does matter is that it's there at all. It's what indicates that you're done and that it should run. So we can just double check that it worked. Now our testing DB is gone as well. So that's all there is to dropping a database. Pretty straightforward command. All right, so we saw how we can create databases and destroy them. So what comes next? We're going to see how we actually use them. And I mean that in a very literal sense. In MySQL, there is a use command. And what this does is it tells MySQL which database we want to be working with. So we have potentially 10 different databases on one MySQL server, and we want to search some data from one of them. Well, we need to tell MySQL which one we want to be using at any given time. And we can switch between them using the use command that you see right here. So I'll really quickly show you how it works over in Cloud9. So if we create a new database, and we'll just call this one dog walking app, and we hit enter. We do show databases. There it is. And if I want to use that, all I have to do is type use dog walking app. And you won't see much except for database changed. That's a good thing. But if we wanted to know for sure what database we are currently using, there's another MySQL command that we can use. And that command looks like this: select database with parentheses after it. And what this will do is tell you the currently used database. So let's try that out. Back in Cloud9, if I type select database with those parentheses and a semicolon, it tells me database is dog walking app. And if I decided to delete that database, I would use the drop database dog walking app command. It tells me query OK. I do show databases and it should be gone. But if I do my select database command, pause and think to yourself for a moment, what database do you think I'll be using right now? We were using the dog walking app, but then we deleted it. So now what? And here's the answer. Kind of a trick question. We're not using a database right now, hence the null here. And we'll be talking a bit more about null throughout this course, but that basically means we're not using any database. So just to show you one more time, if we switch, let's say I wanted to use one of these pre-existing ones like the C9 database. I'm not going to delete that, but if I wanted to, I just use C9. And now if I do my select database, it tells me database is C9. Okay, so that's all there is to using a database, and then also this select database command to see your current database. Next up, we'll start talking about tables and putting some data in these databases as soon as possible. So the next couple of videos are all about tables, which are the most important part of SQL. They are the true heart of using SQL. And in this first video, we'll start off by setting the stage, or setting the table, if you will let me get away with that, for how they work, what they are, and then we'll dive into data types next, and then we'll actually create tables and see the code that you use to create them. So let's get started. The first thing you should know is that a database is just a bunch of tables. So we've already created a couple of empty databases and deleted them as well, but what goes in them are just a bunch of tables. That's where the data is stored. As a short aside, this is in a relational database. So everything we're talking about that uses SQL, things like MySQL, Postgres, SQLite, those are relational databases, and they use tables. They use tabular data, but not every single database in the world does. And we'll see some examples of those later on. This course is not about those types of databases. but it helps to kind of bring them in to show you some contrast to what you're learning. So we'll see that later on. Just a short caveat there. So tables hold the data. That's my definition. If you want the boring Wikipedia definition, it looks like this. Tables are a collection of related data held in a structured format within a database. Hopefully you're still awake after that. But let's take a quick example using cats. So we're going to model some cats data using a table. Okay, so let's take a quick look at the cats table. Drum roll, please. Dum-da-da-dum. I know it's pretty hilarious. You're probably falling out of your chair. All right, so the real cats table, at least in this context, doesn't have an apostrophe, looks something like this. And of course, there's a million different ways we could break down the data for a cat, for modeling cats. In my case, I just went with name, breed, and age. So we could do plenty of other things like location, gender, is spayed, is neutered, that sort of thing. But just doing name, breed, and age. So I've put a couple of cats in here. We've got Blue, who's a Scottish fold, who's 1 year old. That's my cat. We've got Rocket, who is a Persian, who's 3 years old, totally made up. Monty, who's a tabby, who is 10 years old. That is my childhood cat. He's still kicking and biting people. We've got Sam, who is a munchkin. If you don't know what that breed is, look them up. They're pretty hilarious, although kind of sad. They have really stubby legs. Who is 5 years old. Also made that cat up. So, some terminology. When we're talking about tables and you hear the term columns, it's referring to the headers on that table. So what are the different components of data, the different pieces that have to be there? In our case, we have name, breed, and age. So those are the columns, and then the rows are the actual data in the table. So here's a row. Blue, the cat, is one row. Rocket is another row. Monty is another row. Sam is another row. I really wish those lined up correctly, but I just drove myself nuts trying to get it to work. Please forgive me. Anyways, so databases are made up of lots and lots of these tables. It's usually not just one. And if you have a really, really simple app and you're just storing one thing, then it will just be one. But usually apps are pretty complicated and data is complicated. All that we modeled there was cats, but imagine if this was actually an app. Let's say it was a pet sitting app and cats were one thing that we had to keep track of, but we also have to keep track of owners and the pet sitters and addresses and dates and appointments and payments, and those are all going to be tables. Some of them might even be multiple tables. But for now, we're not going to really worry too much about that. But just to show you, sometimes it does get crazy. You can click this link, or I'll click it, follow my own instructions, to see the breakdown of some of the tables that Facebook's database or a social network might use in their database. So this is not actual, this is not 100% accurate. There are things that are missing or incomplete, but this just shows all the different tables, or at least some of the different tables involved in a pretty complex app. So as you can see, there's a bunch of them here. Things like account and event and message and notification, website, screen name, address, blah, blah, blah. All these different things to take into consideration. So things can get messy. And as we progress in this course, you will start working with multiple tables. You'll see how they connect. But we haven't even seen how to create a single table yet. So we're going to focus just on individual tables, and then we'll move on from there. So the next thing we need to discuss around tables are data types. So data types are really, really important. And to show you what I mean, and first of all, what I'm talking about when I say data types, let's return back to our cats table. So we have these three headers, three columns: name, breed, and age. And here's an example. I changed some of the data just a little bit. So the names are the same, the breeds are the same. But if you look over at age, Blue is 1 year old, Rocket is 3, but Monty now is 10, the word 10. And Sam is crazy. Sam's age is I am young cat. So what I'm trying to illustrate here is that we have inconsistent data. This is all text in text, but here we've got numbers mixed with text, and that is not good, and it's actually not allowed in SQL at all. When you create a new table, you actually have to specify name has to be text, breed has to be text, age has to be a number. And there are a whole bunch of different data types. It's not just text and number. In fact, those aren't even data types. Those are just what I'm calling them, the English version, but you'll see them in just a second. But to illustrate why it's so important that your data matches, that you don't have this inconsistent data, and why SQL forces you to do this, here's a little example. So let's say that you have this data in your database in a cats table where hypothetically in a fictional world, you can have data that isn't all matching. So we have this, numeric data mixed with text under age. So let's say I wanted to make a really, really simple app that would take each cat's age in the database and then print out the converted or equivalent cat age. So from human years to cat years, basically, which is sort of interesting. Actually, in making these slides, I learned quite a bit about how you calculate cat age, because for dogs, there's this colloquialism, you can just multiply it by 7. For cats, it's a little more complex. Apparently, it's not linear. So if you look at this scale, when a cat is 2 months old, it's 3 years in human years. But then as they get to 2 years old, it's suddenly 24. And when they're 14, it's 72. So it's not consistent. So I just decided, you know what, let's just go with multiplying by 7. It really doesn't matter. So our app takes the age of Blue, multiplies by 7, no problem. Our app takes 3, multiplies that by 7, no problem. But it has no idea what to do here. Our code doesn't expect text, and it can't do the math. And same thing with I am young cat times 7. It doesn't even know what to do. It just freaks out. So really trivial, stupid example, I know. But the idea here is important, that we have to have these data types established and that MySQL will enforce them. So when we create tables, we have to say exactly what data type we're looking for, because this type of situation is really, really not good, also known as bad. So returning to our cats table, when we're creating it, we'll have to say, this must be text, breed must be text, and age must be a number. So in reality, there are a lot of different MySQL data types. Like I said, text and number are not real data types. In fact, there are a ton, in my opinion, too many, and it gets pretty confusing, especially when you're just starting out. It can be intimidating. Just to show you exactly what I'm talking about, I put together a list of all the different data types. So all the numeric types, basically the different ways of representing numbers. We've got ints, small ints, tiny int, medium int, big int, decimal, numeric, float, double, bit. Then under string types, so these are ways of representing text basically, char, varchar, binary, var binary, blob, tiny blob, medium blob, long blob, text, tiny text, medium text, long text, and then enum. And then finally, we've got date types, so different ways of representing dates. We've got date, date time, timestamp, time, and year. So yeah, it's kind of crazy, I know. Fortunately, you don't have to know all of those at any given time. Absolutely not. I had to spend a decent amount of time even digging through the documentation just to find all of these, because the reality is you don't use them most of the time, or you don't use all of them. You figure out which ones you need depending on a given situation. You use a subset normally that you're comfortable with, and then eventually you may have to switch things out and change from using a medium int to a big int, or actually more realistically an int to a big int or something like that. But we'll get there. For now, we're going to accept that it's crazy, and we're just going to whittle it down and focus on 2. The first one is int for our numeric type, and then varchar for our string type. So to represent numbers, we're working with int, and then to represent text and strings, we'll work with varchar. So we'll start off with int. So int represents a whole number, so we can't use it for decimals. And it ranges up to this gigantic number here. Basically, it's big. However, if you need to store numbers larger than that, that's when you can start looking into some of these other data types, but like big int. But we're not going to worry about that, because for now, we're storing things like cat age. So this is an int. Here's another int. It can be negative, or 0, or big, or 42. So that's pretty much it to ints. Then varchar is a way of representing text or strings, and it's variable length. So you may have noticed that there was char on there and varchar. Well, char is a fixed length. So that means that everything in that column has to be the same length. It has to be 10 characters or something. But varchar allows us to have a variation in that, which is what we want most of the time. And it's between 1 and 255 characters. So things like coffee or negative 9,999, the string in quotes. So it's not a number. Or this, whatever this is. Or capital L. Or a sentence, as long as it's fewer than 255 characters. So returning to our cats table, we would say that name, which must be text, would be varchar. And notice that I have these parentheses here and a number inside. So when you use varchar, you have to specify a maximum length. So in my case, I chose 100. I could go up to 255, but I just don't want to have any giant names. But that's all that it does here. So it specifies where the cutoff point is. And if I go beyond 100 characters, if I write 300 or 200 characters, all that will be stored is from the first character to the 100th character. So breed, I did the same thing. It's varchar, and I did 100 again, but that could change. If we wanted to restrict breeds to be shorter, we could change it to be 50 characters. And then for age, which must be a number, we just use int. We're just working with whole numbers. We're not going to worry about my cat is 1.2 years old or anything like that. Okay, so that's all we're going to do for now with data types. Basically, a high-level overview, and we saw two of them in particular, varchar and int. Next up, we have a really quick activity. So as I mentioned, we have a really quick activity now, and the point here is to get you thinking about data types and thinking in data types or in terms of data types. So what I'd like you to do is draw or write or just think about a tweets table. So modeling tweets. If you're not familiar with Twitter, that's going to be a tough one, I guess. But basically, there are three things I need you to, at least three things that I want you to model. And these are the columns. So a username. So when someone tweets, let's say I tweet and I don't actually use Twitter, but if I had an account and I called it Coffee Lover Cult, I mean, that's just terrible. But if I did, it would need to be maximum 15 characters long. So how do you specify that? What data type is it? Then the content of the tweet, so whatever the tweet is itself, can't be more than 140 characters. And then the number of people that have favorited that tweet, basically liked it or hearted it. So you don't have to draw it out, but if you want to draw it out in that tabular format and then fill in some fake data or even real tweet data that you find, go ahead and do that. But just think about what these data types are in terms of what we just learned. And there's really only two choices that we saw, so hopefully it's not too difficult. So we'll be right back with a solution. Okay, so let's start talking about the answer. So we had username, which was a maximum of 15 characters. That would be a varchar, and you would put 15 in the parentheses to specify that it's no more than 15 characters. Then we have content of the tweet, max of 140. It's very similar. It's also varchar, it's text, but this time we restrict it at 140 characters. Then we have favorites, which is just a number, so we use int. And then here's some mock data that I added if you want to take a look. We have cool guy who tweeted my first tweet, and as one person who liked it or favorited it. Then we have guitar queen who tweeted I love music, smiley face, how endearing. And we have 10 favorites on that. And then lonely heart, this sad guy or gal who tweeted still looking for love, and that has 0 favorites because nobody wants to be depressed. All right, so next up, we're going to see how to take these data types and actually tell SQL or MySQL how to implement a table using those data types. So now that we've learned how tables work and we've seen a little bit about data types, we finally get to start creating tables. So here is the magic syntax for creating a new table in MySQL. Here is the generic version. So it's create table, and then the name of the table, so cats or users or people or results or whatever it is, and then in parentheses, a column name, and then a space, and the data type. And there are a few other things that can come along with the data type, but for now we're just talking about data type. So a column name like age is an int, or address is a varchar, or varchar, however you want to pronounce it. So that's the main idea. And you keep listing these columns, as many as you need. It could just be 1, it could be 20, and you separate them by by commas. And then when you finish, you add your semicolon, and that's that. Now you don't have to format it this way on separate lines, but I think it's easiest to understand. It's definitely easier to read when you get much more complex ones, but you could do it all in a single line, just like anything else in MySQL. So here's an actual example using our cats table. So we're just working with name and age, create table cats. One thing I should point out is that table names should be pluralized. So it doesn't actually matter for the mechanics or behind the scenes, it won't change anything, but you want to just follow this convention. Use plural, because that's what a table describes, is multiple cats, or people instead of person, or payments instead of payment, and so on. Okay, so we have parentheses, and then we list our columns and their corresponding data types. So name will be a varchar with a 100 character limit, comma, age will be an integer. So let's hop over to Cloud9 and see if it worked. So the first thing I'll do is just make a new database. You don't have to do this if you're following along, but I'll just call one cat app. Oops, forgot my semicolon. Then we will use, okay. So now the next thing we'll do is create table cats. And then we can either do parentheses here, and that's what I usually do when I'm working in the MySQL command line, or in the shell, so you don't have to worry about spaces too much. So create table cats, and then we'll say name is varchar 100, comma, age is an int, and then we'll close our parenthesis with a semicolon. Query OK, 0 rows affected. Perfect. It appears to have worked, or at least we have to trust that it worked, because right now we don't have a way of testing that, but we will in the next video. Cliffhanger. So we left off by creating a new cats table, and it said query OK, but the question is, how do we know that it worked? How do we know that it did what we wanted it to do? So there's a couple of options. The first command I'll show you is pretty straightforward, show tables. Very similar to show databases, it just is going to show you the current tables in your database. So we can try that now in Cloud9. We'll do show tables, just like that. And it tells us tables in cat app, there's one called cats. So that's great, it tells us that there is a cats table, but that's pretty much it. It doesn't say anything about the contents of that table. What are the different columns in it? Which brings us to our next command, which is, again, using show columns from a table name. So in this case, we would say show columns from cats. So let's try it out now. And as you can see, we get some nice little table back here that says we've got two fields, name and age. Name is a varchar with 100 limit, and age is an integer. And don't worry about this 11 for now. Then we've got some other data that we're also not going to worry about, because we're going to talk quite a bit about it in the next section. But there are some other categories here that we're just going to ignore. But this is what we want. Name, varchar, age, int. Perfect. One other thing I'll show you is that you can use a shorter version. Technically, these are slightly different commands, but used in this context, there is no difference. So we can use describe, or DESC, a table name, and that's my preference. It's shorter, easier to remember. So let's try that out. Describe cats. You can see we get the exact same printout. So I did say that you could use them differently in a more advanced setting, where you can basically pass in some other things to describe. So anyways, it doesn't really matter, but I just want you to know they're not exactly identical. It's not like one is a shortcut for the other, but they do the same thing in this context. All right, so this video was pretty quick. It was just about kind of testing and making sure that when you create a table, it's created accurately and that you can, one, tell that the table is there using show tables, but more importantly, see the actual columns in that table using these two commands. Okay, so the last little bit of syntax we'll learn in this section has to do with deleting tables. We've seen how to create tables. We've seen how to describe or show their columns. We haven't seen how to put anything in those tables yet. That's coming up next in the next section. But the last thing we'll do is see how we delete them. So think to yourself for a moment, what's your guess about how you delete a table? My hint is that it's pretty similar to how we've seen how to delete something else before in MySQL. Okay, so think about that, and I'll just wait here for a second, I guess. Maybe make a coffee. All right, so the magic is drop table and then the table name. So rather than drop database, we're going to say drop table and then cats in our case. So just to prove to you that that works, let's give it a shot. Back in Cloud9, I will type drop table cats. And this is permanent, it's going to disappear. It tells us query OK. To make sure that it's actually gone, we could use a couple of different things. It's up to you. We can do show tables. Oops. And it tells us empty set. There are no tables here. Whereas before, when we did that, we got data. And if we try to describe cats now, we get an error because cats no longer exists. So it can't even show us the columns because it doesn't exist. So that's all there is to dropping or deleting a table. Very similar to dropping a database. So to close out this section here, we're going to get a little practice with data types and the syntax for creating and deleting tables. So one more activity. This time, I'd like you to imagine that you work at a pastry shop. So you're going to manage, and I manage in air quotes that you can't see me doing right now, but you're going to manage a pastry shop in the inventory for these pastries. It's going to be very simplistic, but you'll need to create a pastries table. And there should be at least two columns. If you want to add more, that's fine. But a name for the pastry, so what is it, a croissant, a chocolate donut, whatever it is, as well as a quantity, which should be a number. So I could go in and see that there are 10 croissants or 5 chocolate croissants and so on. But we won't fill it with data because we haven't seen how to do that. So we're just defining the table and the columns. So I'd like you to do that. Then use a command to inspect your table and the columns using the MySQL command line interface. So one of those short little commands we saw, just to make sure, basically to check your work. And then lastly, delete all that hard work, delete your table. So pause the video if you'd like, go through this and come back when you're done. And I'll be here. Okay, so I'm back in Cloud9. I'm actually still, if I select database, I'm still using cat app. There are no tables in it right now because I deleted the cats table, but I'm just going to put our pastries table in here, even though it has nothing to do with cat app. Maybe it's a cat bakery or something. I've seen dog bakeries, so maybe we're not too far off. But anyways, it's just a silly exercise. So we want to create a table. So create table, and then the name of the table will be pastries, plural. Then in parentheses, and I'm going to do it on one line just to show you that it's not a problem. So we'll have the name of the pastry. And one thing that you may be tempted to do if you come from some other databases is to put a colon there. That's something I find myself doing, just from experience that I have with some other tools. But you don't want that there. So if you see me doing that, hopefully I catch myself. Create table pastries. Name is going to be a varchar. And it should be 50 characters maximum. So in parentheses, 50. And then we have age, we have quantity. And if you wanted to abbreviate that with just QTY, which is what you'll see pretty commonly, you could do that as well. And that's just an integer. Then we need our semicolon to end it. We hit enter, and we have a nice little error message. So that was accidental. I'm not going to try and play it off like I did it on purpose. But I am going to leave it in here. And that's mainly because it's something that pops up pretty commonly. People aren't perfect, at least I'm not, especially when I'm recording. Got a lot of stuff to worry about. Can you identify what went wrong. I'll give you a hint, I'm just missing one character. Yep, if you got it, I am missing a comma here. And the error messages aren't always that useful, but it tells me there's an error in my syntax, and it's something near quantity int. So right before that, I'm missing a comma. And it's treating all of this as name, which is wrong. We need that comma there. So we can recall the line, go back, and insert our comma. Now when we do it, we get query OK, and we'll move on to the next part, which was to make sure things worked. So we could either do show tables, and then we can do show, let's do describe pastries. Perfect. Name, varchar, quantity is an int. And the last thing was to drop our pastries table. Drop table pastries. Goodbye pastries. And just to verify it worked, let's do show tables again, and there's nothing here. Perfect. So the next section is all going to be about inserting data. We make tables, they're empty. How do we get stuff in there? Hey, welcome to the next section. So let's recap what we just saw in the last section. We basically saw how to make databases and then how to create tables, which are currently empty, which are represented by this box here. Let's say this is a cats table. It's empty, it has no data in it. But in this section, I'm going to show you the tools to insert data into the cats table. Thank you, Blue. That was perfect. So we'll see how to do that. It's a insert command. So we'll see that and get lots of practice, lots of exercises inserting data into tables. And then the other thing we're going to see in this section, it's not the primary focus, but it's important, is selecting data back out. And I won't remove Blue from the box just yet. She's very paranoid. She loves this box. But the idea is, rather than deleting things, that's for another time, another section, how can we retrieve it out? How can we read it or search? So let's say insert, 10 cats into a box, and they all have different birthdays and breeds and names. I want to be able to run code like select or retrieve the last 5 cats added, or retrieve the names of the Russian blue cats, or retrieve the names of the last, the oldest cat in your database, something like that. Wow, she's having a lot of fun in there. So that will be the goal in this section, is to show you those two commands, inserting data and then retrieving it back out. I'm just going to leave her in there. I can't stand to take her out. All right, well, I'll end it there. Blue's enjoying her box. I'm enjoying whatever this is. Next up, we're going to focus our time on learning to create data. How do we add or insert data into the tables that we've already made? This is another one of the most important and most commonly used commands when you're working with databases. Obviously, it's really important to have a way to get your data in the database. So we'll be using what we learn here throughout the rest of the course. And you could say that for everything else that we've learned so far, but in particular, this command, insert, or insert into. So the syntax here is insert into, and then the name of the table, cats in our case, and then it gets a little weird after that. So let's just focus on that first. Insert into, and then the table name. Then afterwards, in parentheses, we're specifying the columns that we are going to insert. So I'm saying I'm going to give you a name, comma, I'm going to give you an age. And then down here, I have values, which is another keyword, specifying that, okay, I told you I'm giving you a name and an age, here they are. The name is Jetson, and the age is 7. So these do need to match. Name is first, Jetson, age is second, 7. Before we go try it out in Cloud9, I just want to show you that I wrote it this way mainly because it looks best on a slide. You can do it on one line. So insert into cats, name and age, the values, Jetson and 7. Or you can do it like this. And this is actually a lot of people's preferred way of writing it. But this is a huge pain to enter into the shell this way, where you have to space things manually. But when we start working with individual SQL files, where we'll save our own code basically into these separate files in a text editor, and we can space them out how we want, this is definitely a preferable way. But we're going to work with this. I just like this when I'm presenting and when I'm teaching it. It's a mix of readability, but also it's not so laborious like this. Okay, and just to hit this point home, the order that we write these column names matters. So if I say insert into cats, and I say age is coming first and then name, I have to provide age first and then name. So it doesn't matter which order you use, but whatever you establish up here, you have to follow through with. Otherwise, it will try, if you had this reversed, it would try and assign Victoria to age and 12 to name. And that's going to be a problem because we have these strict data types where things are supposed to be numbers and strings. And so if we mix them up, it's problematic. Not to mention that it makes no sense. So let's give it a shot in Cloud 9. I'll make some space here. And the first thing we need to do is actually recreate a table, because right now I don't have a cats table. I deleted it because I showed you how delete works. So let's recreate that. Create table cats, and it's going to have name is a varchar 50, comma, age is going to be an int, just like that. Perfect. So now we'll use the insert into command we just learned. So we will insert a new cat, insert into cats, and I'll start with name and then age. And then I'll go to a new line. I don't have to, but I like to. Values. And the values we'll put in, let's say for name, let's work with my cat Blue, comma, and her age is somewhere between 1 and 2. We'll just leave it as 1. Semicolon, we'll hit enter. We get our query OK. This time it says 1 row affected. You may have noticed that everything else we've done so far has said 0 rows affected. And I think that's pretty self-explanatory. We haven't had any rows of data yet. So all of these commands have returned 0 rows affected. Now we actually have created something. We've added data to a table, and it says 1 row affected. And before we move on, let's insert one more cat here. And this time we'll switch up the order. Insert into cats, and I'll do it on one line, age, comma, name. And then our values, let's say the age for this cat will be 11, and the name will be Draco. All right. And we also get 1 row affected. So a next logical question might be, how do I see the data? How do I know that it's in there correctly? Basically the same thing that you might have asked when we saw how to create a table. How do we check our work? Well, we've created data in a table. How do we check our work? And we'll see that in the next video. Sorry for the cliffhanger. Okay, so we left off with a little cliffhanger, which was we've inserted data. How do we know that it actually worked? And the main reason I made this a separate video is that it gives me a few seconds, a separate opportunity to talk about one of the main dilemmas behind figuring out how to best teach this content, which is that pretty much everything in this course is related and interdependent, or a lot of it is. So here's an example. I'm talking about inserting data, but it's really not that great of a learning experience unless you know how to view data. But if I teach you to view data first without having you insert it, there's nothing to view, and so on. So my approach is to try and teach things in isolation, but then kind of bridge the gap and give sneak previews when necessary. So with all of that said, I come from the future here. With a SQL command, you won't actually learn officially until the next section. So for now, you can just copy this. We're not going to talk about really what it does or how it works until the next section. We'll dive a lot more into the select statement. But to view all of our data in any given table, select star from the table name. So select star from cats. And that's all I'm going to say about it for now. Our priority is still focusing on creating and inserting data. This is just going to help us check that it worked. So let's try it. We should have 2 cats in there. Select star from cats. And there we go. We've got name and age. We have Blue, who is 1, and Draco, who is 11. And remember, we inserted these in different orders. So we did name and then age for Blue, and then we did age followed by name for Draco. So that's all there is to this. We know that it works. There's a lot more to using the select command. Probably 30% of this course will be focused on selecting data and filtering it and sorting it and searching and all sorts of different ways of viewing data. But for now, this is a magic little shortcut. So another thing to know about the insert command is that you can use it to bulk insert data. So we can insert 10 different users at once, or we can eventually, once we get to it, we can update 10 different users at once or delete 10 or whatever it is. But for insert, the way that it works is that rather than just giving one set of values, like Charlie, who is 10, we just use a comma separated list. So we tack on a comma, and then we add another one, Sadie, who's 3, and then comma, Lazy Bear, who is 1. A note about the comma placement does not matter. You'll see it. I think what's more logical is actually to put it here at the end of the line, but often what you see is here. I think it makes it easier for you to just visually break things up and to see, okay, here's a new line and here's a new line, but really just a matter of preference. So don't pay too much attention to that. Don't pay any attention to that, actually. What's important is that we have a list, and we can multiple insert all at once. So let's try it. So we have our cats table with Blue and Draco. We will do an insert into cats, and we'll do name followed by age. Now we have values, and our first pair, or our first set of values will be, oh boy, this is the hardest part of teaching this stuff, coming up with the fake data. Let's say Peanut, and Peanut is 2, and comma, you could have put the comma there, doesn't matter. Let's say the next one will be called Butter, who is 4. Yes, I am looking at a thing of peanut butter in my kitchen right now. So that's where that comes from. And lastly, let's do, sure, Jelly, who is 7. Just like that, we need our semicolon to end it. Now we get something slightly new. Query OK, 3 rows affected. Awesome. So to check our work, we can just do select star from cats again. And I should be consistent. It doesn't matter, but I'll capitalize the from. Now we have Blue, Draco, which were there before, Peanut, Butter, and Jelly. That turned out nicely. And we inserted them all with one command. So later on in the course, when we start working with some more complicated data, what I'll actually do is give you a file that has an insert statement that will insert, let's say, 20 different items into a database, 20 rows. And you'll be able to run that one line and get kind of starter data that you can use. It'll be an easy way to populate your database with data without having to do it manually 20 times. Okay, so that's all there is to multiple inserts. All right, so it's now your turn to give this a try. You're going to get some practice using the insert command. So we'll be working with people this time. You're going to create a new people table. So actually, this is going to combine both creating tables and inserting data. So the table you'll need to define will have 3 columns. First name that has a 20 character limit, last name also has a 20 character limit, and age, which is a number. So once you've defined that table, the next step is to insert your first person. And for this person, her first name is Tina, her last name is Belcher, and her age is 13. So once you've inserted her, make sure that you've done it correctly. Use that select command to see what's happening. Make sure she's in there. The next person will be Bob Belcher, who is 42. And it's up to you, but I would like for you to try and insert this one using a different order for the values. So if you had said first name, comma, last name, comma, age in the previous one, maybe try last name, comma, age, comma, first name. It doesn't make a lot of sense to do it that way, but give it a shot just to prove that you understand that the order matters. And then lastly, write one insert that will insert 3 different people at once. And that will be Linda Belcher, who's 45, Philip Frond, who is 38, and Calvin Fischoder, who is 70. So insert all 3 of those at once and go ahead and give it a shot. And in the next video, we'll have a solution. Okay, let's take a look at a potential solution for this people problem. So first thing, we need to create the table. using the create table statement with first name as a varchar 20, last name varchar with a 20 character limit, and age as an int. So let's do that. I'm just working in the cat app for now. It's fine. We're going to delete this at the end. So we'll start off with the create table, and we'll call it people. And the first thing that we'll have is first name, which is varchar 20. Next thing is last name, which is the exact same. And then finally, we have age, which is an int. And then our closing parenthesis. Okay, let's just double check it worked. Let's use describe people. Cool. First name, last name, age, varchar, int. Perfect. So now we're going to insert our first person, Tina Belcher, who is 13. So insert into people. And we'll start off. Let's do first name, last name, age, and then values. And we'll do, Tina Belcher. It was 13, right? Okay. We hit enter. Just double check that it worked. Select star from people. There, Tina is perfect. Now we're going to insert our second person, Bob Belcher, who is 42, and my instruction here was do it in a different order. So we'll do an insert into people. This time, let's do age, last name, first name. Values. So age was, I already forgot, 42. Last name is Belcher. And first name is Bob. Don't forget our semicolon. Let's do our select again. Perfect. It worked out how it was supposed to. Great. So then the last insert we're going to do is a multiple insert. We have Linda Belcher, Philip Frond, and Calvin Fischoder. Oh boy, this is going to be a lot to remember. Let's start off by just typing out the basics. Insert into people. And we'll do this one with first name, then last name, and then finally age, just like that. Then we'll do values. And we'll start off with Linda Belcher, who is 45, I think it was. And I'll do commas on the new line. And then we'll go with Philip Frond, and he is 45. No, 38. I made this too hard. Lastly, we have Calvin Fischoder. I'm just going to copy Fischoder, who is 70. Calvin Fischoder, 70. Alrighty. And before I forget, we need a semicolon. Perfect. Let's do our select star again. Have to use the up arrow a couple times. And we have Linda, Philip, and Calvin, Belcher, Frond, Fischoder, 45, 38, 70. Perfect. So that's it. And I didn't specify this in the instructions, but let's go ahead and delete the table. So that's drop table people. Goodbye to the Belchers and the other two. And we verify that it's gone. If you tried to do select star from people, we get an error. But if we do show tables, now we only have cats. All the people are gone, just left with cats. Now this video is going to be a slight departure. We're still working with inserting data, but it's a slight side note, which has to do with something called warnings. So to illustrate what I'm describing here, if we tried to insert something that looks like this, so we're going back to cats, and our cats have a name and an age. If we tried to insert a cat whose name is this gigantic string.
This is a cat named Charlie, which is also a human name. In fact, I know a couple of Charlies. Fun fact.
If we're trying to put that as this cat's name, and age is just 10, if we do that, let's go ahead and copy this just so I don't have to type that. Make sure we have our cats table. Let's do describe cats. Okay, so name and age. Remember there's this restriction here of 50. I'm just going to paste that and put a semicolon. I get something that says query OK, 1 row affected, 1 warning. Just to double down on that, I pulled it out into a separate slide. 1 warning. Oh my gosh, what's going on? Well, if we wanted to know what that warning was, we can use this command, show warnings. So we'll go back and type show warnings. And I want you to pause and think, what is the warning? If you were to guess, obviously we haven't talked about it yet, but what do you think I'll see? And the answer is I get a warning here that says data truncated for column name. So that corresponds to name here, which had a limit of 50 characters. And this is more than 50 characters. I can't remember how much it is, but it's more than 50. And if we look at cats, you'll see that first of all, our table gets a little messed up here, but the string for name gets cut off after this cat is named Charlie, which is also A, and then the rest is gone. So it's not like it's hidden and it's not displaying, it's just not stored at all. So that's important to note. So that's one warning that we saw there, and that happened when our data was truncated. Can you think of another warning we could generate deliberately? What's something we could do that would give us a warning? So pause the video, or don't, but try and come up with something based off of what we have currently set up for cats. How could we insert something that would give us a warning? All right, so what I was imagining is that we could try to insert something where we mixed up a data type. So let's say age, instead of being an integer, we passed in some text, random gibberish. That should generate a warning. So let's try it now. Insert into cats. We'll do name first and then age. And name will just be Lima, why not? But age will be gibberish, like that, which is not a valid integer value. We'll hit enter. We get one warning. And we can view that warning with show warnings. And this time, it's a different warning. It says incorrect integer value. So the last one we saw said that name was truncated. It was too long. This one is telling us that incorrect integer value for column age. So then here's a second thing for you to think about. And you probably, you'll just have to guess, but what do you think is stored inside of age? Any ideas? Well, if we do a select star from cats, we can see we have Lima, whose age is 0. So in this case, if we screw something up, if we pass in some invalid data or a string instead of number, it will automatically set age to be 0. In a little bit, we'll see ways of changing that default. But for now, it's 0. Okay, so that's it for warnings at this point. Just be aware that if you do see one warning or two warnings or however many warnings after a query, type show warnings and you'll be able to see your answer. However, actually, I forgot to mention this. If we do something invalid, so let's do the same thing, but instead of Lima, I'll call the cat Cusco. I can't remember if there's a Z in that. I don't know. Well, we'll assume that there is. So Cusco, with this crazy gibberish, should give us a warning. But if I do something in between, like select star from cats, and now I do show warnings, nothing. Our warning set is empty. So this is just something to be aware of. With that said, when you're creating applications using MySQL, that application, whatever you're using, let's say we're using JavaScript or Ruby, that will have ways of handling these warnings and letting you know. But when you're working in the shell like this, you have to use the show warnings command. All right, that's all there is to warnings. In this video, we're going to answer a simple question. Back when we typed describe table names, or describe cats, what's up with this part? What is this null column here in this little table? And why is there 2 yeses for name and age? So this video is all about null, the concept of null, and working with null in SQL. So to start off, let's talk about what null means. Null basically means that the value is unknown. It's SQL's way of saying, I don't know what this is, or there is no specified value. An important note is that it does not mean 0. Some people often think null means 0. It doesn't in this context. So to illustrate the significance of these having a yes here, it basically means that these are permitted to be null. It's okay if they have an unknown value. And that happens by default. To illustrate, though, that is the case, here's a little bit of code. Right now, we could run this command. We have a cats table with name and age, but we could do insert into cats and only specify a name. And in this case, I used Alabama. I'm not sure who names their cat Alabama, but you could probably say who names their cat Blue, which is what I named my cat. So we could run this command, and age has no specified value. So in fact, let's try it right now. Make some space. Insert into cats name, values. What is this siren? Alabama, just like that. We don't get any warnings or anything saying that name or that age is empty, nothing like that. Now if we do select star from cats, you'll see that we have a new cat whose name is Alabama, but age is null. And again, that's because we have null as a permitted value, or it's technically not a value, but age is allowed to be null. So is name. So I could do the same thing, or an even more extreme version. I could run this. Insert into cats, nothing. Values, nothing. And if I did that, take a moment to guess. Insert into cats, nothing. Values, nothing. What do you think will happen? Let's do a select star. Now we have cat null, or name null, age null. So then the question becomes, how do we prevent that? How do we require that name is not null and that age is not null? And the answer is not null. So what we can do is specify when we actually define a table that something, let's say a field like name, is not null. And we use this syntax right here. So here's an example. For a cats2 table, and I'll be using this convention cats2, cats3. So in a cats2 table, or 2.0 version, when we define it, we would say name is varchar. This time I used 100, but the limit doesn't matter really, followed by not null. So that means that it will not be permitted to be empty. And then age is also an integer, age is an integer who is also not null. So if we try that right now, I'm going to create a table, cats2, and we're going to have, and I'll do this on separate lines. Name is varchar 100. It's okay. This one you can have longer names. And then we'll have not null, followed by age is an int, also not null. We hit enter. Now let's start off by using describe cats2. This time, under null, for both fields, it says no. So that's one way to tell that these are not allowed to be null. And just to emphasize this, I made a slide. Notice the difference here. So now let's actually put it to the test. Let's try to insert into cats2. And this time we'll only do name and we'll leave off age. And then we'll have values. And name for this one will be Texas, in keeping with the state theme. Okay, what do you think will happen? Insert into cats where age is not allowed to be null, but we're not specifying age. So it says query OK. We didn't get an error message, and we got a warning. So let's do show warnings. Warning, field age doesn't have a default value. So what it's telling me is that I left age off. I didn't specify it. So what it was going to do is make it null, but then, oh no, it's not allowed to be null. So I need to go find a default value, and there's not a default value specified. So if we look, and you can probably guess our next video will be on default values. But if we do select star from cat2, you can see it automatically defined 0. So in the next video, we'll talk about why that happened. But the way that int works, if it's not allowed to be null, you don't have a default, it's going to be 0. Now let's try the same thing with insert into cats2, and this time only age is specified, and age will be 7. I get the same query OK, one warning, show warnings. This time it says field name doesn't have a default value. Let's do our select star. Notice what we get right here. Earlier, see how far back I can go, we had null when we didn't specify a name when we inserted into cats, just regular cats, not cats2. But now when I don't specify a name, it doesn't say null. And this is an empty string. So there's a difference. Null means that there is no value at all. We didn't specify. Empty string is just a type of a varchar that just has nothing in it. So you can think of it as this basically. Okay, so next we'll talk about how we specify these default values. Okay, so we're moving on. In this video, we're talking about default values. What's up with this part right here? Default. So as we talked about a little bit in the last video, it's helpful to be able to decide or to set default values. So if something is not specified, that there will be a fallback. And here's how we do it. We use default, so you can see both of these when we're defining a table. Default, and then we specify default. So for name, if you leave off name, I just said, okay, we'll call it unnamed or name to be determined. Sometimes if this is a cat shelter, in the real world, sometimes they decide on a name a little bit later once they figure out the cat's personality. And then for age, if this is more of a silly example, but if we wanted to, if we didn't specify age, we could always set it to be 99. Not sure why, but for the sake of this exercise, we're going to do that. So let's give it a shot, remaking a new cats table, cats3. Okay, here we go. So create table, cats3, and I'll do a new line here. And we will have name, varchar, let's do 20, even though my slides say 100, it's okay. Default, and our default will be, let's see, no name provided. How about that? It's important that whatever you put here matches this data type. So we couldn't say the default is the number 100. And then we'll have our comma, age, and age is an int. Default should be 99. Perfect. Close that. Now if we do our describe cats3, here we go. So we have default, no name provided, and default 99 for age. Awesome. Okay, so now let's give it a shot. Let's do insert into cats3, and I'll do age only and no name. And age will be, let's do 13, just like that. What do you think will happen? I'm going to insert a new cat into cats3, which is right here, only providing age. And name has a default value of no name provided. Okay, I did it. Now let's look, select star from cats3, and I get no name provided. Perfect. So we have a default value that's working great. We could do the same thing for age. Feel free to skip this if you feel like you know exactly what's going to happen. Let's leave both off this time. Insert into cats3, values. Now when we select, we have another unnamed cat, this time who is 99 years old by default. So the next thing that I want to talk about, here's another version of creating a table for cats4 this time. And I combined not null alongside default. Otherwise it's the same. So we have name, varchar, default is unnamed, age, int, default is 99, but I added in not null. And as I wrote here, you might be thinking, isn't this redundant? Because if we have a default value, it's already saying it won't be null. If we go back and we look at cats, regular cats, if we do an insert into cats, just like this, and if you can remember all the way back to cats, we have no default provided. And I do select star from cats, we get null, null. There's no default values. And then when we have our cats3, when I insert something like this right here, insert into cats3, it's totally empty. We have those defaults. So when I select star, from cats3, we get no name provided 99. So why would we want to add not null? And the answer is that we could still manually set something to be null. So if I did that here, let's do insert into cats3, and I'll do name and age, values, and I will say there's no name. All right, let's say name is, what's another state? Montana. It's not too bad for a cat's name. Great state, by the way. And we'll leave age as null, explicitly null, just like that. Let's do select star from cats3. And you can see that there was nothing stopping us from setting age to be null. All that we have is a default value. If you don't specify something, it will be 99. But you're allowed to say null. I'm allowed to say this is explicitly an empty value. Okay, so that's where this comes in. Name, varchar, not null, and a default. And I won't make you sit through me typing that whole thing, so I'll just copy it. But to walk through it again, same thing here. Same with the default, we just added not null and not null. So let's go ahead, paste this in. This is cats4. This time, if I do describe cats4, we now have null is no on both, and we have a default on both. So we're almost there, I know. It's been a little bit of a long video. Let's do a insert into cats4, and we will specify name and then age. And this time, if I do values, and I say name is, what's a new one? Let's do Cali, fine. Sort of a state name. And age is null. If I do this time we get an error. So not just a warning, but an error saying it cannot be null. And that's what not null specifies. So important to note that. You'll use not null pretty often. It's a way of basically requiring that something has a value, but also saying that it's not allowed to be null itself, which I also included as a slide here. In cats3, we can manually insert something as null. Okay, as you can see, the slide says we have one more thing, and that is true. We have one more thing to cover here before we do our final exercise in this section. So in keeping with this pattern, what's up with this key column here? And it's empty. There's nothing for name or age. What does this mean? So to dive into this, and this is actually something we are going to come back to quite a ways down the line in this course, but we'll experience working with key for the first time in this video. So to illustrate the problem, right now, I could do this. I could insert identical data, Monty 10, Monty 10, Monty 10, Monty 10, and so on. And we've already seen this, but just to prove that to you, if I just work with cats, let's do select star from cats, and this is true about any of the cats tables we have. You can actually already see we have two cats that are identical, null and null. But I could also do something like insert into cats, name, age, values, and this one will be called Helena, and Helena will be 6, or Helena, however you say it. We can do this, and we can do it as many times as we want, and there's going to be identical data in there. As you can see, we have 5 identical cats. So why should you care? Why is this really a problem? And there's a couple reasons, but it comes down to the fact that we want all of our data to be uniquely identifiable. Even if it looks the same like it does in this case, we assume that these are separate cats. If they are in fact one cat, then this is just in error. We don't want to have this many entries. But imagine we actually have 5 cats named Helena with an age of 6. They are unique and individual, and we want to be able to keep track of them. And right now we can't. There is no way to uniquely refer to this. So in a case like here, where we have Alabama, who is null, age null, and then we have null, who is age null, there's a way of telling these apart. Even though they both have age of null, I could tell SQL, and we don't know how to do this yet, but I could say, give me a cat whose age is null and whose name is Alabama. And that can get me this. But there's no way for me to get this cat and separate it from this cat, or this one and separate it from this one. And that's really a useful and important thing, and it's actually a really fundamental part of working with databases, is having things be identifiable. When you're signing up for an account on, let's say, Twitter, and you're trying to make a username, there's a reason that you can't just make the same username that already exists. I wish that I could just go and make my username Colt, but somebody already has that. And it's not just about keeping it simple and not being confusing for users, because obviously it would be confusing if there was, one Colt and then another Colt and they're both tweeting, how do you know who is who? But actually in the code, that's hugely problematic, because there's things like when I log in, I type my username and it's going to go to the database and try and find a user with username Colt, and then it's going to match my password. But if there's 2 users with username Colt, then what does it do? So in that case, you're not allowed to have separate usernames. But there are times when we have data that looks the same. Like hypothetically, we could have 2 cats named Helena, age 6. Or maybe a better example, we could have a couple of cats, if we go back here, where we have no name provided. They're unnamed, but they're unique, different cats. How do we know? And the easiest way, and what we'll do and what pretty much everyone does, is assign an ID, a unique identifier. So you can see here I added a new field, cat ID, and every cat is given one of these IDs. So now, rather than saying, I want to select Monty from this database and getting all of these, I can say, I want the cat with ID 1 or ID 3, and they are uniquely identifiable. All right, so there's a precise term for this, primary key. So a primary key just refers to something that is a unique identifier on a row. It's a way of identifying something, and you know that it will be unique. Just a heads up, we will see another type of key later on called foreign key. Those are both keys. Don't worry about it, but primary key just means that whatever field we assign, whatever we make the primary key, so in this case, we would make cat ID a primary key, means that it has to be unique. So let's see how we actually assign one. So I'm creating a new table here, and I know it's a little bit longer than what we've seen, but a lot of it is very, very similar. So we have unique cats. It's just the name of the table. I got tired of cats 1, 2, 3, 4. So unique cats. We have name and age, but we also have cat ID now. So cat ID is an integer, and we can't have cat ID be null. We definitely want there to be something there. And then this is the new and important piece. This is just another field. This isn't technically new conceptually, but this is primary key, and then we give it the name of a field. So we want the cat ID to be unique. We want it to be the unique identifier, so we just pass it in here, cat ID. So let's try this out. I'm just going to copy it over just to save you time, so you don't have to watch me type the whole thing. Here we go. Create table, unique cats, a cat ID, name, age, and by the way, that cat ID you talked about earlier is a primary key. All right, so now let's do describe unique cats. And you'll see a couple things. We have cat ID now, because we had this line here. But we also, under this key column, we have primary, or pri, but it means primary key. So cat ID is a primary key. So how do we know? Well, let's insert into cats, or unique cats. We'll do ID, name, and age, just like that. And then we'll do values. And we'll start off with an ID of 1. Name will be Fred. And age will be 1. Let's do 2. Fine, 23. Accept the typo. Okay, hit enter. Oh, we have a problem. I just referred to ID. It should be cat ID. Silly mistake. So let's fix that. Cat ID. Okay, so now just double check our work. From unique cats. Cat ID is 1. All right, so we could do the same thing. Change this to 2. And instead of Fred, let's have Louise, who is 2. 3. We hit enter. Same thing. I think you get where I'm going here. We can keep doing this. However, and this is where the primary key part comes in, I could now say insert into unique cats, cat ID, name, age. What if I tried to make another one with ID 1? And this one is called James. Just like that. I get a new error. Duplicate entry 1 for key primary. So this is saying, wait a second, you said it's a primary key. I cannot have a duplicate entry. You cannot have something. The whole point is that ID is supposed to be uniquely identifiable. Well, that's a problem. So it doesn't add it to the database. So that's really, really important. And IDs are not the only thing you can make primary keys. I gave that example of username, which is something we'll come back to later. You often want to make a username a primary key so that you can't have more than one account with the same username in your database. And so all that you would do is, instead of saying primary key, where's that? Cat ID, you would say primary key username, or whatever the name of the field is. And then if I tried to insert something with an already existing username, I would get the same error here. Okay, one more thing to talk about, which is it's kind of annoying to have to manually specify this ID. It's more than annoying, it's impractical. I mean, are you just supposed to know where you left off? 1, 2, 3, and every time you insert a cat, you just have to know what the last one was? It just doesn't really work. It's not even in this shell context, but especially not in a real application. You can't, and it's just a pain. So there's a way around it. Our code gets longer, I know, but all that's added here is this, auto increment. So it does what it sounds like. It will take cat ID, and it will automatically add 1 to it every time a new cat is created. So we no longer have to specify cat ID is 1, cat ID is 2. It will just do it. We just leave off cat ID entirely, and everything else here is the same. So cat, unique cats 2. I'm just going to copy this over, make some space, hit enter. And before I show you that it works, if we do describe unique cats 2, you'll notice that we also have auto increment here under extra. So it doesn't get its own field, but it's considered extra. So Now let's try and insert something into that. Insert into unique cats 2. And we'll do name and age. We don't specify cat ID anymore. Values. And let's see, seriously, the hardest part of all of this. Let's go with Skippy. Once again, I see some peanut butter in my kitchen. And age will be 4. Just like that. Now, if I do select star from unique cats 2, cat ID is automatically 1. And to prove to you that it's auto incrementing, let's change this name to GIF. And we select star again. And now we have 2. So this solves 2 problems. One is that it's annoying to have to manually type those IDs and keep track of what number we're on next. But also, I can now have duplicate cats as far as name and age, which is our whole goal from the get-go. So I can now do another GIF and another GIF again. And this time, let's do a Skippy as well. Now select star from unique cats 2. And you can see we have Skippy here who's 4 and Skippy here who's 4, but they have different IDs. Therefore, they are unique. Same thing with 3 GIFs. Perfect. Alrighty, so that concludes all the new stuff in this section. Now you're going to get a chance to put it in action, to actually practice it, and to write your own bit of code, create your own table that looks a little bit something like this. Okay. All right, so it's your turn to put some of this into practice with a single exercise. It should be pretty quick. All you need to do is define a single table. So here are the demands. Well, demand sounds a little strong. Here are the requirements. Define an employees table. So let's say we're a company trying to manage some employees. We'll definitely need more data than this to actually make it operational, but for now, this is all we need. 7 different fields, 7 columns, ID, last name, first name, and middle name, and then age and current status. And actually, I can't count. This is 6. So ID is relatively self-explanatory. It should be a number. I'm not telling you the data types, but you should know at this point what they are. So a number that automatically increments. It's mandatory, so it can't be left off, and it's a primary key. Last name and first name are both text, which isn't the data type. Again, you need to use the actual term, and then neither of them can be left blank either. They're mandatory. But middle name, while it's also text, it isn't mandatory because not everyone has a middle name, so we can leave that blank. Then we've got age, which is numeric, and it is mandatory, can't be blank. And finally, current status, which is essentially like their employment status, if they're employed or if they're fired. And it should be mandatory, so it can't be null. But if no status is provided when something is inserted, it should default to employed. So we'll have 2 statuses, employed and terminated, or fired or something. I guess terminated is more professional. And so it should just default to current status is employed if nothing is provided when it's inserted. Okay, so go ahead and define this table, type it out, try running it to make sure it works, and then try inserting some data as well to make sure that it works. Okay, if you want a solution, have it in the next video. All right, so if all you care about is the solution, just check out the code following this lecture or pause the video. You can see the solution here. But I'll go ahead and go through the process of typing this out very quickly. I'll kind of speed it up. So what I like to do is start by defining the rough skeleton of what we need in a SQL file. So we need a create table employees, and then within that we'll have ID, we'll have first name, we'll have last name, we'll have middle name, and then we have age and current status, just like that. And then we can fill in the data types. So we know ID is an integer and age is an integer. And then these are varchars, let's say 255. Somebody may have a giant name. And same for current status. So then the next thing that we could do is focus on ID, which we know needs to auto increment. And we also want it to be mandatory and a primary key. So mandatory means not null. And a primary key, there's actually 2 options. The first one is to do this. And the second one, just duplicate this, it's also in the slides, is to add it on the end here. We don't want that underscore there. There we go. So these will do the same thing. But of course, we're not done. So the next thing would be first name. And first name is just mandatory, as is last name. So we'll just add not null and not null. Middle name we can leave alone. Then we've got age, which is also mandatory. And then finally, current status, which is mandatory, but there's also a default value. So we want not null, default, employed. And then we need to make sure we have all of the correct commas here. Just like that. Add our semicolon as well. Copy it. And let's see what happens. All right, so it looks good. We can describe employees. And then if we wanted to, let's just do a single test insert to make sure our default value works and our auto increment works. So we'll do insert into employees, and we'll do first name, comma last name, comma age, and that's it, because everything else either has is allowed to be null or has a default value. And we'll insert someone with the name of Dora Smith, I guess. And let's say she is 58. Okay. Copy that, paste that in. Let's do a select star from employees, just like that. And it looks good. We've got an ID auto incrementing at 1, first name, last name, middle name is null because it's allowed to be, age is 58, and current status is employed because we didn't specify one and we have a default value. All right. So again, the other solution here is just to put primary key on the same line when you're defining the column. I prefer to do it that way, but you'll also see it done this way. Both work. All right, that's it. Hey, welcome back. If you're looking at my desk right now and you're asking, wow, why is there so much CRUD on it? Well, you're on to something. This section is all about CRUD. Yeah. So CRUD is an acronym. It stands for 4 things: C-R-U-D, create, read, update, and delete. And they are the 4 basic actions that we want to be able to do to our data. So we've actually seen 2 components already. We've seen how, let's say we're working with users. We've seen how to create users with the insert command. We've seen how to read users, take them back out, spill the milk out of the database. That is the read section, which we did with select. Now we also are going to review more about select and insert, but primarily we're going to see how to update and delete information. So how do we change something in our database if we made a mistake, or let's say a user changed their password. They clicked a forgot my password link and they want to reset it. We need to change it in the database. And then delete, let's say our user decides to leave our site for some really bad reason. We can delete him or her. So that's the focus of this section. We're going to have a ton of exercises because we're seeing a lot of commands. And now that we have those 4 commands in place, we'll be able to go do a lot of stuff. They're kind of the fundamental 4 things of any database or any data. So tons of challenges coming up. Look forward to that. And I'll see you basically in the next section when I have to do another one of these videos. See you in a bit. Alrighty. So in this section, we're going to focus on the basics of something called CRUD. So it's an acronym, C-R-U-D. And it stands for create, read, update, and delete, or destroy, some variation of that. The idea is that these are the 4 main operations that we perform on our data. We've already seen how to create data. When we have a database, we want to be able to add data in. We want to be able to search back or read it back out. We want to be able to update it, and then also to delete it. Those are the 4 most important and most common operations that we'll do. And CRUD itself, the acronym, is not particular to databases. It's common in other facets of programming and web development, but it's a nice acronym that fits what we are trying to do here. So what we're going to do is step through all 4 different operations. And we've already seen create. It should be review, hopefully, which we do using insert into. So going back to our cats, we have things like insert into cats, name and age, and then the values, taco and 14. So we won't spend any more time talking about create in this section, but we'll be using insert into throughout the rest of the course. But really what we're going to focus on here are the other three operations. So how do we read data out? How do we search? How do we find things? How do we update data if we made a mistake or something changes? And then how do we delete data? How do we delete everything from a table, and how do we delete one or two things at a time? So that's really what this section will focus on. And we'll kick it off by talking about reading data out. Okay, so before we see any new code or new commands, I want to clean up the data that we currently have. If you remember, we kind of added a bunch of different cats databases. We have cats and cats 1 and cats 2 and cats 3 and so on. What I want to do is delete the original cats table, and then we're going to remake it, but with a few additions, because our original cats table was the most basic. It only had name and age, but I want to add some other data in, like an ID that auto increments and so on. So basically, we're just going to remake the cats table and add new data in. So if you want to make a bit of an exercise out of this, the first step would be to delete the cats table. So do that now. And the command, if you want to see it, is drop table cats. So let's do it. Drop table cats. Whoops. There we go. And now that we've dropped the table, we want to recreate the table. So this is what we want here. We're going to have a cat ID, integer not null, auto increments. We're going to have a name, that's a varchar, a breed, that's varchar as well, an age that is an integer, and cat ID is our primary key. So if you'd like, go ahead and type that out, or just copy it, paste it in. Perfect. Of course, we could make sure it worked. Describe cats. There we go. All right, so the last step here is to add new data in. And I would like for you to have this same data because we're going to use it throughout this section. There'll be a couple of activities and questions, and it will be much easier if you have the same data as me. So we've got 1, 2, 3, 4, 5, 6, 7 cats. Each one has a name, a breed, and an age. Some of them, there's a couple of Maine Coons, a couple of Tabbies, and a couple that have the same age, which we will use in just a little bit. So copy this, or if you're a masochist, you can type it out, paste it in. Perfect. And now we have 7 cats in our database, 7 rows. Okay, so now we've prepped our data. We've deleted the original cats table, remade a new special cats table with some more interesting pieces of data, and then we've inserted data in there as well. Awesome. Next, we're going to move on to talking about searching or reading data out. So we're moving on to the R of CRUD, which is read. How do we retrieve and search data from a database? And we've actually already seen this. The magic command is select. So remember when we were doing this earlier, select star from cats? I told you not to worry about it too much because we'd spend more time on it. And it was really just something that we needed to have to check our work at that time when we were inserting data. But we didn't actually talk about how it works, what the star means. That's what we're going to do now. So the star in select star from cats means give me all the columns in the cats table. So we're asking for the cats table, that's the from cats, and in that table we just want everything that we have. So in our case, that means cat ID, name, age, and breed. We want all of them coming back to us. So let's do that now. Select star from cats. You can see we get cat ID, name, breed, and age. And we also get every single cat. No one is missing. These are the 7 that we inserted. So that's the basics of select star, which you'll use often just to check things out. But we can also get more specific about what data we want back, which is where the select expression comes in. Basically, there's a way for us to specify what columns we want in particular. I only want the ID, or I only want cats' names and age, but not the breed. So to do that, rather than saying select star, we can do things like select name from cats. And if we do that, select name from cats, what do you think the table will look like? It looks like this. We only get name. So it gives us all 7 names, but nothing else. We could also do select age from cats. And hopefully this is what you expected. We just get a bunch of ages. And just to hammer it home here, we could also do a select, let's do cat ID from cats. And we get 1, 2, 3, 4, 5, 6, 7. Okay, so that's useful enough, but oftentimes we want more than one piece of data, but we don't want everything. And that's where this comma separated list comes in. So this whole thing is the select expression. We're saying select name and age from cats. So we can try it now. Select name, comma, age from cats. And what do you think we'll see? So we get a table with name and age returned back. So there's no limit on that. We could do name, age, comma, cat ID, comma, breed, which would be the same thing as select star. We could do name, age, and breed, or cat ID and name and age, and so on. I think you get it. We can mix and match whatever fields we want back. So just to illustrate my point, let's do a select cat ID, comma, name, comma, age from cats. And we hit enter, and we get those 3 fields. Notice we're missing breed, but we could just go add that in if we wanted. And notice that the order matters. So I said cat ID, then name, then age, then breed. And that's what we get. But if I just did a select star, it uses the default order, which is cat ID, name, breed, and then age, which is just how we entered it when we created the table. So I could reverse it if I wanted to by select age, then breed, then name, then cat ID from cats. And there we go. Okay, so that's pretty much all there is to the select expression, for now at least, where we're just specifying exactly which columns we want, or we can default and use the star, which will give us all columns. Okay, so what we've seen so far allows us to specify what columns we want, name and age only or only ID, but it still gives us every single result in the table. So if we have 10,000 users in our database, if we wanted to select one, we don't have a way of doing that right now. We only can select all of them, which really is not that useful. And in fact, most of the time when you're selecting things, you're doing it deliberately and you're trying to find particular pieces. You're not just trying to check in on your table, make sure everything's okay. You're usually trying to, let's say, sign someone in if it's an application. You're trying to verify, find someone by their username and check if their password matches that they entered into your website. Or something like that, where you're searching for specific data. And to do that, we need to use what's known as the where clause. So it's another magic keyword, where, and it allows us to get specific. It allows us to say, I want all cats who are 4 years old, or I want all cats who are tabbies. And those are very simple examples, but later on, throughout this course, we'll continue to expand your arsenal for select and for searching. You'll be able to do things like, I want all cats that are tabbies between the age of 1 and 2 and whose name starts with the letter B, let's say. So we'll be able to get much more specific, but for now, we're focusing on the basics. And as a side note, I want to show you that we will use where all the time. So it's not just for searching or for selecting, but we'll need to use it when we're updating or deleting things as well, because unless we're trying to update every single thing or delete every single thing, usually we want to update something specific. So we might say, I want to update the cats where their age is 2 and I want to make their age 3. Versus I want to update every single cat to have an age of 3. We could be more targeted using where. So we're going to start by seeing how we use it to select. So here's an example. Select star from cats where age is 4. So notice the syntax here. We have our same select star from cats. That will give us all cats. But then we have this where age equals 4. So what this will do is only select the data from the cats table where the age column is equal to 4. And if we try that now, if we look at our data, actually, you'll see we have 2 cats, Ringo and Egg. who are both 4 years old. So if we do a select star from cats, you see what we get. But now if we modify that with our where age equals 4, semicolon, we only get those 2 results. So we still get cat ID, name, breed, and age because we use star. That tells us the columns. But now we only have 2 results because we used where to get specific. One note, notice that when I refer to age here, that is the column, age. So there's no quotes around it, it's just age. So we can do the same thing here, but this time I'm using name to drill down or to get specific. So select star from cats where name is equal to egg. And notice I use quotes here because it's no longer an integer like age is. Name is varchar, it's text, so we need those quotes. So we can try that now. Select star from cats where name equals egg. Just like that. And you notice we get egg. Cat ID, name, breed, and age. One side note while I'm here. You may come across this at some point. What do you think will happen if I fully capitalize egg? It still works. So it's important to note that by default, this is case insensitive. So I could do lowercase g, uppercase g, and it still gives me the same data. So we'll see ways around this later on. Oftentimes it is useful though to not worry about case if you're dealing with things like an email address where case doesn't actually matter. So if a user types in their email with a capital letter at the beginning versus lowercase, it should still be the same email in your database. But we'll talk about that later. I just wanted to point out that it's a thing, case insensitivity. So that's all there is for now to the where clause. Now there is a lot more that we will be seeing and working with. Like I mentioned at the beginning of this lesson, we will come back and use where all the time. And in fact, we're going to continue to use it for updating and deleting. Like I said, we need to specify what we want to delete and what we want to update. But I just want to make it clear we're not done with where. There's a lot of add-on functionality that we'll see in ensuing sections. Perfect. All right, so before we go any further, we have a couple of quick exercises that are just going to test you basically on what we just learned, select and where. So the first one, I'd like you to write the SQL that will select the following. And this is using our cats. So the same data that we already had, which is why I asked you to, hopefully you inserted the same cats. Basically, select all the cats, but only get their ID. And then the next thing I'd like you to do, of course, you can pause the video and do it, and then move on when you're ready to the next question, which is write the SQL that will select the following. Name and breed only. So we don't want ID, we don't want age, just name and breed in that order for all of the cats. All right. And the next one is a little bit more complicated. You'll need to combine both things we just learned, the select expression and the where clause. So in this case, you're going to only select the tabby cats. So the cats that have breed equal to tabby, and we only want name and age. And then finally, this is a little bit of a challenge because I didn't show exactly how to do this, but hopefully you'll be able to figure it out. We'll talk about it in the answer video either way, but hopefully it's not too difficult. In this case, what you're doing is selecting the instances where cat ID and age are the same. So if I go back to the data here, when I select all of them, if you look here, cat ID and age, they're not the same. 1 and 4, 2 and 10, but egg's cat ID is 4 and egg is 4 years old. And Jackson has an ID of 7 and is 7 years old. So how can you select just those two? And I don't want you to cheat. Don't select based off of their name or their breed or something. I want you to select where cat ID is the same as age. And we only want cat ID and age as well. Okay, solution video is coming up next. So let's see the answers here. Feel free to skip forward if you feel like you got them right. So the first one, write the SQL that selects the following. We only want the cat IDs, but we want all of the results, all the cats. So that will be select cat ID from cats. So we want all cats, but only the cat ID returned, and that's what we get. Next up, write the SQL query that selects the following. Name and breed for all cats. So it's similar to the last one, except we want name and breed from all cats. There we go, name and breed. Okay, so let's talk about the solution to this one here. We need to use both the select expression and the where clause. We want to select name and age from cats where breed equals tabby. So let's do that. Select name, comma, age from cats where breed equals tabby, just like that. And we get Ringo, who's 4, and Misty, who is 13, and that's exactly what we wanted to see. Now, the final one is a little trickier, as I mentioned. We didn't see exactly how to do this, but hopefully you were able to figure it out because it's exactly the same syntax, but we're just checking a slightly different where clause. So we'll start with the first part. We want to select cat ID and age. So that's a select cat ID, comma, age from cats where, and we want where cat ID is the same as age. So we've been doing things like where age equals 2, or we could do where cat ID equals 1, but we can also just do where cat ID equals age. Those are both going to be numbers, and MySQL is smart enough to figure that out. So it's going to compare cat ID and age and see where they're equal. As you can see, we get what we want, cat ID and age, and they're equal. So let's go back and revise this a bit and do a select star, just so you can see exactly what we're working with. We have Egg and Jackson, where age is 4, ID is 4, age is 7, and ID is 7. Okay, so in addition to having some practice there, we also learned that you can compare columns and the values rather than just picking an exact value like 4 or 10. We can compare two different columns and select based off of when they're equal to one another. All right, so one more thing we're going to talk about with reading data when we're talking about CRUD. Before we move on to updating and deleting, there's one other thing, which are aliases. These are really simple, very short video here. Basically, we can specify how our data should be displayed back to us. So what that means is rather than having cat ID, name, breed, and age here, I could tell MySQL that instead of breed, I want, type of cat. Or instead of age, I want years. And it won't alter the data itself. It just is how it's displayed to me. So let me show you a more specific example. Here we have using an alias. We're selecting the cat ID as ID. So rather than saying cat ID in the results, it will only say ID and then name from cats. Now this is not that clear why it's useful, and that won't become clear for a little bit because right now our data is very simple and straightforward. But once we have multiple tables and we're selecting from, let me give you an example. Let's say we have a pet shelter where we have a cat's table and a dog's table, and both of them have a name. So dogs have names, cats have names. And when we talk about join tables, which you'll learn about in a little bit, that's when we take both tables and we select from them at once and combine them. And the results, we would have two columns with name. So we would need to figure out which one is cat name, which one is dog name. So we could use this as to relabel it. So it wouldn't change the actual data. Our data is the same, the columns are the same. But when it's printed back out to us, when it spits out the data, it would use an alias. So if we try this now, cat ID as ID, comma name from cats, you'll see that we get ID here. And just to make that clear, I did the same thing, and I even put a little arrow pointing to that ID. It doesn't say cat ID, it says ID. So also just to prove this, we could do something like select name as cat name, or also just to show you, you can use quotes to add spaces. So cat name, like that, comma, we'll also select breed as kitty breed. Why not? From cats. And there you go. Our new column headers here are cat name and kitty breed. But of course, if we do a describe cats, you'll see nothing has changed. Our fields are still name and breed, just when we print them out. So that's all there is to aliases. You'll see us using them later on, but I wanted to introduce them now so that you're not overwhelmed with a bunch of new stuff when we get to join tables. Alrighty, so we've covered the C and the R in CRUD, create and read. Now we're moving on to the U, which stands for update. So how do we update or alter existing data in our database? We've inserted something and maybe we made a mistake. We want to change it, but it's not always a mistake. In our applications, let's say we have users, think about when you're updating your password. You forgot a password as a user, so you click the forget password link and you reset your password. Well, that needs to be changed in the database. Or you change your profile picture on Facebook, or you change your, relationship status or something. All of that requires updating. So how do we do it? And the answer is that we use probably the longest SQL command you've seen so far. There's multiple parts, but the key words are update, set, and where. So we've already seen where. This is where we tell MySQL which items in particular we want to select to update. So in this case, this entire line here is going to find in the cats table all the cats who have a breed of tabby. And we're going to change that breed to be short hair. So again, we have update and a table name. Then set, and this is a list of the changes we want to make. So in this case, I'm setting the breed to be short hair. And then who do we want to, or who is the wrong way of saying it, but what do we want to perform it on? What is the actual data? In this case, breed equals tabby. So I will go ahead and just copy this line, move over here, and if I do a select star from cats, you can see that we have two tabbies right now, Ringo and Misty. If I paste this line in, update cats, change their breed to be short hair if their breed is tabby, and now we select star again, you can see that both tabbies, or previously tabbies, are now short hairs. Ringo and Misty. So here's another example. Let's say I wanted to change Misty's age to be 14. Right now, Misty is 13. And we realize that her dental records are wrong. Apparently you can tell how old a cat is from their teeth. So we misjudged how old she was and we want to make her 14 now. So to do that, it looks like this. Update the cats table, set age to be 14. We don't need quotes this time because we're working with a number, an integer. And we only want to do that if name is Misty. So let's try it. Now select star again. Or if actually we want to be more specific, we could do select star from cats where name equals Misty. Let's try that again without that extra L at the end. You can see Misty is now 14 rather than 13. The last thing that I'll mention about updating is that there's a good rule of thumb that you should follow. When you're updating something, you should make sure that you're targeting the right data before you actually do the update. So basically run the equivalent select using your where query. And once you make sure that returns the data you expect, then update it, just so that you avoid accidentally updating the wrong data. And the same holds true when we talk about deleting, which we'll do in just a moment. But the core idea is that there's no undo button. So you could update something back manually if you messed it up. But you always want to just make sure you're targeting what you mean to target before you hit enter on your update. All right, so it's your turn. We have a couple of pretty painless, I hope, update exercises. They should be pretty quick. So the first one here is to change Jackson's name to Jack. Once you've done that, you can move on to the next one, which is to change Ringo's breed to British Shorthair. And then finally, update both Maine Coon's ages to be 12. So there are two cats that have breed of Maine Coon. Make them both 12. Okay, so in the next video, we'll talk about answers. All right, so the first one is to change Jackson's name to Jack. So we'll practice what I just talked about, running a select before you do the update. So let's just try selecting star from cats where name equals Jackson. Okay, so we get Jackson, but we want to update his name to be Jack. So now we do our update, cats, set name equal to Jack. That's what we want to change it to. And where do we want to change it? We want to change it where name is currently Jackson. Now I didn't specify that you had to use where name equals Jackson. You could also say where name or where cat ID is 7, or where breed is Sphinx, because we only have one Sphinx right now. So any of those are valid. Now if we do our select again, we get nothing because there is no cat named Jackson. If we change it to Jack, we get the same cat whose name is now Jack. Next up, change Ringo's breed to British Shorthair. So let's do the same thing where we just do a select where name is Ringo. You can see that currently breed is Shorthair, but we want to get more specific, British Shorthair. So to do that, we do an update, cats, set breed equal to British Shorthair, like that, where name equals Ringo. And again, you could also do cat ID 1, or where breed is Shorthair. You could identify this cat however you'd like, but let's make sure it worked. So now if I select where name is Ringo, we see breed is now British Shorthair. So the last one, update both Maine Coons, so breed equal Maine Coon, and make their ages 12. So let's just take a look at our current setup in our database. You can see we have these two Maine Coons, Cindy and Dumbledore. Cindy is 10, Dumbledore is 11. For whatever reason, we want both of them to be 12. So let's just select both of them first. Select star from cats where breed equals Maine Coon. Just like that. Perfect. So we are targeting them correctly, so we can copy that. And then we'll do our update, cats, set age equal to 12. We don't need quotes. Where, and I'll just paste that in. And it updates both of them. So that's really what I was testing here, is that you understood that where is not always just going to return one result. Whatever is returned will always be updated, which is also important to note that if you leave that where off, and I just said update cats set age 12, that would update every cat, which we don't want to do, which is why it's always important to select things first and make sure you know what you're targeting. Sometimes there could be reasons you wanted to update everything in a table, like if you were making a big change or you are migrating something, or you realize that you made a big error early on in your application and you have every piece of data is wrong somehow, maybe. But most of the time, you're being very specific in the changes you're making. So just to double check, if we select again, you can see Cindy and Dumbledore are now both 12. And that's all you needed to do. Perfect. Next up, we're diving into delete. Okay, so we've made it through the C, R, and U portions of CRUD. Now we finally made it to D, which stands for delete or destroy, depending on who you ask. So in this video, we're going to see how to delete things in MySQL. And it's pretty straightforward. It's very similar to selecting things, except rather than just selecting something, you're going to delete it. So let me show you what I mean. Here's an example that will delete any cat with the name egg in our database. So imagine, first of all, that we were selecting. All we would have is select from cats where name is equal to egg. So if we ran that, it would give us the cat or cats with name egg, and we can swap out select with delete, and that will delete it. So that same rule of thumb from before, where I said make sure before you update something that your selection is correct, then do the update, because it will, there's no undo button, unfortunately. Same holds true, and more so with delete, because your data's gone as soon as you delete it. So let's try this. We'll delete egg. Let's do, first of all, select star from cats. Just make sure we have egg in here. there he or she is. I'm not quite sure what I was intending with that name, egg. So what we'll do first is just make sure we can select appropriately before we delete. So select star from cats where name equals egg. Remember that this is case insensitive. Just for now, I'll do lowercase just to prove that. All right, so we get egg. Perfect. So now to remove egg, delete from, and then we can just copy this. So before I hit enter, I do need to take a moment to address something pretty serious. And that is that no cats are being harmed, no cats are dying here. Yes, they're being deleted from this table, but in reality, deletion doesn't mean death. It means that they're being adopted, perhaps to a loving family that will treat them with the care that they deserve. So there's no death here. And I hope I don't receive any furious comments about how I'm treating animals in my course. I love animals. I learned from my first course, I made a mistake. I will never refer to deleting dogs or cats as killing them. I'm very sorry for that. So again, these cats are not dying. So with that out of the way, let's hit enter. Now let's go back and select star from cats. And as you can see, egg is now gone. Also, something that does come up sometimes, notice that the cat IDs have not shifted. They're still the same. Some of my students in the past have had the expectation that the IDs would alter, but they always will stay the same. And that's because when something is inserted into a table, that unique ID is generated for it. Remember, it's a primary key. And eventually, we'll learn about having multiple tables that interact with one another, and we'll be storing these IDs in other tables. So if it changed, that could be problematic because we'd have to change it in multiple places. Anyways, all I'm trying to say is that we removed 4, but we still have 5, 6, and 7. This didn't change to 4, this didn't change to 5, and so on. All right, so we deleted that. Rest in peace. Enjoy your new life with your happy family, egg. So one last thing here is that if you look at what I've written here, delete from cats, what do you think that will do? Now, I don't run it, but what do you think this would do? And the answer is that it deletes everything, all cats. They're all released to their happy families. So that's important to know that you can do that. So it's different than dropping a table, because dropping a table gets rid of the table entirely and all data inside of it. But deleting from cats just deletes the entries in the cats table, but we still have the shell, we still have the cats table. There shouldn't be very many times when you need to use this command. I'm not going to do it just yet because I want us to have our cats data for a little bit for the next exercises, but just keep that in mind. Because we didn't specify a where clause over here, it's the same as selecting without a where clause. It selects everything, so this will delete everything. Okay, next up, you're going to practice deleting. All right, so it's your turn here. We're going to get some practice with delete. So we have 3 different things I'd like you to do. The first one is to delete all cats that are 4 years old. So if we look at our data, there's only 1 right now because we got rid of egg. But I would like you, so don't just say delete Ringo or where breed is British Shorthair or ID is 1, but use age. Then the next is to delete cats whose age is the same as their cat ID. Now I had you do something similar to this with the select exercises. Now you'll need to put that together with delete. So in our case, it's only Jack at this point. So Jack has an ID of 7 and age of 7. But once again, no cheating. Don't just select based off of name or breed. Do it the way I specified, please. I mean, it's up to you, but the way I recommend. Next up is to, oh my gosh, delete all cats. So that thing that I said I wasn't going to do because I didn't want to delete all of our data, well, you're going to do it. And then we'll be starting with a whole bunch of new data in the next exercise. All right, give it a shot. So let's talk about solutions to these. The first one, to delete all 4-year-old cats, all we need to do is start off, and you don't have to do this, but I like to start off by making sure we're selecting things correctly. So select star from cats where age equals 4. We get Ringo. Then I just like to copy this and do a delete from cats. And of course I forgot to add a space, but delete from cats where age is 4. Now if we do let's do our first select, we should see nothing. And if we do a select star, we should see that we're now missing number 1, who was Ringo, by Ringo. Okay, next up, delete cats whose age is the same as their cat ID. So this one involved something slightly different, like I mentioned, where we're not just checking for a specific piece of data like breed equals Maine Coon or age equals 12, but we're checking where cat ID equals age. So we'll do a select first, select star from cats where cat ID equals age, or you could do age equals cat ID. And we get Jack. Cat ID is 7, age is 7. Great. So then we'll just copy this and do our delete from cats where cat ID equals age. It says 1 row affected. If we try and select it again, it's gone. And if we do a select star, now we're also missing Jack. As you can see, we just have 2, 3, 5, and 6. Which leads us to our final example. Delete all cats. So this one is pretty straightforward. If we tried to do the equivalent select, it would just be select star from cats with no ensuing where clause. Just like that. So to delete all of those, well, it's just delete from cats. All of our cats are being released at once into a land of rainbows and joy. We hit enter here. They're definitely 100% not dying. Nothing bad will ever happen to them. Here we go. 4 rows affected. Select star from cats, the moment of truth. And they're all gone and not dead. Okay, so we've now covered the C and the R and the U and the D in CRUD. That spells CRUD, which means that we're done with this. Next up, we'll get some practice putting it all together. Hey, welcome to the next section. So this section is a bit different than everything else. I guess you could say that for every section, hopefully, but the structure is pretty different because it's all challenges, it's all exercises. So the way that this will work is you're going to practice all the commands you've seen up until this point. Everything from creating a database and switching and using the database to creating your tables and defining a schema, to then doing the basic CRUD operations we've talked about, creating, reading, updating, and deleting data. All that stuff, all those commands that are associated with that, you'll be practicing them all at once in this section. And it's not just one giant video. I broke it up into kind of logical, hopefully, sections that make sense. You'll go through, the create section. We'll create data together, and then you'll do exercises with it. And we'll be working with all the same data, so we get all the same answers, which is really important that, if you're following along and you're trying to update something, that your update looks the same as mine. So the data that we'll be working with has to do with inventory management, has to do with, let's say, a clothing company, an online clothing retailer, or maybe just our closet. We're just doing an inventory of my closet. I need to figure out what fits, what doesn't fit, what colors are there, what shirts have holes, I don't know, what to give away to charity, what to burn in a pile, if that's what you do, all that stuff. And, we'll have different types of shirts. I got props again, short sleeves, we've got long sleeves, and the underappreciated and elusive 3/4 length sleeve. Not to mention things like, Hawaiian shirts, or even Hawaiian shirts of different colors too. I bet you didn't see that coming. Look at that, another Hawaiian shirt. Yeah, I should probably stop this video, huh? So let's get on with the exercises. Coming up, whole bunch of exercises around shirts. All right, so we've seen the basic components of CRUD, creating, reading, updating, and deleting. You've learned how to do all those operations in SQL. And now it's time for the super, ultra, hyper, mega CRUD exercise. Actually, let me try that one more time. It's time for the
super, ultra, hyper, mega CRUD exercise.
It's only been half a second, but I already regret that. So let's move on. So the idea here is that you're going to get to put all the different things you've learned to use. So this will be one exercise. In this case, we're working on closet inventory. Super exciting, I know. So basically the idea is that I or you or somebody has a bunch of clothing in their closet that they want to go through an inventory and figure out sizes and colors. And we're just focusing on shirts, so different types of shirts, tank tops, polo shirts, t-shirts, and so on. And we can go through and we'll just perform some basic operations on them. I do want to add a note that I know that up until now our data has been sort of trivial, and this included t-shirts. It's not that exciting or that realistic really, but we still don't have the pieces to go into complex real world data that you would see in a web app. But we will get there, and so hold tight. I promise we'll be seeing a lot of real world, potentially more exciting, definitely more challenging data. So we're working with spring cleaning, and you're going to have a bunch of operations to do. And the first one is to create a brand new database. So think back to how we did that. No more working in the cats database. We need a new one called shirtsDB. So create that. And then the next step is to create a new table called shirts. And to do that, you need a little more information. You need to know, what does that table look like? So here you go. Here's a graphic representation. We've got a shirt ID, which cannot be null and is a primary key. We have article, which should be something like t-shirt or polo shirt or tank top. It's text. Then we have the color of the shirt, which is also text. White, green, black, blue, and so on. We have the shirt size, in this case, smalls and mediums, text. And then we have actually, before I move on, I do want to call your attention to the fact that I did shirt_size rather than just size. And that's because size is a bit of a reserved word. So you can still use it, but it's a word that MySQL uses internally, size. And so it's better to avoid any conflicts there. So I just went with shirt size. And then last worn is a number, and that refers to roughly how many days ago the shirt was last worn. So the idea is that we would inventory our closet. Maybe you do this, maybe you don't, but you go through and you figure out what you don't wear all that often, and then either sell it or donate it, or I don't know, make tie-dye with it, whatever you do. So that's what we're trying to calculate, or what we're trying to store here. And it's just a number for now. So create that table. It should be called shirts. And once you do that, you can move on to the next step, which is getting the starter data in there. So I want all this data in the table, but I don't want you to have to type it up yourself. It can be obnoxious to insert that manually. So I've given you basically a starter seed data that contains the exact same thing. So a white t-shirt that's small with 10 days ago. So you can see it's the same as this first shirt here. And I've done it for all 8. So you could copy this. It's in the text of this video as well. And then what you could do is just insert it all at once. So remember how to do a multi-insert. Get all that data in there with a single line. And then the next step is to add a single new shirt. So insert something manually, not using a multi-insert, but just one at a time. A purple polo shirt that's medium that was last worn 50 days ago. All right, so then once we have those 9 shirts in there, we can now start to do some stuff with them. First thing we'll do is select all shirts, but only print out article and color. So we should only see t-shirt purple, polo shirt black. We don't want to see ID, we don't want to see size or last worn. Then once you do that, the next step is to select all medium shirts. So all shirts that have size of medium, and print out everything but the shirt ID. So we want all of this here, article, color, shirt size, last worn, but not this, but only for the mediums. Okay, then next up, we're moving on to update. So we've done the create and the read. We're working on update now, which is update all polo shirts to be size large. Maybe, I don't know, you realize that the company that makes your polo shirts, it might say medium on them, but in reality, they're pretty large. And so you want to update your database. It's a dumb story. Let's just go with it. So change their size to large. So that's where article equals polo shirt. Next up, update the shirt that was last worn 15 days ago and change last worn to 0. So this would mean there's a shirt that was worn 15 days ago that we decided to wear today. So we're going to change the database to say last worn is now 0. So once you do that, now our final update, we had a bit of a mishap. We were doing laundry. we took all the white shirts and we washed them with, I don't know, some colored stuff that we shouldn't have, and we shrank them at the same time. So we have a double update here. You need to update all the white shirts to now be an extra small size, and their color is no longer white, but it should be off-white. So you need to update both of those at once with one line, just to be clear. All right. Next, we're deleting. So delete all old shirts. And in our case, old just means if it was worn 200 days ago or last worn 200 days ago. We will see very shortly how you can do things like delete all old shirts that have been last worn greater than 50 days ago. But for now, we're doing exactly 200 days. Okay, next up, our tastes have changed. We've decided we no longer like wearing tank tops. We don't like the person that it turns us into. So we're going to delete all tank tops from our database. So delete all shirts where article is tank top. Then finally, catastrophe strikes. We have to delete all shirts. I'll let you decide why, but we need to delete all the shirts. That doesn't mean delete the table or the database. Just delete the shirts in the table, so it should be an empty table. Then finally, drop the entire shirts table, another catastrophe. So it should be an empty table at this point. Drop it entirely. And that's it. So go through all those steps. I recommend just pausing the video as you go. Make sure you do them. And then if you'd like, watch the solution to see how to do it or how I did it. Okay. Alrighty, let's go through the solution. Spring cleaning, we're doing our closet inventory. And the first step was to create a brand new database called ShirtsDB. So if we hop over to Cloud9, if we just check what database we're using, remember we can do select database. We're using cat app. So we're going to make a new database, create database, and we wanted to call it shirts_db, semicolon. Now, if we do show databases, you can see we have ShirtsDB down at the bottom. All right, so the next step, we need to use ShirtsDB, just like that. And now if we run that same select database line, we're currently using ShirtsDB. Okay, so now this is probably the longest thing you'll have to type. We need to create a new table. We'll call it shirts, and it needs to have these 5 columns. Shirt ID, which cannot be null, and is a primary key, which means that we'll have it auto increment as well. Article, which should be varchar, and let's just for simplicity say all of these have 100 character limit. Color, varchar 100. Shirt size, yes, we could have kept it short, but maybe you might have a shirt size that's small, spelled out the full word rather than just the letter S. So we're not going to limit that either for now. And then last worn is an int. So let's try it. We'll do a create table shirts. And I'm going to do this on a new line here. And the first thing that we have, let's start with shirt ID, which should be an integer, not null, auto increment. Next, we're going to move on to article, which is a varchar 100. And then after that, we have color, which is also varchar 100. Then we have shirt size, which is also varchar 100. And finally, we have last worn, which is an int. Just like that. Then we'll close our parentheses, and then we'll add our semicolon. And I forgot something, which I did not do on purpose. But if we look at the message, it says incorrect table definition. There can be only one auto column, and it must be defined as a key. And so I'm missing the primary key definition at the end, which this is actually a helpful error. Oftentimes these error messages aren't that useful, but this one tells us exactly what we did wrong. So I'm going to recall that line. And then at the end, I'm going to add comma, primary key. And then our primary key is shirt ID, just like that. Now if I hit enter, and would you look at that? I left off the last parenthesis again. So we have another error. Okay, so now if we hit enter here, it worked. If you'd like to see a nice cleaned up version, what this actually looks like here, I have it here. So create table shirts, shirt ID, int, not null, auto increment, article varchar, color varchar, shirt size varchar, last worn int, primary key, shirt ID, and the semicolon and the correct parenthesis closing it out, and that should do it. All right, and if we wanted to double check that things worked, we can do our describe shirts, and you can see we have what we expect. So the next thing is to get all of this data in our database. So I gave it to you as this comma separated list where things are all in the same format, where we have parentheses for one shirt, and then inside of that we have article first, and then color, and then size, and then last worn. So we can insert using that format. So we'll do an insert into shirts, and we have to specify we're doing article first, then we're doing color, then we're doing shirt size, and then finally we're doing last worn. And then we need our values, and I'm just going to hit enter for now, and I'm going to paste that giant list, and we need a semicolon at the end, and we hit enter. Good, no mistakes this time. It says records 8 rows affected. Okay, so if we wanted just to double check, we can do our select star from shirts, and we get the data in there that we should have. And then the last thing we need to do is to add a new shirt. So manually, one shirt, rather than bulk inserting, it should be a purple polo shirt that's medium that was last worn 50 days ago. So I didn't specify what order you needed to insert into, so I don't really care, but we'll do insert into shirts, and we'll do color because that's how I specified here. Color, then article, then size, and then last worn. So color, article, shirt size, last worn. Like that. Values, and it's purple polo shirt, comma, medium, comma, 50. Just like that. Okay, and if we do select star, we should see that new polo shirt down there. It's purple, medium, 50 days ago we wore it. All right, so we've now wrapped up the create part of CRUD. We saw how to create the database. We created a new table. We inserted data into the table. Now we're moving on to reading. So this is the read solution. Basically, it's a bunch of select statements we're going to write. So the first one is to select all shirts, but only print out their article and their color. So back in Cloud 9, all we need to do is select, and rather than just select star, which gives us everything from all shirts, I mean, this is correct in that we want all shirts to be listed, but we wanted to narrow down the fields we get, which was article, comma, color. And there we go. Article, color. T-shirt white, polo shirt black, tank top white, and so on. Next up, select all medium shirts, but only print out shirt ID. So that's all we want. So let's start off by just getting the medium shirts. So select star from shirts, where, and then we need to do a shirt size equals medium, just like that. And we'll hit enter. And we get 4 shirts that have shirt size of medium. But all that we want is everything excluding the shirt ID. Just a moment ago, I think I said it backwards. We want everything but the shirt ID, which means we need to list everything we want out. So select article, color, comma, shirt size, comma, last worn, and then we can just copy this from shirts where shirt size equals medium. And here we go. We have all mediums, and we have the 4 columns we're looking for, which excluded shirt ID. Sorry, shirt ID. So that's it for the selecting portion, the read in our CRUD. Next up, update. So we've covered creating and reading. Now we're on to updating our shirts. So the first problem is to update all polo shirts and change their size to be large. So we'll start by just selecting polo shirts. Select star from shirts where article equals polo shirt, just like that. Okay, so this is what we get. And what we want to do is change shirt size to be large. So we need to keep this I'll copy it now. And then we'll type out update shirts set, and we want to change shirt size to now be large. And where do we want to do that? Only where article is polo shirt. Hit enter. We get 3 rows affected, 3 rows changed. Now, if we go back and run our same select, we should see all polo shirts are now larges. We could do the same thing just to see it in the grand scheme of things. There we go. We have 3 larges now, all polo shirts. The next problem is to update the shirt last worn 15 days ago and change last worn to be 0. So we'll start by just selecting that shirt like we did earlier, where last worn equals 15. There it is, tank top, blue, medium, last worn 15 days ago. And we wore it today. It was a hot day, we needed a tank top, and we want to update last worn to be 0. So update shirts set last worn equal to 0, where last worn is currently 15. We get 1 row affected, 1 changed. Let's do our select again. We no longer have it, but now if we say select where last worn is 0, we have 2 shirts. This t-shirt that was already there and our blue tank top we just added. Perfect. So the final update is to update all white shirts, change their size to extra small, and at the same time, change their color to off-white. So this needs to happen all at once. You can't do 2 lines. I mean, you could, but that's against the rules for this problem. So let's start off by just selecting all white shirts. Select star from shirts where color equals white. Oh boy. Let's get rid of that extra L there. Here we go. So we have 2 shirts. A t-shirt that's white, that's small, and a tank top that's white, that's small. So we want to change color to be off-white and shirt size to be extra small because we shrank them and we mixed them with colored stuff in the washing machine, so their color is now off-white. So to do that, let's start with the first part, update shirts, and we'll set color to be off-white. And then we'll do the second part with a comma, shirt size equals XS, extra small, just like that. And then we'll do our where color currently equals white. And that should do it. Fingers crossed, no typos. Now, if we go back and select where color is white, we should have nothing. But if we say where color is off-white, we should have 2 that are extra smalls, or we could, of course, do select star from shirts to check our work. We have extra small, off-white, extra small, off-white. Okay, so that problem was just making sure that you could update multiple fields at once, making sure you understood that. Okay, that's it for update. Next, we move on to D, delete. Okay, so we've made it to the end, the final video solution to our spring cleaning extravaganza problem. Now we need to delete. We've covered creating, reading, and updating, basically inserting, selecting, and update. Now we're going to use delete. So the first thing is to delete all old shirts, which really just in this case means last worn is 200 exactly. So when we do our select star, you can see there's 2 shirts that meet that criteria. 7, ID of 7, and ID of 2. But we're going to delete them based off of last worn. So we always start with our select star from shirts where last worn equals 200. And we get our 2 shirts. So then we can copy this. And actually we can copy this entire thing. Delete from shirts where last worn is 200. 2 rows affected. Now, if we do a select star, those 2 are gone. You can see it goes from 1 to 3, and then from 6 to 8. And there we go. So the next problem is to delete all tank tops. We've decided tank tops make us look kind of stupid, so we're going to delete tank tops. So your tastes have changed. So how many tank tops do we have? We've got 1 and 2 that are left. So we'll do a select star from shirts where article equals tank top. We get 2. Then all we need to do now is delete from shirts where article equals tank top. Hit enter. Now if we try and select them, they're gone. And if we do a select star from shirts with no where clause, now we have 1, 3, 5, 6, 9. So we've lost our 2 tank tops. All we have are t-shirts and polo shirts, which leads us to our final exercise here. Delete all the shirts. And I lied, it's actually the second to last. So to delete all the shirts, but not the entire table, it's pretty simple. We use the same where clause, which is to say that we don't have a where clause. So in this case, it returns select star from shirts, returns all shirts. Well, we just replace that, delete from shirts, if I can spell it correctly, with this part, and moment of truth. 5 rows affected. Now when we do select star from shirts, we get nothing. It's a sad day. Not as sad as when we deleted the cats, but still sad. And the last thing is to drop the entire shirts table. We're just done with this. We hated this exercise. We want to move on. So drop table shirts. Now hit enter. And if I do show tables, no tables. And if I try and describe shirts, we get an error because there is no shirts table to describe, and it freaks out. So we've successfully deleted it. Now we have an empty database that we don't need anymore. And we're done with this. Congratulations. Hey, welcome to another one of these videos at the beginning of a section where I just make a fool of myself, do something ridiculous. This time, we're working with books. As you can see, I got more props. Just really love props on this course. And they're here for a reason, because in this section, we're getting introduced to our new data set. So for the next couple of sections, we're going to be working with one data set that I'm going to give you, and it has to do with books. And books make a particularly good data set because there's a lot of data to model. We've got things like, titles, genre, the authors, how many authors there are, things like reviews, ratings, page count, release dates, tons of information for all different sizes of books, giant prop books, medium, small books, all that fun stuff. And our backstory here, it's a very weak backstory, is that we run a small online bookstore and we're being just slaughtered by Amazon. So we're fighting back the only way we know how, which is redoing our database inventory management system. So that's what we're going to do. We're going to fight back by redoing our database, and that will be what we start this section doing. But then once we have that data in the database, we're going to move on to learning a bunch of new commands. And those commands all are called string functions. So I'll explain what those mean in just a little bit. I don't want to make this video too long, but basically they expand our way of selecting data and working with text or with strings. Really important and kind of fun things that we can do. So we're going to go ahead and get started. Before I forget, this book here, it's a very important book. This represents the book of SQL knowledge. Yeah. Kind of regret this now, but this is the book of SQL knowledge. You can ignore, there's a bunch of bugs in here. They're attracted to the light. You can ignore that part. Our book of SQL knowledge doesn't have any bugs in it. We are bug free. Anyways, I think I should probably end it here. I'll see you in the next video. Okay, so we made it through all of that crud. That's sort of a joke. Anyways, we're now talking about string functions. So basically, we've seen how to interact with our database, create stuff, insert it, update, delete, all of that. But now we're going to focus more on select, or reading the data out. Because what we've been doing right now is just reading the data directly as it is. So I could say, I select breed and name from cats, and that's it. I get it back, and that's great. But there are things that I could do with that data. So with numbers, I might want to add them together, or I might want to, reverse a string, or replace all spaces with a certain character, or conjoin first name and last name, or conjoin, two pieces of data together. All of these are different operations, different ways of printing our data out that we can do. And so we're going to start focusing on them in this section. We're talking about string functions. So there's going to be a bunch of things that we see. I already mentioned some of them. We can concatenate words. We can take certain parts of a string and leave other parts out. We can reverse. We can uppercase, lowercase, replace characters, all sorts of things. But before we get there, the first thing I want to do is show you something that I think is pretty useful and that we'll use pretty often from here on out. So up until this point, all of the SQL that we've been writing has been manually entered into the command line, into the CLI here. So if I want to create a table, I have to type create table and then the name of the table, cats. But let's say that I mess it up. So let's say I typed singular cat, which technically isn't a problem per se, but it's a good idea to have things pluralized. It won't break. But so let's say I don't notice for a little bit though. So I create a table cat, and we want, name is varchar 100, age is 10. What am I doing? Age is int, just like that. Let's say we leave it at that. Now this isn't a great example because this is a short line, but if I messed it up, I have to go all the way back here and edit it, right? And do cats like this. But let's now suppose that I have something even longer and I want to put it on separate lines and format it nicely like this. Create table cats. And then we have parenthesis there. And we'll do name is varchar. And let's say I misspell this like that. And age is an int. And then I realized, oh shoot, I totally messed up. I don't have a way of getting back there. I don't have an easy way of getting here. So I have to retype the whole line or copy it. There's no simple way of editing it. So what I want to show you is that we can run code from a file. And that's really, really useful. Running SQL files. That's what we're going to talk about here. So basically, by the end, we will be working with files that look like this. They're nicely formatted. They have nice syntax highlighting. We can edit them, make changes, and so on, and run them when we're ready, rather than typing things manually into the command line. That doesn't mean that we won't be typing things here, because it's a very useful tool. Oh, go away, Siri. It's a very useful tool. I should probably edit that out. Well, anyways, it's a useful tool that allows us to explore things, try things out. If they're short lines, it's great. But if we're really trying to do more serious stuff, it's much easier and better to work in a file. You can make edits, you can share it with people. So that's what we're going to do. So let's go ahead. Let me get out of this. And I'll just hit enter and get an error. And that's fine. So right now I'm in cats database. And if I do show tables, I do have a cats table, but if I look at it, it's empty. So what I'm actually going to do is drop that cats table, drop table cats. Okay. So what I want to do is remake the cats table. And what I could do is what I just did here, create table cats and do the whole thing. But rather than that, I'm going to do it in a file. And then all I'll have to do here is run that file. I'll execute it with one short line. So up here, I have a new file. Again, you can do file, new file. You can use the shortcut shown here. You can right click and do new file as well. Whatever we do though, we need a new file. And I'm just going to put something in there. So create table. And I am showing you creating a table, but we'll be putting any SQL query in here. Creating a table, dropping tables, inserting data, selecting any sort of query we want. So create table cats. And it's so easy now to format it nicely. We'll have name, which is varchar 100. Let's do an ID as well. See how easy that was if I made a mistake. Cat ID will be an int, not null, auto, increment, comma, name, varchar, and then we'll do age is an int, and we'll do primary key is cat ID. So this should all be review. But what's nice is I have this query like this. I need to save the file. So I did Command S, but you can also go File Save. And we need to give it a name. Any name will do. I'll just call it first file. And this is the most important part, .sql. So that's what identifies the contents of the file as SQL code. So we need that. Click save, make sure it changed up there. Also, you can see we got nice syntax highlighting now, which is also very useful. Okay, so I'm sure by now you can see the value in doing this. You have a history of your work, you can edit it, share it with people. It's just a much better way of doing it. So how do we actually run it? Well, this is the magic. Source, and then a file name. So in our case, our file name is firstfile.sql. So we just need source filename.sql. So I'm going to actually quit out of the CLI. And the first thing I want to show you is that it matters where you are when you initialize your CLI. So when I type ls here, and if you're not familiar with that, it just lists the current files. So what this shows me is that I have book data, first file, and problems. All right, so we want first file. Don't worry about these other two. So we are in the correct directory to access that file. So if I start up the CLI with MySQL CTL space CLI, and I use the cat app database, just like that, I'll make some space. Now all I have to do is source first file.sql, just like that, and we'll see what happens. It says query okay. So now how do we know it works? Well, we could do describe cats, and here's our table. So that's all that there is to actually executing the file. It's just source and the file name. But what I want to show you, two things. I'll go ahead and make a new directory. You don't have to do this, but I'm just going to call it, testing. And then inside of testing, I'll make a new file. And what I'll put inside of that file is a select statement. Select star from cats. Actually, let's do an insert. Insert into cats. And we'll just do, what do we have here? Name and age, which I'm just realizing I capitalized. So we could obviously go back and change that here and rerun it, but we'll leave it. So insert into cat's name and age, just like that. Values and name will be, let's do Charlie. And age will be, let's do an old cat, 17. Save the file. And we'll do file, save. And make sure the file has .sql in it. So we'll do rename. And I'll just call this insert.sql. Okay. Let's actually, just to show you we can do more than one thing at a time, let's insert both. Or let's insert two. And this one will be called, I think we already have a Cindy. Let's do a Connie, who is 10. And then at the end, we'll also do select star from cats, just like that. So these three things will be executed at once, if we do it correctly. So now to reference this file, our CLI is running in this folder. So we can't just say insert.sql. If we did that, source insert.sql, it tells us it can't find that file. So what we need to do is do a source testing / insert.sql. And there we go. So that's important, that you have to access the correct path. You have to refer to this file by its full path to get there. So if you're in this folder, all that we can access are these. But if we drill to this folder, then we have access. And obviously you could extrapolate that to as many layers as you need. So now let's make sure it worked. You can see after it worked, we had query OK, one row affected. That was our first insert. And then the same thing, our second insert, and then our select statement gave us this right here. So that's all there is to running code from a file. It's really, really useful. We'll be doing it pretty much nonstop. And the first thing that we're going to do is actually get some new data into our database using this in the next video. So now that we've seen how to use source, we're going to take advantage of it to get some sample data going for the next couple of videos and exercises. Cats are kind of boring. They're pretty simple at this point, name and age and breed. And we need some more complicated data, and that's something that's a little more real world. So we're still not working with something straight out of a production app because we haven't seen some of the features that we need to know for that to work. So it's still kind of simplified data, but what we're working with is books data. So this is what we have. I've given you this file, so you can find it in the file section or the downloadable section of this video. Basically, there's two parts. We're creating a books table, and I'll go over that in just a second. And then after that table is created, there's a bunch of values that I'd like for you to insert. And I didn't want you to have to type these all at once, but I want us to all have the same data so we can be on the same page when we run exercises. So all of this data is actually real data. It's about books from Amazon. And basically every book has a book ID, so that should not be new. There's a title, it's a varchar. Then we have an author first name and an author last name. So if we look at one, here's the namesake, that's a title. The author first name is Jhumpa, and her last name is Lahiri. Then we have the released year. So what year was it released in? And this is an example where we're using kind of the, I don't want to say dumbed down, but simplified version of data. Because typically you would probably store a date, an actual date, not just a number like 2003. So we'll see how to do that once we talk about dates. But for now, we just have 2003. And then the next thing is stock quantity. And this is just an arbitrary number I picked. The idea here is that we have a fictional bookshop, and we're keeping track of all the books and how many we have in stock. So for the namesake, we have 32 copies in stock. For A Hologram for the King, we have 154 copies in stock. Then the final thing is the pages. How many pages are in that book? So you can see some books are really long, like The Amazing Adventures of Cavalier and Clay has 634 pages, and some are much shorter, like what we talk about when we talk about Love by Raymond Carver. Really good short stories if you like short stories. 176 pages. So a note about these books. I started off by just picking off the bestsellers on Amazon as of writing today, so I think that's where this one, Norse Mythology by Neil Gaiman, came from. But I then just decided to create a variety of years and page numbers, some of my favorite authors. It's a whole mix of things. So it is real world in a sense, but it's also I planned certain things to work certain ways. So we have we have some really long titles and some short titles. We have some really long books and short books. We have some books from the 2000s and some from the 1900s and so on. Basically, I wanted a variety of things that we could practice with. So go ahead, create a file in Cloud9 and put all of this in there. Now, if you want to type it, go ahead, but I would recommend that you don't, just so that you don't accidentally mess something up. We want our data to be consistent. So you go ahead, copy it, make a new file, and then we need to execute that file. And I want to make a new database. Right now, if we do select database, we're working with cat app. I want to create database, and we'll call it bookshop. And then use bookshop, and we should have a blank slate. If we do show tables, there should be nothing here. Perfect. So what you want to do is make sure this file has been saved, and then we just execute it. So it's pretty straightforward. Source, and then you'll need to make sure you either are referencing the correct path. So in my case, I'm running my CLI in my root directory. So all I have to do is bookdata.sql. Whatever you called it, you'll need to refer to. I recommend just putting it in the main directory for now, but we could, you could have a separate folder if you wanted to, and you just need to refer to it correctly. Anyways, source bookdata.sql. And here we go. All right. First thing, we get this message, and that tells us the create table worked. And then we get 16 rows affected, and that tells us the insert statement worked. So let's just verify. Let's do describe books. Here we go. Here's all that we created in that table. And let's just do a simple select star from books. As you can see, it's pretty messy. And that's deliberate. We're going to work on ways, we're going to see ways of refining this and making things shorter, collapsing data, and so on. So that's all we're doing in this video, just getting set up. Now that we have it in there in our database, we'll be able to work with it and be on the same page. Awesome. All right, so we have that out of the way. We've seen how to run files using the source command, and then we actually did that with the sample data that I gave you. Now we actually dive into the meat of this section, which is all about string functions. And the first thing I want to show you is that if you go to Google and we type in MySQL string functions, string functions, excuse that, and we hit enter here, you can see I've already clicked on this link, the MySQL reference manual, string functions. I have to say I'm not a huge fan of the documentation of MySQL. For one thing, I think it's kind of ugly and looks dated, but it does have all of the information you need. I just don't really like how it's presented. But if you look at this giant list here, these are all string functions that we can use. And a lot of them are very, very specific. I'm going to show you some of the more, first of all, the useful ones, and then a couple just fun ones, and that we'll be able to combine together for some good exercises. But we're not going to take a look at most of these. Most people don't even know that these are here. I'd say that's a generalization, but in my experience working with MySQL and people who work with MySQL, you use maybe 5 of these on a regular basis, and then occasionally you might need to do something like, hey, is there a way of doing X? Let me go check on the documentation, and oh, look, there is a way of doing that. Perfect. Or, oh no, there's not a way. Great. What am I going to do next? So I just want to show you that this is here. And the first one that we're actually going to take a look at is called concat. So what it will do is combine pieces of data, combine strings. So here's an example using this book data. Remember that we have author first name and author last name. And there are valid reasons for separating that data. Sometimes, you might want to sort books by last name, and sometimes you may only want the last name in certain contexts. You might not want the first name. It's not a great example, but there are reasons that you would separate this out. Just like when you're filling out a form online, you're signing up for a site, they usually don't just ask you for your full name. They ask you for first and last name. But then, if they have those pieces of information, it's pretty easy to combine them. So that's what we're going to see now. How do we combine these two and get something that says Jhumpa Lahiri or Neil Gaiman, or in this case, Foster Wallace as the last name, which I'm actually not sure if that qualifies as a last name exactly, but David Foster Wallace, how do we combine that? How do we get that? And the answer is we use concat. So let me just first show you what we have right now. We'll do a select author F name, author L name from books. And that's what we get here, just what I had printed out in the slides. So what we want, again, is to combine them, but we'll take some baby steps. And yep, here's a slide. I totally got ahead of myself. What if I want full names? So concat. The way that concat works is that we pass in multiple arguments or pieces of data, and it will combine them. So whatever we give it, in this case, if you had columns named X, Y, and Z, this would work, but it's really just supposed to be an example. More specifically, what you can do are things like this. Concat a column name with another column. So that's what we'll work on. We're going to do first name, or author F name and author L name, and combine them together. And if we do this right here, so concat author F name, author L name, what it will actually do is just slam them together. Put them exactly together, concatenate them. So there's no space in between. So we get Dave Eggers, Jhumpa Lahiri. So there's no, that's not exactly what we want. Maybe we want a comma. Maybe we want last name, comma, first name, or maybe we want first name, space, last name. So there's a way of doing that. When we concat, we can pass in a column name and then some other text, and then another column name, and if we wanted more text. And we can keep going on and on and on, and it will concatenate everything. So to add a space, it's pretty simple. Author, first name, comma, and then a space, comma, author L name. And that will give us Dave Eggers and Jhumpa Lahiri. So now that I've shown you in the slides, let's take a look. And the first thing I'll show is that often people expect they can just come in here and just type concat. But if I just do concat, author F name, comma, author L name, there's a problem. Hopefully you can identify what the problem is. If I hit enter, this is not valid syntax. First of all, it doesn't know what table. What if we have multiple tables? Where's author F name coming from and author L name? And second of all, we have to select. So we can't just run these willy-nilly. We can't just run them on their own. We need to run them as a select. So select concat. And then in here, I'm actually going to start with something simple. I'm not going to use columns. I'm going to use text. So I'll just put something like hello, comma, world. So this is very trivial, but if I just do this, select concat hello world, and I hit enter, you can see it does it for me. And it just gives me hello world, combines these two things. So I could do the same thing and add a space. And rather than a space, let's do dots so it's easier to see. And we need a comma, a lot of punctuation going on. Select concat hello, comma, dot, 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 comma, world. It just shoves them all together and we get hello, dot, 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 world. So that's how we can do it with just text, which you probably won't be doing. You'll be doing things like this. Select, and then concat a column like author F name, and then a space, and then author L name from books. So let's try it. We can copy it now. Go over here and paste it. Select, and what it will do when we hit enter is just make a new column for us, or in our results. It doesn't change our initial data, just to be clear. Our data looks the same in the database. This is purely about printing it out. But we have this new thing up here with this horrible title, concat author F name, comma, space, comma, author L name. But then in here, we have the data that we're looking for. We have Jhumpa Lahiri, we have Patty Smith, Raymond Carver, and so on. So that's really useful to combine data like that. Now, if we want to get a little fancier, let's rename it. So let's give it an as, and we'll just say as full name, just like that. And now I get full name up here, Jhumpa Lahiri, Neil Gaiman, and so on. So that's concat. I'll show you a couple more examples just to show you how these string functions work. You don't have to just do one at a time. So we could do something like this. Select, and we'll do author first name just on its own, author F name as first name. Let's just do first actually, as first, comma, author L name as last, and then we'll have a concat author, and let's do it on a new line just because it gets a little messy here. Concat author F name, so this is what we've already seen, with a space, comma, author L name as, and we'll call it full. So we'll have three different things printed out. The first name under the title first, author L name as last, and then the full name combined using concat as full. So then we need to say from where? From books. And now I hit enter and I get this pretty little table. First, last, and full. So what I want to show is that you don't have to use it in isolation. You can combine it with other things. And we'll see this as we go. We're not going to just use concat. And you don't have to just use one concat per select. You could have multiple if we wanted to. You know, I could have full name, and then I could have full names, comma separated instead. And if I want to do that, you can probably figure this out, but rather than just having a space there, I'll just put a comma. And now I get Jhumpa, comma, Lahiri. All right, so one more thing about concat is that there's something called concat WS, which stands for concat with separator. So there might be times where you're concatenating multiple fields, multiple things together with the same symbol or piece of data stuck in between them. So there's a shortcut for that. So if I wanted to have title dash author F name dash author last name, let's not debate why, but if I wanted to, I could do something like this. Select concat, and we have author, or actually we started with title, comma, and then we wanted to dash, and then author F name, comma, and then another dash, comma, author L name, just like that. So it's kind of a lot of repetitive typing, especially if we have more items that we're combining. But if I just do this here, from books, you see it does what you expect. It puts the title dash first dash last. But we can use concat ws, and it looks like this. So it switches things around a bit. The first thing that we pass in is what we want the separator to be. So in this case, a dash with a space on either side. And it will go ahead and then insert that in between every other thing we pass in. So we'll have title dash author, first name dash author, last name. So now if I paste that in, you can see we get the same result, although I added spaces here, but it's the same idea. It's sandwiched every time. So just worth noting, if you ever are in a situation where you're combining lots of data in the same manner, you can use concat ws to save you typing this or whatever your symbol is over and over. So that's our first string function we saw, concat and concat ws. And what they do is concatenate or shove together, smash together strings. Next up in this onslaught of string functions is substring. So substring allows us to select individual parts or portions of a string. I only want the first character, I only want the middle 10 characters, or the last character, or so on. So the syntax is similar to concat. Here's an example. In this case, we're not working with columns or tables or anything. We're just working with static data, hello world. And what this will do, select, so there's our select again, and then substring, our string function. In parentheses, in this example, the first thing we do is tell it, here's the string we want to work with. So that first thing is hello world. And then what we're going to do is only print out the substring, the portion from 1 to 4. So those are indices referring to characters. And in MySQL, they start at 1. If you're familiar with other programming languages, they often start at 0. That's not the case here. So H is 1. So we go from 1 to 4. So 1, 2, 3, 4, which gives us hell. I'm sorry, that is a bad word. Please don't be mad at me. So hello world 1 to 4 gives us that, but that's not the only way of using it. Here's another example. Select substring hello world, the same starting piece of data. And this time, all we give it is one number, one index 7. So if we count 1, 2, 3, 4, 5, space is 6, 7 is that W. You might think it's only going to give us that W, but that's not true. It gives us from that W on to the end. So if you only pass in one number rather than 2, it starts from whatever that index is and just goes to the end. So let's try a couple out. We'll do a select substring, and we'll just do the hello world example that we just saw. And we'll go from 1 to 4. So we already know the answer here. Oh, there's hell. As you can see, 1, 2, 3, 4, we get hell. So if we change that from, let's do 3 to 8, we get low whirl. So that's one way of using it. And then the next way, as we saw, is if we just leave that second or that third argument off and we just say hello world, comma 3, it will go from the third character, so 1, 2, 3, to the end. So we get low world. Or in the case that I showed, if we do 7, we get world. And there's one more way that we can use it, which is to actually give it a negative number, negative index. So what do you think will happen? I give it -3. Hello world. Well, the answer is that we get RLD. So it starts from the end of the string, and it goes from -1 to -2 to -3. And it includes all of them. So RLD, if we try that, give -3, you can see we get RLD. And if we did -7, it'd go 1, 2, 3, 4, 5, 6, 7 to this O. And we get O world. So that's how we do it with just static data. But now let's say we wanted to work with a column. So in our case, let's take the example of title. So let me just do a select star from, actually let's do select title from books. So we've got a variety of lengths of titles, right? Short ones like white noise, Coraline, long ones like what we talk about when we talk about love, stories. Let's say I wanted to just print out I don't know, the first 10 characters of every title. Maybe, you've probably seen that before when you're on a shop, and if there's a long title, the whole thing isn't printed out. There's just, a couple words and then ... or read more or something like that you can click on. We'll do something similar. So to limit this, what we would do, let's just take this as an example. We can do a select substring. We'll give it the whole title, and then we only want from 0 to 10, or from 1 to 10, excuse me. We could do that. And this actually, here's another error that I considered editing out, but I've decided not to because it is worth taking a note of. The problem is that it thinks that I'm still in a quote because I have this opening quote and this closing quote, but in between I have another quote, which is actually an apostrophe in this case. So this is not going to work. If I do this, I'll just exit out, just ignore that. But I'll have to redo the whole line, and rather than using single quotes, I'll use double quotes, like this. Where I'm calling from, selected stories, just like that. All right, and then I'll get rid of this other quote I put at the end. So that is important just to take note of when we're working with strings. If you have a quotation mark in there, you've got to work around it. All right, so I do this, and you can see it gives me where I'm. Yes, this is 10 characters, maybe isn't long enough, but we're just going to work with that. So now to do it to every single title, it works just like we did with concat. We're going to do a select substring title, comma 1, comma 10 from books. And that's it. And there we go. Now we have this ugly heading up here, so we could do an as again, as, and let's just say short title, like that. Now we get this short title, blah, blah, blah. The name say Norse myth, American G, a hologram. Some of these actually work. The circle, there we go. Just kid. All right. So one other thing I'll show you. There is a shortcut. It's a very small shortcut, but you can type substr, S-U-B-S-T-R. I don't use this all that often because I can really remember what the shortcut is, because in some languages, there'll be substring where it's S-U-B-S-T. There's some I've seen where it's S-B-S-T. It's just not clear which characters get cut out, because it's not just all vowels, because we have a U still. Anyway, so if you would like, you can use this. I can just show you if you replace that. If we do select substring and just change substring to be substr, it does the same exact thing. But what I also want to show you is that we can combine concat and substring, or any of the string operators or the string functions you'll see. So let's say I wanted to add a ... after this, so that it looks like this. Short title, the name say ... Rather than just an abrupt cutoff, let's add a ... So hopefully you can identify what we need to do is first chop our string, use a substring, 1 to 10, and then concatenate that with ... So I'll do this in a separate file. I'll go ahead and make a new file, and I'll just call it something silly like bookcode.sql. So we know we're going to do a select, and there's going to be a concat in there. And what we're going to concat is the short title. So again, this is wrong, what I'm typing, but I just want to put a placeholder. The short title with a ... from books. So this won't do anything right now. We need to replace this with how we actually achieve that short title. And that's going to be with a substring. So in here, we type substring, and we want to put title in there, oops, comma, and we want it to go from 1 to 10. So this looks like a lot. It's pretty ugly. To format it a little nicer, we can do this. Depends on how intense you want to be about it. I like to just do it like this here. So substring is our first argument, comma, ... is our second one, from books. So if you look at it, you can see the order things are going to happen. So substring is going to happen first for every title. So that will be the name say, or American G. And that will be concatenated with ... And that will run for every single book in our database from books. So if we save that, we could either source the file or just copy and paste it. So let's do that now. We'll do source book code.sql. And there we go. The names say ... Norris Smith ... American G ... But you see we get this really hideous title up here. So let's put in as. We'll call it as short title. Save again, rerun it. Now we get this. Much, much nicer. Short title, the names say ... and so on. All right, so that's what all there is to substring. But the tricky thing, in my opinion, is just knowing that you can combine them. So it takes a little bit of getting used to, but again, the way it works is whatever is on the inside first will be evaluated. So substring will happen first, and then that will be concatenated with this. So that's it. We have a couple more, and then we'll do some challenges. The next built-in string function that we'll work with is called replace. And what it does is it replaces parts of a string. So if you wanted to get rid of a certain occurrence of a character, or you wanted to replace all spaces with commas or something like that, you could use replace. And the syntax looks like this. Here's an example where we have the string hello world. And you know what? I just realized this again. That's a bad word right there. So if we wanted to get rid of that, we could use replace hello world, comma, what we're trying to remove, and then what we want to replace it with. And it will do that to all occurrences. In this case, hell only occurs once. So that's what our output looks like. Percent star octothorpe. Oh, what's this thing called? There's an actual name for it. The @ symbol, but there's a real name. And then O world. So if I copy that over and just run it now, you can see that's the output that we get. We could also do something like replace hello world, and let's just replace all L's with 7s. Why not? And that's what we need to do there. And then we get hello world, but with 7s instead of L's. You know, we could do the same thing, just to show you one more, with O's and replace them with 0. Now, one thing that is important to pay attention to, let's say I have hello here with a capital O and hello here with a lowercase o. Or excuse me, world with lowercase. So the idea is just I have upper and lowercase O's in here. If I try and replace O, and let's say I just want to replace it with, let's do an asterisk. What do you think will happen? And the answer is it only replaces exactly this character. So it is case sensitive. So it didn't touch this capital O here. So that's one way to use replace. The other way that I mentioned is that it can replace multiple things. So here's a silly example where I have a string cheese, space bread, space coffee, space milk. Maybe it's a grocery list or something. And I want to replace all spaces with the string and, well, space and space. Basically, the output will be cheese and bread and coffee and milk. It inserted that right there, here, here, and here, every time there's a space. So if I try running that, you can see it works. Cheese and bread and coffee and milk. So now let's do something with the book data we have. We'll do something really simple and similar to what we just did. Let's replace all E's with 3's. And we'll just do lowercase e. So anytime there's a lowercase e, like namesake, Norse, American, we'll replace it with a 3. So to do that is a select, replace, and don't ask why. It's not really a real world example, but select, replace, we want to do title. And then what are we trying to replace? Lowercase e's. What do we want to replace them with? 3. And then what table? From books. And we could get more specific, but let's just do from books. And you can see we get the namesake with 3 3's and all the way down. Consider the lobster, cannery row, and so on. And that's pretty much it to using replace. A bit of a bonus at the end here is that I'll show you we can combine replace with other functions like we've already seen. We use concat and substring together. So we could try the same thing by using replace and concat, for instance. So I could do something like, if I work in this book code, I will comment this out, which I haven't shown how to do yet, highlight it, and on a Mac it's command slash. On a PC I believe it is control slash. So I'm going to comment it out, which means it just won't run. It's here so I can see it, but SQL treats it, or MySQL treats it as if there's nothing there when it runs it. So what I want to do now, I want to combine replace. So what I'm going to do is select, and I'm just going to fill in some rough blanks here. So we have replace, and then we're going to have from books. But what we want to do is not just replace things. I'll do the same thing where we replace all E's with 3's. So that's replace title, the lowercase e with 3, like that. But I'm only going to take the first 10 characters like we did with substring. So I need to do substring, and I want to do substring of this whole thing. And I'm realizing as this goes on, this is a little convoluted, so I'll throw up another don't panic here. This is more just me showing you that it's something you can do, but it's not essential that you wrap your head around this entirely. But just to show you, so substring, and the first argument is replace this whole thing. So basically, we're taking a substring of this and then of this, and we want to go from 1 to 10. So that's a lot there. And now, if I paste it in here, you can see what it did was first replace all E's with 3, and then take the substring of that from 1 to 10. And of course, we could give it a better name because it is pretty ugly. So we could do as weird string, let's say. And now we have weird string up here. And yeah, that's pretty much it. I just wanted to show that we could combine them together. Why you would do this exactly, again, you probably wouldn't. But the key here is that they're kind of like Lego pieces. You can reorder them. You can, maybe more like nesting dolls actually, where you can nest them inside of one another. So like we did substring inside of a concat, we can do a replace inside of substring. So that's enough of replace. We're going to continue with a couple more, and then we'll do some challenges. All right, moving along to the next function, which is reverse. And reverse does what it sounds like. It reverses strings. That's why I said it's super straightforward. Forward, reverse. It's a joke. Yep. So that's what it does. It will reverse a string. So here's an example. Select reverse of hello world, and we get this. Ole. I think it's probably best if I just stop pronouncing them from here on out. But you get the reversed version of the string. Same casing and everything, same spaces, just reversed. And that's kind of all there is to it, to be honest. I'll show you a couple examples, but if you feel like you already have it, that was enough for you and you understand how it works, then feel free to just move on. But I'll go over to Cloud9 and show a couple of examples. So let's do a select reverse, and instead of hello world, let's just do meow. Meow, why not? Just like that. And we get what? Oh, I said I wouldn't pronounce them. Well, we get this right here, reversed of meow meow. So we could do the same thing to find the reverse of every author's first name in our table, for instance. So that would be a select reverse author F name, and then from books. And there we go. We get the reverse of Jumpa, the reverse of Neil, and so on. And that's kind of it. And just like some of these other ones, we can combine them. So if I wanted to turn something into a palindrome, for instance, let's say I started with the string woof. And if you're not familiar, a palindrome is something that reads the same forwards and backwards. So the way I would do that is by adding FOOW to that and concatenating them. So taking the original string plus the reversed string and concatenating them. So we have two functions. We've seen how to do that. And it's just a matter of concat. So a select, concat, and we'll just start with woof. And then what do we want to concatenate it with? Well, we want to concatenate it with the reverse of woof. Just like that. And that should do it. Let's try it out. And we get this, the palindrome version, I guess, that we just made, this sandwich. Now let's just try it with authors' first names again. So let's do that now. All we need to do is replace a couple things in here. So rather than concatenating woof, we're going to do author F name. And then we're going to use the reverse of author F name as well. Just like that. And then, of course, we need to say from where? From books. Let's copy that. So just again, we're taking the author's first name, the reverse of the author's first name, and we're smashing them together with concat. And there we go. We get, this one's kind of funny, I guess, David, Diva, D. And I don't think any of them are really pronounceable otherwise. But they are valid palindromes. So I guess we succeeded at something. The next function we'll take a look at is pretty quick as well. It's called char length. And what it does is it just tells you how many characters are in a given string. And that's pretty much all there is to it. So it looks like this, char underscore length. And when we do it on Hello World, we could count the characters. So 1, 2, 3, 4, 5, 6 for the space, 7, 8, 9, 10, 11. And we get 11. At least my slide says we get 11. Let's verify that. Can't trust those slides. Whoever made them. Me. So you can see we get 11. So if we changed it and just added a bunch of stuff, we won't count it, but it says that's 31 characters long. Okay, so we could do something like select, and let's just print out the author last name this time. So author L name, comma, then we'll also side by side print the character length of the author's last name. So it might say something like Carver, and then next to that, 1, 2, 3, 4, 5, 6 characters. And Eggers, also 6 characters, and so on. So it's just going to be our author's last name followed by the number of characters in their name. So character char length, author L name, just like that. And let's put an as here, and we'll just call it length, just like that, from books. We'll hit enter, and you can see we get this nice little table with our author's last name and the corresponding length. So we've got a lot of authors who are 6 characters long, or their last name is 6 characters long, and then we get Smith, who's the shortest, and so on. We'll see later on how we could sort things and order them differently, but for now, we've got them all here. All right. So just like before, if you feel like you have a grasp of this, feel free to move on. I'm just going to show that we can also combine character length. So what I would like to do is end up with a result that looks something like this. Eggers is, and then 6 characters long. So I'd like that for every author that we have. So if we break it down, this is going to be author's last name concatenated with is, concatenated with the character length, concatenated with characters long. So it's going to be kind of a big one. So let's try it out. We're going to do a select concat, and the first thing we'll concatenate is the author's last name. So author L name, and then we're going to concatenate that with space is space. So that gives us this right here. Then inside of that, we're going to add char length of author L name. You can see this is getting kind of long, comma, is, not is, space, characters long, and our parentheses. So that's kind of a lot here. We're concatenating the first thing, the author's name, and then adding is, and then adding the character length, and then adding characters long. So we're building this sentence one piece at a time. And then we also need to specify from books. Okay, so let's take a look. Let's copy this, paste it in, and there we go. Lahiri is 6 characters long. Carver is 6 characters. Steinbeck is 9 characters. Foster Wallace is 14 characters. So that's working. By now, you should know we can use as to make this a little prettier. The only other thing that I'll take a moment to address is that this is kind of ugly. It's something that I do often to format MySQL, meaning my personal SQL, not MySQL, the database, is use one of these formatters. So there's a couple of them. I like this one, sql-format.com. And I can paste in my query and just click format. And it will just format it a little nicer for me. And it depends on, when things get really long, when you have long create tables, it will clean things up nicely for you. So in this case, this is the cleaned up version. Not that much of a difference, to be honest. But we can replace it anyways. It's a little easier to read. All right. So that's all there is to character length. That's all there is to char length. All right, welcome back. So we've made it through a lot of string functions. We've seen concat and replace and substring and reverse and char at. We have 2 more that I'm combining into one video because they're really simple and straightforward and they're a natural pair. And then after we finish this, we have some fun exercises. So the 2 that we're looking at are upper and lower. And they do what they sound like. They change the case of a string. So we can make something all caps or all lowercase letters. So let's take a look. What do you think this will do? By now, you should be familiar with this select and then some string function. So select upper hello world is going to convert hello world to all caps. And just to prove that, let's go over here and do it. And we get hello world in all caps. Likewise, select lower hello world will convert everything to be lowercase. So it's really just the H and the W. And we get hello world. Still don't believe me? Okay, there we go. Hello world. So honestly, that's pretty much it. Just like the other couple videos before this, if you feel like that's good enough, go ahead, move on to the exercise. But if you want to see me use it with some of our author data, stick around. So let's do something silly like print out all book titles in all caps. So to do that, it's just select upper title from books. And that's it. And of course, we can combine it with other things. So we could do something like my favorite book is, as if someone was yelling. My favorite book is, and then a book name, like the namesake. And to do that, we need to combine the uppercase version. So I'll start writing it here, upper title. And we need to concatenate that with this string right here. And to concatenate them, kind of building backwards here, we need to use concat. Just like that. So concat, my favorite book is, and we should add a space, the, and then the uppercase version of title. And then we'll just add a select concat from books. So I kind of built that one in a different way, starting from the inside out. But you can see we get my favorite book is a namesake. My favorite book is a circle. My favorite book is the Cannery Row. Yeah, I'm not sure why I put the there. Whoops. Well, anyways, if we delete that extra the and rerun this, now it's grammatically correct. So that's pretty much it to upper and lower. I mean, we could change this to be lower fine, if you make me, I'll show it. I don't think there's any surprise about what will happen, but just in case, it just converts everything to lowercase. Okay, so that's upper and lower. That was a lot of stuff. All these different string functions we saw. Now it's time for you to get some practice doing it yourself. Okay, so you made it to the end, hopefully. I mean, I guess you could have skipped forward, but you made it to this video, however you got here, at the end of the string function section. So we have a couple of exercises. And they range from pretty straightforward to reasonably complex, where we combine multiple string functions together. So let's get started. The first one here is to reverse and uppercase the following sentence. Why does my cat look at me with such hatred? I would also appreciate an answer to that if anyone can help me. But anyways, what we need to do is just take this, you can copy it or type it out, and just use MySQL. I should specify, don't just manually reverse it and type it uppercase. I mean, using what we just learned, how can you reverse and uppercase this? All right. Then, when you're done with that, the next problem. This one's a little different. You don't have to actually do anything. I want you to figure out what this prints out. So don't just cheat and copy and paste it. You can do that to check your work, of course, but try and work through what's actually happening. We've got a select, we've got a replace, and a concat, and some words and spaces and symbols and dashes. So give it a shot. Then move on to the next one here, which is to replace all the spaces in book titles with this little arrow. It's a dash greater than sign. So replace every space. So instead of the space namesake, it's the dash, or let's just say arrow, the arrow namesake, and that happens for every space. And one more thing I'll call attention to is up here, it just says title. So you're going to need to use as to make sure it says title. So basically your task is to just get this same data printed out, this exact same format. Then after that, print this out. So you're going to have the author's last name printed regularly forwards, and then next to it, you'll have the same author's name printed backwards, in reverse, you might say. So that's what you need to do. Also pay attention up here, it says forwards and backwards. So you'll need to use as again to do that. Then once you do that, the next one, I'd like you to print out a full author's name. So it's a little more complicated in caps. So we want Jhumpa Lahiri, so that's author first name and last name combined and uppercased. And that should happen for every author. And then also, again, the name appears, or the header says full name in caps. All right, then make this happen. So what this is showing is a title, the namesake, and then was released in, and then the actual date that we have stored in our database for when it was released. So you need to combine a title, was released in, and then the year it was released. And again, I called it blurb, but just put some label up there. Then next one here, print book titles and the length of each title, which is pretty similar to what I did using authors' last names. So just print the title and then the number of characters in that title. As you can see, some of them are quite long. The only other thing I would say is up here, pay attention, we have character count. So use as, you get it by now. Then finally, this one combines 3 different pieces of data. We'd like to have a shortened title. So I believe this is 10 characters, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, so the first 10 characters and then a ... afterwards, and call that short title. Then we'll have the author printed out, but the way it should be printed is last name, followed by a comma, followed by first name. And then quantity. So quantity should not just be the number we have in stock, but it should be the sentence, 12 in stock or 104 in stock. So there's a lot of pieces here, and each one of these 3 is going to require multiple string functions to make it work. So give it a shot. This one is a little more challenging, so don't panic again if you don't get it. But try them all out. And then in the next video, we'll have solutions. Okay, let's go through some of these solutions. So the first one, reverse and uppercase this following sentence. Why does my cat look at me with such hatred? So I'm just going to copy it. And the first thing I'm actually going to do is make a new file. So I'll come up here and do new file. And I'll just call this exercises.sql. Then in there, I'll paste this. And we know that we need to do two things. We need to reverse it in uppercase. The order doesn't really matter. So we need to do a select first, either way. Select reverse, and we're going to select the reverse of this. And then we can do upper here, just like that. Or we could switch them and do select upper reverse. But let's give it a shot. And I'm missing my quote there. Let's get out of here. Missing that closing quote. There we go. Try it again. And there we go. It's reversed and all uppercase. So now I'm going to comment that out, and we'll move on to the next one. What does this print out? So let's start on the inside. Concatenate I with space with like space and cats. So it will be I like cats, the sentence with spaces. But then we have a replace, and replace is going to get rid of all those spaces and put dashes. So it should be I dash like dash cats. Let's try it. There we go. I like cats with dashes. So that one's really just testing that you understand how these are actually executed and that you can stack or nest multiple functions. Next up, we have our first one really working with the books data. So replace all spaces in book titles with the arrow. So we need to do a select, and we know that there's going to be a replace, and we know that it's going to be from books. So let's start with that. So what are we replacing? Well, we're looking for all titles, and we're replacing a space with the arrow. Double check, replace spaces with arrows, that should be good. And the other thing was that up here we had title. So we need to use as title. So let's copy it, make sure it works. There we go, title, the arrow namesake, Norse arrow mythology, and so on. I'll comment that one out, and we'll move on to the next one. Print this out. So we should have forwards and backwards, and this is last name printed regularly, and this is last name reversed. So let's start. We know we need to have a select, and the first thing that we know is that we're going to have author L name as forwards. Just make sure I have that. So that will give us this right here. And let's close off. Let's do from books, just like that. So we could start with this if we wanted. And we get that left portion. Now we need this right portion. So we need a comma because we're now selecting two different things. And what we want to do here is use reverse author L name as backwards, just like that. Let's copy it. And there we go. Forwards, backwards, regular last name, reversed last name. All right, comment that one out, and we move on. This one, we need to print a full name, so first and last name of the author, all in caps. So there's a couple ways we could approach this. The easiest way is just to capitalize one string. So we combine the two, first and last, and then capitalize. If you wanted to, though, you could take capital first and then capital second, capital first name, capital last name, then combine them, and that works just as well, but it's easier to just do it once, and it's also faster. So the other thing is we have full name in caps up here, so we need to use as. So let's start by printing full name. So we have a select from books, and what we need to do is concat, and what are we concating? Author F name, comma, author L name. And I'll leave it like this for now, but hopefully you can predict what the problem is. When I do that, we don't have spaces. So let's add our space in. And that should give us the concatenated version. And well, if we add the right comma, Now let's try it. There we go. So we get Jhumpa Lahiri, Dave Eggers, and so on with the spaces. So now what we want to do is just uppercase that. So we could do it on the same line because uppercase is so short. We can just say upper of that, copy it, paste it in. We also need to rename this up there. So we need as, and what did I call it? Full name in caps. So there's spaces in that. So we need to use quotes, full name in caps. Copy that. There we go, full name in caps. And if we want to format a little bit better here, we could do this. Just like that. And it will work just the same. Okay, let's comment that one out and move on. Make this happen. So what we have again is the first name, the title was released in, and then the year. So we're going to need to make use of concatenate. So let's start off with our select, and we'll have a concat, but we will also have from books, just like everything else we've done. So what are we going to concatenate? Well, first is the title. After the title, we have space, was released in space. So we need those spaces, comma, like that. And we could just start with that if we want to take a look. And we get the namesake was released in, Norse mythology was released in. Then we just need to add in the year, comma, released year. And we haven't really worked with the year in a while, so if you forgot what the name of that column is, earlier when I was recording something, I ended up having to redo it because I was referring to year rather than released year. So you could just do a describe books and see that, okay, it's called released year. All right, so then we'll copy that in, paste it, and we get the namesake was released in 2003, and so on. The only thing we need to change is this up here. It's supposed to be called blurb, as blurb. And there we go. So we're done with that one, comment it out. Next up, print book titles and the length of each title. So printing the title is easy. Then we just need to use char length and print the character length. So let's do that now. Select from books, and what do we want to select? Well, first we want title, and then after we select the title, we want char length. And one thing I should highlight there is that because this is a SQL file, you might have noticed I get these autocomplete suggestions. So I can either click or I can hit tab. And that's much faster in my experiences to hit tab. So we want the length of the title. Just like that. And we get the namesake 12, Norse mythology 15. And that's what we want, except we need character count. Just like that. However, this will cause an error. Whoops. We need to put it in quotes because there's a space there. Now we give it a shot, and it works. All right. Last one, I promise. So this one is more complex. 3 different things we're selecting. Each one is complex on its own. So let's tackle the first bit, the short title. So we want first 10 characters of the title plus ... So we'll comment this out. We'll do our same select from books. And we'll start by selecting the first 10 characters. So that's substring, or if you're lazy, whatever. Let's do substring. And we want it of title from 1 to 10, just like that. So that should just give us, at this point, you should know what it does. Gives us the first 10 characters, but we also want to concatenate that with ... So we'll do that here. Concat with the string ... not comma, comma, comma. We want ... And now if we copy that, that works, but it's supposed to be called short title. So we add as short title. And we just triple check our work. Looks good. Now we have our next thing we're selecting, which is the author, but we want last name, comma, first name. So it's going to be another concat actually, and we'll start with the author L name, comma, a comma in quotes, kind of hard to talk about, comma, 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 but this comma here is actually going to be concatenated in. This is quite a string to look at there. Author F name, and we want it to be as author, so we don't have to use quotes for that. Let's try it, see if we made any mistakes. It looks good. So we get Lahiri, comma, Jumpa, Gaiman, comma, Neil. That's what we expect. And it's called author. Good. Finally, we need this last portion, quantity. And this should be the number in stock followed by the string in stock. So if you don't remember what the column name is, we can do describe books. And you can see, okay, we have stock quantity. So that's what we want to use. So this time we're starting off with stock quantity, comma, and then we want space in space stock. Just like that. And then we need to use as quantity. Boy, it's a long one. So let's try it out. Make sure we didn't do anything wrong. And that looks good. 32 in stock, 154 in stock. And then we have author and short title both working. Now, one thing I want to point out here, that stock quantity is a number, it's an int, but it doesn't break everything. Concat is okay with numbers like this. What it does is it just takes the string version, the text version of 32 and adds it to in stock. So it basically does this, 32 plus in stock. So that's very different than trying to add a number to text. All right, so that was a lot, I know, but we're done now. We're done with these string functions, and we're moving on. Hey, welcome back. So this section, as you may have guessed, we're continuing on with our books data. We're not doing cats, we're doing books. And primarily what we're going to do is focus on some more advanced MySQL features. Things like limiting the number of results that we get back. Instead of 10,000, I want 5. Then we'll see how to do things like sorting our results. I want the top 5 books sorted by sales or sorted by title alphabetically or by genre. All sorts of things we can do. And then from there, of course, at the end, we're going to have some fun exercises and challenges to wrap everything up. So let's get started. All right, welcome back. So in the last couple of sections, we focused on select, and we're going to continue that trend. In this section, we're going to talk about some of the other tools that we'll be able to use to get more specific when we're selecting things. So we'll be able to do things like sort our results that we get back in alphabetical order or reverse alphabetical order, or limit the number that we get, or only get unique results back, and a bunch of other things that we'll be able to combine and use just as other tools in our arsenal, or weapons rather, in our arsenal. So before we do that though, I want to start by just adding a little bit more data to the books that we're currently working with. Basically, I want to have a bit more variety. So I'd like to insert 3 new books, and they look like this. So we have one here, 10% Happier by Dan Harris, released in 2014. We have 29 in stock, and it's 256 pages long. You'll see why we have that, why we're inserting that in just a couple of videos, but there is a reason. We're going to come back to it. And then we have a fake book. So just imagine that we're testing our system or something, and we want to make sure it works. So we have fake_book. And then that's written by Frida Harris in 2001, 287 copies in stock, 428 pages. And then this is actually one, so I haven't read either of these, but this is one I just finished. And that's one of the reasons I added it in. There's another one though. It's really good, by the way, if you're looking for a book, called Lincoln and the Bardo by George Saunders, released just this year. And we have 1,000 copies in stock because it's brand new. So we haven't sold any, or we haven't sold many yet, or maybe we're anticipating a big flood of sales, and it's 367 pages. So either type that up or copy and paste it in. The code's available along with this video. And we're going to just copy and run over here. Make sure that let's make sure we're working with the correct database. All right, in Bookshop, and we'll just paste that in. Insert into books, blah, 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 blah. We don't need to go over everything. All right, so we get 3 rows affected. Let's do a select title from books. Just make sure that we have those in there. Here we go. We had up to Consider the Lobster in the last section. Now we have 10% Happier, Fake Book, and Lincoln in the Bardo. All right, so that's all I wanted to do here. I highly recommend that you go and do this if you want to follow along. It will make the exercises much easier. It will make them possible in the first place. And you'll be able to type the code that I type on your own. So I highly recommend that you do it, but I guess you could just watch if you wanted to. So without further ado, let's get on to the new stuff. Now then, I don't really like now then. I use all right too much. Okay, how about up next? We're going to talk about distinct. So distinct is something that we use in conjunction with select. So when we're selecting data out, let's say we're doing something like give me all book titles from the database. And we may have duplicates in there. And we would get all those duplicates because we just asked for all titles. But if I say give me all distinct titles, it will do what that sounds like. It will only give us the distinct or unique titles. So without further ado, let's take a look at it in use. So here's an example. The first thing that you should notice is that distinct comes right after select. So we're saying select author last name. So there's a bunch of authors, and in our table, some books have, or some authors have multiple books. So David Foster Wallace, for example, has 2 books in there. So when we say select author last name, we get 2 results. We get David Foster Wallace, and then again, if we're only doing last name, we get Foster Wallace and Foster Wallace. So if I wanted to know only the unique or the distinct author last names in my books table, I would write this query here. Select, and the only thing that's different is the distinct. So select distinct author name from books. So let's try it out. We'll go over here, make some space, and let's just start, just to show you what I'm talking about, by select author without the distinct from books. Just like that. And as you can see, we have Gaiman, who's in here twice, Eggers is in there twice, Carver is in there twice, Foster Wallace is in there twice, and Harris is in there twice. However, there's something kind of weird about Harris that we'll take a look at in just a moment. So if we only want to just get a survey of all the authors in our database, but we don't want duplicates, it's as simple as select distinct author lname from books. Just like that, hit enter. Now it's much shorter because those duplicates are gone. So now we only have 1 Gaiman, 1 Eggers, 1 Foster Wallace, and 1 Harris. And of course we could do that for other things. So let's try it for years. So we have select released year from books. You can see, let's see, are there some books that have duplicates? So for example, 2003, there's 2 2003s at least. I think there's at least 1 more when I designed this or when I created the data. But let's just focus on 2003. So there's 2 of them there. So if we do a select distinct released year from books, our list is shorter, and now we only have 1 2003. So the reason I show it to you is not just to show you another way or another example, but also we're working with numbers here, and that's important to remember that released year is an int. It's not a varchar, but distinct still works. There's one more advanced thing that I want to talk about here, which has to do with when we did our select. Let's start again with author lname from books. When we did this, remember that and actually let's do author fname and lname. So when we did this, remember we have Neil Gaiman twice and Dave Eggers and so on, but then there was Dan Harris and Frida Harris, 2 different people, 2 different authors with the same last name, which is a pretty common situation. So when I do distinct, select distinct author L name from books, it reduces them, to just the distinct last name, which is what you would expect. It only gives us Harris once, which makes sense. We're asking for distinct author last names. But what about distinct full names? What if I want every distinct author's full name printed out? So basically, what if I just want to know how many distinct authors there are? Not just based off of last names or just first names, but both need to be distinct. So that, Dan Harris is distinct from Frida Harris. There are a couple ways of doing it. One, you already know at this point. You can use concat. So I'll show you that now. What we could do is concat author F name and author L name, and then ask or select distinct versions of those. So if I make a new file, this one won't be too long, but I'll make a new directory first, and I'll just call it refining selections. You don't have to do this, but I'm getting a little messy in here, so I want to make a new file in that directory, and I'll just call it distinct.sql, the most important part. Okay, so in here, right now we have our select distinct author L name from books. So let's start off by just running this, make sure that our file is working. One thing I will point out, I don't recommend putting spaces in your directory names. It's just not a great idea. So I'm going to edit that. It won't break anything. We can still do it, but it's just not great. So let's just do like that. Refining elections, well, that might work too, but refining selections. Alrighty, so if we want to run it, it's a source refining underscore selections / distinct dot SQL semicolon, and it works. Okay, so back to the problem at hand. How do we actually get just distinct authors, first name and last name? So what we could do, I'll comment this out for now, is a select, and then we can concat author first name and author last name, just like that, from books. And if we save and run that now, we get this. And if we try and do distinct on that whole thing, that works. We get Dan Harris and Frida Harris are distinct. And we only have one Neil Gaiman, one Dave Eggers, and so on. And of course, we could go add the space that we want there and try doing it again. And that gives us distinct full names like this. That's one way, but there's actually an easier way. And that's using distinct. We just do a select distinct. And if you do author, we can do F name first or L name. Just separate them by a comma. And we try running that now. You see, we only get unique rows back. So it's basically applying distinct to the entire row. So in this case, it's basically saying I want the combination of the first name and last name to be distinct. So that's why we end up with one Neil Gaiman, one Dave Eggers, and one Dan Harris, and one Frida Harris. So it works in that way. The only difference here, aside from this being longer, is that here we're actually just combining them and checking if it's distinct. Here, MySQL is doing that for us. And it depends just how you want your results printed out. If you want them combined as a full name, then this method works better. And if you just want to keep your data separate in two different columns, then this is much easier and a little bit shorter. All right, so that's pretty much all there is to distinct. At its core, it's pretty simple, and it's powerful too. It's something we'll use quite a bit throughout the course. As our data gets more complicated, we'll also have more duplicated data, which isn't a bad thing. But sometimes when you're trying to understand it or work with it, you only want distinct data. So you use distinct. All right, I should shut up. Moving on along to our next topic. I guess that's okay, moving on along. I'll keep using that. Our next topic here is order by. So as the subtitle tells you, it's how we can sort our results, which is something that we'll want to do. Hopefully you see why that's useful when you're trying to understand things. It's good to be able to sort your data. So with our books, for instance, right now we're getting them all in the order that they were inserted in. And maybe we want to do things like find the best-selling books or the worst-selling books, or Find the most active users on our website or the least active users or something similar. Find the most upvoted posts or the post that has the most comments on our blog or whatever we're working with. It's important to be able to sort things. And again, the way we do that is by using order by. So let's take a look at an example. Here's a query that's going to select all the author last names from books. So up until this point, nothing is new. Select author last name from book or books. But after that, we add on this little thing, order space by. That's something that trips me up, by the way, that there is a space. Sometimes it feels like it should be one word or there should be an underscore, but there's a space. Order space by. And then what do we want to order it by? By the last name. So let me show you. If we go here, we just do a select author L name from books. This should be review. What we get them in the order they were inserted. So that's not alphabetical at all. So if we want to do alphabetical, select author L name from books, order by, and then we have to say author L name, just like that. And as you can see now, we have Carver up top, all the way down to Steinbeck. And you should notice it is sorted by default in ascending order. So from C or A, technically down to Z. And it's actually alphanumeric as well. So if we do titles, for instance, let's just do select title from books. We've got a title that has an A at the beginning, but we also have 10% happier. So if we do this, select title from books, order by title, you'll see we get the 10% happier first before the A's and all the way down to W. So as I mentioned, it is ascending by default. So if you don't specify an order, it just assumes you want ascending. But of course we can change that, as my slide says, by just providing one thing at the end. So everything up until this point is the same. Select author L name from books, order by author L name, space, DESC. And in my opinion, this is also something that's kind of confusing because it's DESC, but then the abbreviation for ascending is ASC, which is only 3 letters versus 4, but that's just my opinion. So let's try it now. If we recall what we had, select author L name from books, order by author L name. There we go. This is the original in default ascending order. But if we add DESC, you can see it's reversed. Now it goes from Steinbeck down to Carver. Or if we do the same thing with our title, and we just add on DESC, it now goes from white noise down to 10% happier. And of course, order by will also work with numbers. So it's pretty common that we want to sort things numerically, whether it's, the number of orders or sort the highest priced items, or like I said earlier, sort the blog posts by whichever have the most comments, most to least, or something like that. Those are numeric values. So to do that, it's the exact same syntax. All that we change is what we're ordering by. So in this case, released year, which is released year, which is an integer. Select release year from books, order by release year. So let's try it out. Let's do a select release year from books without the order by. And they're in all sorts of crazy order. I think our lowest one is 1945 all the way up to 2017, which is that Lincoln in the Bardo book. Definitely recommend it still. So if we recall that line and just add on order by released year, there we go. And by default, it's also ascending, 1945 up to 2017. We could reverse it with DESC, just like that. And just to prove to you, you can do this. You can be explicit with ASC, ascending, and get the same order if you left it off. And not to harp on this too much, but I don't like that this is 4 letters versus 3 letters. It should be consistent. So if we leave it off, though, we get the same results. Okay, so that's the basics of order by. Another thing I'd like to highlight here is that we've been doing things like select released year, order by released year, where it's matched. What we're selecting is matching how we're ordering it. you don't have to do that. So let's say we wanted to get, let's say we want title and year, released year, that is, and pages, why not? And I want all three of those from books, order by, and we'll do released year. So I can do that, and it's going to order them by the release year, but still gives me all the data. So it's not like, it has to match. Or I could even leave release year out of this entirely. I don't have to select it, but I can still order by. So I could select title and pages and order by the released year. You can see the first one we get is Cannery Row, and the first one we got here is Cannery Row from 1945. And the last one was Lincoln in the Bardo, 2017. Last one is Lincoln in the Bardo, 2017, even though we don't have the year actually printing out. So that's all I want to show there, that you don't have to be ordering by something that you're selecting, or that it doesn't have to be the only thing that you're selecting. So here's another little quirk of order by. If you take a look at this query, select title, author F name, author L name, and I put this on 2 lines here, not because it's correct to do that, but just so that it's easier to read for you. So select title, author F name, and author L name from books, order by 2. What do you think the 2 refers to? Well, in this case, it's actually just a shortcut. So we don't have to rewrite author F name. So if we're selecting title, author F name, and author L name, this will be 1, this is 2, and this is 3. And it's a shortcut for me to say order by 2, author F name. So let's copy it over, try running it, and you can see the results we get back. They're not sorted alphabetically here, even though it sort of looks like it because we have 10% happier and then a hologram for the king, 10 and then A, but it's not. The rest of the way is not. But you can see over here, we've got Dan first, and then David, Dave, Data, Don, Frida, blah, 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 down to Raymond. And if we wanted to sort instead by last name, we just change it to 3, again, because author L name is the third thing that we're selecting. And now we go from Carver down to Steinbeck. And likewise, we could change it to 1 to sort by title. And we could also switch it over to descending, and that works. And if we did switch the order here, just to show the order does matter. So if I do author L name, comma title, if I want to sort by title, I would need to do 2 now. And now they're sorted by title. Okay, so there's one last thing, and I made a slide to remind myself about it, which is this here. So what we can actually do is sort by or order by 2 different columns, which seems like something that you wouldn't really do that often, and truth be told, it's not, but I just want you to know that you can. So to show you what I'm talking about, let me first do a select, and I'll make a new file for this one as well, just because we're going to have a little bit of code. Let's do new file. I'll just call it order underscore by.sql. Okay, and if we do a select author F name, comma author L name from books, just like that, save it, and we need to do our source order by.sql, just like that. And I forgot the directory, refining selections / Okay, so when I do that, we get first and last names, so not sorted. So now if I do an order by author last name, and I redo it, everything looks good. We have our authors sorted alphabetically, Carver, Gaiman, Harris, but then that's where we run into our problem, which is Harris. And it's not really a problem, but if we wanted our authors sorted alphabetically, technically when there's 2 authors that have the same last name, and we want the entire author name to be sorted alphabetically, well, then we need to go to the first name. And in this case, Frida Harris is in front of Dan Harris, even though D comes before F. So we want Dan to come before Frida. And that's where this comes in handy. We can sort, after we sort by last name, then sort by first name. So it's not going to redo everything. It's going to keep basically the initial sort and then sort first name if there's any conflicts. So we can just add that in as a comma, author, F name, and save. Now, if you just focus here, so we have Frida Harris and then Dan Harris. And if I source that and run it, you can see it just switched. So everything else is the same. Carver first, Steinbeck last. But now Dan Harris comes before Frida Harris. All right, so that's actually it to order by. I saw a lot there. It's a little bit dense. I apologize. But order by is useful. Like I said, you'll be sorting lots of things, and it helps you understand your data, especially when we're talking about sales data or site-specific data. There's a lot of insights that you can get just by putting it in an order. Next up in our toolbox is limit. So limit allows us to specify a number for how many results that we want to select. So I could say things like, I want the first 2 best-selling books rather than all best-selling books, or the top 10 most recent books. So we often use it in conjunction with order by or sorting, because that typically is going to give you something meaningful rather than just saying, select all books and give me the first 2. Well, how is first defined? And we can do that. I'll show you that. If we do a select, let's just do title from books. The order that we get them right now, again, is the order they were added. So we have the namesake, Norse mythology, American gods, and so on. So I could limit this. And the syntax looks like this. I just add limit at the end, just like we added order by. Limit, let's say 3. And now I just get those first 3. So it's going to limit it to the first 3, whether they're sorted or not. It doesn't care. It just chops it off right there. So again, it's not that useful or that meaningful just to do it on its own like this. But we could do, limit 1, limit 10, and so on. And that's basically all that there is to limit. We can do it with a select star. If I only want, let's say I want everything about the first book. There we go. I get the namesake and there's everything about it. But more often than not, we're using it with order by. So here's an example. If I want the 5 most recently released books, I'm going to, and I only want the title and the release year in this case. So select title and release year from books. Then I'm going to order them by the release year, descending. And then I'm going to limit it to the first 5. So let's try it. I'll go ahead and make a new file again, limit.sql. And in there, I'll write a select title, comma, released year from books. I won't add limit yet. Let's just make sure our source is working. So we'll do a source, refining, why did I name this so long? Refining selections / limit.sql. Fortunately, you only have to type it once. Okay, so that's working. So now what we'll do is order them by that released year. So we'll do an order by, and we could write release year, and I will because it's more specific, or it's easier to understand. It's more semantic to write it out, even though it's longer. But of course, we could replace it with 2, as we just saw in the last video. So order by that release year. If I do that now, that gives us all the books ordered in ascending order based off of their year, which is not what we want. So we can switch that with DESC. There we go. And now I can limit it to 5. And so that limit comes last as well. So it's going to do everything and then chop it wherever you specify. So that's important to know. So let's try it now. Make sure I save. And there we go, the 5 most recent books. And of course, we can change this to whatever number you want. If you want the 1 most recent book, or if we wanted, let's say 14, we can do that. So there are a few other ways we can use it. For example, here's the same query. However, I've written it slightly different. So everything up until this point, right here, is the same. Limit. But this time I'm saying limit 0, 5. So if we just copy this, I won't make you watch me type that whole thing out. And I comment this out. and I try running this now, just take a guess. What do you think will happen? And here we go. It does the exact same thing. So this is a syntax that allows us to specify a starting point and then how many we want to go from there. So basically it's saying, and this is kind of confusing because it starts at 0. So the first row in a table is the 0th row. But then when we're dealing with strings, like when we had hello world, H is actually the first character in MySQL at least. So anyways, it's saying I want the first row and I want to go for 5 rows. So we could change that. I only want 3 rows this time. If we rerun it, it gives us the first 3 rows. But then I could shift it. Let's say I want to go, I don't know why, but the second row onwards. So it gives us Norse mythology, 10% happier, and the circle. If you didn't catch that before, when it was 0, we got Lincoln and the Bardo, Norse mythology, and 10% happier. When I change this to 1, it shifts the starting point. So it's not that, it's not common at all, but you could do things like 10, 1. And what this will do is go to the 11th book. Well, I need to save first. Now if I run it, it will give us the 11th book. And just to make sure that we're right there, if we rerun it now, we could count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we get fake book. So if you need to access very particular rows based off of order, that is a way that you can do it. It's just honestly not that common. Pretty much every time that I use limit, it's in a context like this. Limit 1 or the first 3 or the first 5 or something like that. But I'll give you a real reason you might use it. Let's say that you have a blog site that you've created and your blog has thousands of articles in it already. When a user visits the blog page, you don't show them all 1,000, or let's say 10,000 results all at once for every blog post that you've written. That would be overwhelming, and there's too much information to display. Most likely what you'll do is have the first 10 posts, and then I can click a next button, and it will load from post 11 to 20. And I can keep clicking next, and so on. You've probably seen that before. It's called pagination. So you can do that by, rather than selecting everything from your database, you could select from 0, and I only want the first 10. And then the next time through, you could select from 10, and I want 10 more, and so on. So that is a situation where you could use that limit and provide a range like that. But again, most of the time, I just use this, limit and then one number. The very last thing I'll show you is that this is actually straight from the docs for MySQL. I think it's really clunky and weird that they even specify this. If you wanted to select from one row all the way to the end of the table, so I want from row 5 all the way to the end, we might have however many thousand rows. There isn't a nice, elegant way of doing it. This is what you have to do. Select star for whatever you're selecting from whatever table, limit, and then where you want to start, comma, some gigantic number. And I'm not kidding you, I actually have it in the docs here. Where is that? Right here. To retrieve all rows from a certain offset up to the end of the result set, you can use some large number for the second parameter. So that's their official suggestion on how to do it. Select star from table, limit 95, comma, some gigantic number that you would know you never have that many rows in your table. So we could actually do that here. If we just do a select title from books, order by, and let's just say I want to go, we don't even need the order by, honestly. Let's just do a limit. And if we just do limit 5, that's going to give us the first 5. But if I want to go from 5 to the end, I can do limit 5 and then some gigantic number. And in our case, it doesn't even have to be that gigantic because we don't have that many books. But if I do that, it gives us everything after 5, or technically 6 because it starts at 0. So I could reduce this down. I could just do like 50, and it gives us the same thing because we don't have 50 books. So it just goes until the end. So that's it to limit. With all those weird things that I showcased and the odd situations and ways you can use it, the most common and the way that almost always that I use it is this. Just limit and then a single number. Alrighty, so that's it. Moving on to one more, and then we're done. For this section at least. We're not done with the whole course. All right, so we have one more video here, or at least one more tool for the toolbox before we get to the exercise at the end of this section. And that tool is something called like. And I'll start off by saying like is very useful. It basically allows us to perform better searching of our data. So if you think of when we saw how to use where would allow us to find exact matches. So I could do things like select star from books where title is exactly Harry Potter and the Sorcerer's Stone. But what if I wanted to select all Harry Potter books? I would want to do something like select star from books where title contains Harry Potter or starts with Harry Potter or something like that. And we don't have a way of doing that yet until now with like. So like allows us to do things like this. Imagine someone comes into your bookstore, if we have a bookshop, and they say, there's a book I'm looking for, but I can't remember the title. I think the author's first name is David, or maybe it's Dan or Dave. And you could go over to your system as a really helpful bookstore employee, and you could just search for, let's say, books written by authors whose first name starts with DA, which I guess is a very broad category, but you could still do that. If you searched for authors at like a Barnes & Noble or a Popular Bookshop or Amazon, you can do that type of search, and it will work. It's just not that common. But we could do the same thing for books, like I said. Harry Potter is a good example where we want to search for all the Harry Potter books, not just the exact one word for word matched or character for character matched. So that's where comes in. Now, I'll warn you, it's going to look a little bit odd when I show it to you, but that's okay. It's not that complicated. There's just some weird symbols here. So here's an example of using like. This is ignoring the first part of the query, the select star from, or the update, or the delete, or whatever it is. So blank where author f name like, and then in quotes I have this %, DA %. So I'll tell you first of all what this is going to do is find where the author's first name has the letters DA in it. And these little things here, those percentage symbols, kind of like that animation there, those are known as wildcards. So that's basically the way that we specify we want to find author first names where there's something, anything at all. It's a wildcard. So any characters, and then these two exact characters, DA, and then anything afterwards. So it's basically a way of saying whatever blank, anything, DA, and then whatever anything else afterwards. And if we try using this right now, actually, you'll see what happens. If we go over here and we do a select, and let's just do a title and author F name from books where, and then we'll do author F name like, and then this is where we need those wildcard symbols, and we'll put DA in between. So once again, this is saying anything followed by DA, exactly DA. So it can't be D and then S and then A. It has to be DA and then anything afterwards. So if I hit enter now, you'll see that it works. We get these authors, Dave, David, Dan, and Frida. And you might notice, well, Frida, that doesn't start with DA, and you would be right. It ends with DA. But it still meets this query's it still meets the conditions for this query, which is anything DA anything. So in this case, it's FREID or FREI is meeting this, and then we have DA, and then this wildcard, there's nothing afterwards, and that's perfectly fine. This is not saying there has to be something after the D and the A or something before. As you can see, we're matching DA VE, so there's nothing before it, that's fine, then DA, and then VE afterwards. So basically this is all about pattern matching. And if we wanted to refine this so that we only get author first names that start exactly with exactly with DA, we can do it like this. All we do is leave off that first wildcard, that first %, and that says I want to find author first names where they start with DA and then anything afterwards. So it could be Dana, David, Dave, Dan, Darwin, whatever. So if we just make that one small change and we delete that percentage sign, you can see Frida is gone. I'm sorry, Frida, because Frida no longer fits the pattern that we're matching. Also, it's important to note that it is case insensitive, as you can see. This is lowercase d and a, and it still matches all these uppercase d's and lowercase a's. So if I wanted to do something slightly different, let's say search all books where the title has the word the somewhere in there. It's pretty simple. It's just a select title from books where title like. And if I just say the, that's only going to give me books where it's exactly the, and that's not what we want. So we want something followed by the, and if we just leave it like this, that's not going to give us anything, because this is specifying we want books where the title has anything and then ends with the letters THE. That's not really what we want. So we'll add another wildcard at the end, and now that gives us all the books that have a title that has something, then THE, and then something else afterwards. So you can see we get the namesake, a hologram for the king, the circle, the amazing adventures of Cavalier and Clay, Consider the Lobster, and then Lincoln and the Bardo. Really good book, by the way. I know I've said that like 10 times. It's a good book. So that's the basics of using like. These percentage signs are very common. I know it looks kind of odd, but this is really, really important. Think of when you're searching, I don't know, if you use Reddit, if you're ever searching for things on Reddit, behind the scenes, like is being employed. Or if you're searching on whatever site you search on, there's some form or variation of this like going on, where your query, whatever you search for, it's not only matching exactly. So when I search for, on Amazon, I type in, let's just go with let's say Lord of the Rings. I search Lord of the Rings. It's not only going to give me books that have a title exactly of Lord of the Rings. It's going to give me books that have Lord of the Rings in the title somewhere. Obviously, their search is much, much more complicated, where it also searches things like, through comments and reviews and related books. And there's this whole complicated graph network of how the search works. But the core idea, the simplest search that you could implement, uses like. So that's the basics. But there's another wildcard character that I'll show you, which is the underscore. So here I have a really weird query. This is 4 underscores in a row. You'll just have to trust me that it's 4, and it was hard to tell. What this will do, so we're searching stock quantity, which is a number, and we're trying to find where it's like 4 underscores. And basically an underscore is a wildcard to specify exactly one character. Any character, but exactly one. So 4 of them in a row is saying, I want to find where the stock quantity is 4 characters long. So let me show you why we might want to do that. If I do a select stock, let's do title and stock quantity from books, just like that, you can see that we have stock quantity of 2 digits, 32, 43, 3 digits, geez, it's giving me a tough time, digits, 154, and then this great book, Lincoln and the Bardo, has 1,000 copies in stock. It's brand new. People don't know about it yet. They're not buying it. I'm sure people will buy it soon, though. Once, of course, they realize what a great book it is. So if I wanted to select books where stock quantity is 4 digits long, I could use that wildcard. So let me just show that again. So select title and stock quantity from books where stock quantity like, and all I have to do, so just to clarify, if I did this, that wildcard just means anything. So that's going to give us everything. And if I do 4 of them, it doesn't make a difference. That's not saying 4 characters. That's just 4 different ways of saying anything at all. It could be nothing. It could be 1,000 characters. It doesn't matter. So by adding underscores, that's 4 there, you'll see I get Lincoln and the Bardo. Or I could do 2 underscores, and I only get the 2-digit stock quantities. Now, that's not to say the only time you use underscores is when you're trying. Yes, Blue. It's my cat. Are you going to say hi? She's now sitting on the computer. Okay, so back to where I was. Get this cat hair out of here. The underscore is not only used, and actually it's not even primarily used for counting digits like that, but it's a way of specifying exactly one character, like I said. Let's say that we're working with phone numbers, and in the US, they might look something like this. So we have an area code in parentheses, and then 3 digits dash 4 digits. And if we wanted to match that pattern, we would have something that looks like this, like, and we'd have our first parenthesis. And if we just put this wildcard there, that's going to say any number, any letters, whatever it is in between those parentheses, but we're actually looking for 3 digits. And then another 3 digits after that parenthesis, then a dash, and then 4 digits. So basically, we have these 2 wildcards at the end of the day. %, which means anything or nothing, and then underscore, which is exactly one thing. And you can chain them together to match patterns. Then that brings up another question, which is, but what if I'm searching for a book that has a % in it? How would I do that? And you may have noticed that I expertly planted a book title with a % in it. I was thinking ahead for once. How would we select that? Or there's also a book title that's not so creative that has an underscore in it. How would I select that one? If these characters are special wildcard characters, how do I actually search for the exact character %, or the exact character underscore? And the answer is actually pretty straightforward. We use what's known as an escape character. In this case, I always forget which one's backwards and forward slash, but whichever slash this is, the one over the enter key, I'm pretty sure that is backslash. So backslash % is going to match a %. So this entire thing right here is basically saying %. Likewise with underscore, it's backslash underscore is the escape character. So let's put that into practice. Let's try it out. So we'll select title from books, and we'll just do that first of all, and you'll see we've got 10% happier and then fake underscore book. So let's start with 10% happier. So I want to select title from books where title like, and just, I mean, this should be clear by now, but if we tried to do this, that's not going to work. That's going to give us everything. But if I tried to say, okay, %, that means anything, and then a % and then anything afterwards, that's not going to work either, because that's basically just 3 different ways of saying anything at all in the title. So that's where we need our backslash. And now what you could read this as, you could condense this to say exactly a %, 1 percentage sign, anything before, anything after. And there we go. That's how we get 10% happier. Same thing with the underscore. I won't go through that whole routine again. We just replace that backslash % with backslash underscore, and that gives us fake book. All right. So that's all that there is to like for now. It's very, very useful. We'll be using it quite a bit in this course. It's probably one of the most commonly used things in MySQL or in SQL when doing queries. In all likelihood, you won't be matching % or underscores all that often, but you'll be doing things like this all the time, where you're using the % wildcard and the underscore wildcard to match patterns. Okay, next up, exercises. Okie dokie, artichoke. Yep, that's how I'm starting this video off. It's your turn. So we've covered 4 different things here, 4 new tools for this mysterious magical toolbox. We've got distinct, as well as order by, and then limit, and then finally like. And you're going to put those to use along with some of the stuff you've learned up until this point with a couple of exercises. And there are some clown emojis here to show you how excited you should be, and they're not at all creepy. So here's the first thing I need you to do, or I'd like you to do. Please do it. Select all story collections. So some of these books have titles that contain the word stories, which tells you that they're a collection of stories. What we talk about when we talk about love, stories. Really good read, by the way. Where I'm calling from, selected stories, oblivion, stories. So using what we just saw, and that's something I just want to point out, for all of these exercises, there are ways that you could directly select things maybe a little bit easier, or you could cheat in a way. but make sure that you do it the way that I specify, please, using the things you just learned. So specifically, titles that contain the word stories. Not exactly stories, but something that contains stories in it. So that's the first one. All right, and then the next one, find the longest book in the entire database or in the entire books table. So this is what you should get back. Print out the title and the pages. The Amazing Adventures of Cavalier and Clay is 634 pages. Of course, don't just select based off of where pages is exactly 634 or where the title is The Amazing Adventures of Cavalier and Clay. Please do it the right way so that your query would always work no matter how many books are in the table and what they're named and how many pages they have. It will always get the longest book. Okay, just one. Then the next problem, print a summary. In our case, a summary contains the title, dash, the year. And print only three of the most recent books. So 2017, 2016, and 2014. So again, a summary. And it says up here, it says summary, so that remember how to do that. The title, dash, the year it was released, and then only print out the three most recently released books. All right, next up is find all the books whose author's last name contains a space character. And it's only David Foster Wallace in our case. Don't cheat and just say where author L name is exactly Foster space Wallace. But how can you find any author last name that has a space in it? And then once you do that, find the three books with the lowest number in stock, the lowest stock quantity. So as you can see here, we've got American Gods has 12, Where I'm Calling From has 12, What We Talk About When We Talk About Love has 23. And I'd like you to print the title, the released year, and the stock quantity. So just to reiterate, the three lowest stocks. All right. Then we have this one. Print the title and the author last name. So we've got title, author L name, sorted by the author's last name. So this is all of the books, by the way. So sort by the author last name and then sort by title. Because some of these authors, for example, Carver or Eggers or Gaiman, have multiple books. So if we look at Carver, for instance, Carver has What We Talk About, blah, 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 Where I'm Calling From. What we talk about comes before Where I'm Calling From, alphabetically, if that makes sense. Same thing with Eggers. A Heartbreaking, A Hologram, The Circle. So sort first by the last name of the author, and then on top of that, the title. Then we've got this one. Just make this happen. It's kind of difficult to write out exactly what's happening. The main idea is that we're going to go through every book. You're going to print out this string here. My favorite author is, and this is yelling in all caps. I won't wake my neighbors. It's kind of late. But my favorite author is, and then the author's first name capitalized, and the author's last name capitalized, and an exclamation point at the end. And do that for every book, sorted alphabetically by the author's last name. So you can see Carver comes first, Eggers, Foster Wallace, Gaiman, down to Steinbeck. And then make sure you call it Yell up here. Yes, it's a bit of a complicated one, but fortunately it's last. Hopefully you can make this one work. It's a little bit long. Good luck. See you in the solution video. All right. So hopefully you made it through those exercises, or maybe you're just wanting to watch the solutions, or maybe you're here accidentally. However you got here, what I'm going to do in this video is go over the solutions to the previous video. And that's a bad noise. Why'd that happen? All right. So the first one, select all story collections. So those are titles that contain the word stories in them somewhere. And we just want to print the title. So I'm going to go over here and make some space. And the first thing that I'll do is just make a new file. And I'll just call it exercises.sql. And then I'll open that up. And we'll start off with this first one. Select title from books. And we'll start there. Just make sure we're doing everything correctly. Source, refining, selections, / exercises.sql. Make sure that, okay, it's working, selecting the titles. So now we only want the ones that contain stories. So that's going to be a where, and we're going to do title like. And this is, if we just do stories, it's not going to work. That gives us exactly stories. We're going to want that wildcard character, just like that. And now we get what we're looking for. Technically, with our specific data, we could leave that last percentage sign off, that last wildcard, because all of the books that contain the word stories, it comes at the end. But that may not always be the case. There might be a book out there called My Favorite Stories for Kids or something like that. And if we wanted this truly to just find all books that have stories in the title, we need both of those wildcard characters. All right, so that's the first one. Next up, find the longest book. So print out the title and the page count for the one longest book. So we'll go ahead and comment this line out, and let's just do a select title and pages from books, just like that to start. Okay. So now what we want to do is sort them. We'll sort them by the pages. So that's an order by pages. And if we just do the default sort, remember that we get ascending rather than descending, which is what we want. What we're going to do is use limit to give us the first result. But right now, if we do limit 1, it's going to give us the shortest book rather than the longest one. So we want to reverse that sort with the descending order. So now the first one is the longest. And then we just add our limit 1. And we run it again and again and again, and it always works. And so whatever book has the longest page count will always be what is printed out here. All right, so that's that one. Let's comment it out and move on. Print out a summary containing the title and year for the 3 most recent books. So this one required you to not only use order by and limit. We're ordering by most recent year and then limiting to 3, but you also needed to use concatenate to concatenate the title with a dash with a year. So let's do that now. Let's just start by doing the select concat, and it was title, comma, and then we have a space and a dash and a space, comma, released year. And we'll start with just that from books. Save. Okay. Oh, the other thing we wanted to do is clean this up so it says summary up there. So this is also review. We'll say as summary. Okay. So now we get that. Now we want to order them by most recent. And let's break this up onto some different lines here. From books, order by, and we'll order by released year. And if we try that now, we also see that it does work, but it's in the opposite order that we want. We want most recent, so we need to reverse that again with descending. And then finally, we want to limit it to the first 3. Limit 3. Or if you want to get fancy, we could do this, but I don't like doing that. So that's much easier. Okay, so that gives us Lincoln in the Bardo 2017, Norse Mythology 2016, 10% Happier 2014, summary. That's all good to go. Next up, find all the books that have an author last name containing a space. And don't cheat by just doing Foster Wallace. So let's comment this out first. And this one's actually pretty short and easy. It's just a select, and we're looking for title and author L name. Select title, comma, author L name, where author L name, like, and of course we can't just say space because that's only going to find authors whose last name is exactly space. And it looks like, oh, I'm forgetting from books. Hopefully you caught that before I did. But back to what I was saying, this isn't going to work because we don't have any authors whose last name is space. So what we want is that wildcard on either side. Anything with a space and then anything afterwards. Now we get Foster Wallace. And that's it for that one. Next up, find the 3 books with the lowest stock. So we want the title, the release year, and the stock quantity. 3 books with the lowest stock. So let's start with commenting this out, just like we've done with all the others. Select title. What else was it? Released year and stock quantity. Okay. Just like that. And we'll have our from books. We'll start there, make sure that works. Okay, so now what we want to do is sort them by stock quantity. So that's just an order by stock quantity. And you can see that gives us the order we want. We want them to be in ascending order this time rather than descending, because we're looking for the lowest stock quantity, 12 all the way up to 1,000. Okay, and then we want to limit it to 3. I don't know why I picked 3 so many times in these exercises. Let's try it now with that limit 3. And there we go. American Gods, where I'm calling from, what we talk about when we talk about love. That's what we're looking for. Then we've got this one. Print the title and author last name sorted first by author last name and then by title. So let's get the title and author last name to print first. Select title, comma, author, L name from books, just like that. And at this point, we all know what that does. So now let's sort by the author last name. So that's just a simple order by author L name. And that gives us the alphabetical order we're looking for. So we don't need to use descending. That's all right. But then if you look over here, if we take Carver's books, notice that where I'm calling from comes before what we talk about when we talk about love, even though WHA comes before WHE. So we want to now sort by title there. And the way we do that is not by just changing that to be title, because then it purely sorts by title and ignores author L name. Rather, we want to do this, author L name, comma, title. And there we go. Now you could also replace this whole thing with 2, 1, which I really don't like, just because it's not very semantic. It's not meaningful to look at this, but it is shorter. And again, that 2 is referring to author L name and 1 is referring to title. It's just the order that we're selecting them in. So I'm going to change it back, but I will also duplicate that below and change it to 2, 1 and comment that out as well, just so we have both solutions. Which brings us to the last problem. Hopefully it's the last. Okay, it is. Make this happen. So we want to yell, my favorite author is, and then the uppercase first name of an author, and then a space, and the uppercase last name of an author, and then exclamation point. Yeah, it's kind of a lot. Okay, so let's start with selecting, and we know already that, well, we can start with select from books, sure. What we're going to want to do is concatenate my favorite author is, and then an uppercase version of Raymond and a space, and then uppercase version of the last name. So, and an exclamation point. It's a lot of concatenation. So we're going to have a concat, and I'll just do this. Well, let's do it this way, just like that. What are we concatenating? Well, let's start without the uppercase, or without. So let's just start with my favorite author is, and we'll add a space, comma, and then we want author F name, and then we want another space, this space here, so they don't just run together, comma, author L name, finally an exclamation point. It's a lot. So let me drag this down a bit so we can see the whole query. Select the concatenation of my favorite author is, space, the first name of an author, space, the last name of an author, exclamation point. Let's save it and run it. It's pretty long. Oh, and this is partially messed up because you can see up here, the column heading here is this entire thing. So let's add the as yell. And now if I run it, there we go. Okay, so we're close. The next thing we need to do is capitalize author F name and author last name, which is easy. just an upper, like that. Save, rerun it. Okay, it's all uppercase now. We have one last thing, which is sorting alphabetically by the last name. So from books, order by author, L name. Long query here. Let's try it. It looks like it worked. We got Raymond Carver all the way down to my favorite author is John Steinbeck. And that's about as loud as I'll yell in here. Don't want to wake my neighbors. All right. So congratulations. Hopefully you made it through this relatively unharmed. It's a lot of exercises, a lot of ordering by and limiting. But the reality is you'll use those a lot. It is very useful to be able to determine, the highest page count, maybe not, but the best selling book once we get to sales and users and stuff for the most active users, or like I keep coming back to the highest commented post, or the most trafficked, the most clicked on ad. All those sorts of bits of data are really useful, and you'll use order by and limit all the time, as well as other tools that we saw distinct and like. They're all very useful. All right. Well, I recommend you take a quick little break, and then we'll move on. Hey. Welcome to the next section. So this section, as you can probably gather, we're still working with our books data. I hope you're not tired of it yet. If you are, we're almost done. But it's important that we keep working with one data set for a little bit at least, so that you can get familiar with it. And the reason that matters is that as we do some of the more advanced things, we want you to be able to check your work. So in this section, we're going to learn a lot about different ways of performing analysis on data. So things like finding averages or summing a bunch of data together, grouping things by authors and calculating average quantities or page numbers per author. These are operations that if we had 10,000 books or 10,000 something else, it's really hard to know if you're doing it right or wrong. You get an answer, just a number, let's say 67.5, and how could you know if that's right or wrong? But if we're working with books and we have 20 of them, and you're familiar with the page counts and the authors, you'll know, okay, this author has 3 books, that seems right, versus, okay, that author only has 2 books, why are we saying that, we have 3, or something like that. Terrible example, but the same idea is true. We know our data at this point. We're going to, at the end of this course, and along the way, we're going to keep upgrading our data to more complex structures, more tables, more rows, complex stuff. But at the very end, kind of the capstone case study, we'll be working with Instagram-esque data, fake data for Instagram, and we'll have thousands and thousands of rows. And you won't actually know if you're doing things right or wrong based off the number you're getting, unless you've manually checked your work by, doing 1,000 additions or something. So all that's to say, stick with the books if you can. And in this section, we're focusing a lot on these new aggregate functions. So those are things like finding averages, counting, summing things together based off of grouping data. So it's a bit hard to explain in a headshot without showing you code. So I'll let the code do that in just a few videos from now. But the rough idea is that we take our data and there's all sorts of insights we can gain. So rather than just working with an individual row or a group of rows, we can combine things into like mega rows. I can combine all of our authors and group books based off of who wrote them, or group books based off of what year they're written in, and then perform operations on those groups. So it allows me to do things like find the average sales that we've had per year. Or we could do things like find the average page number for books per genre. And then we could expand that obviously to more complex stuff. If you're working with advertising data, or let's say our Instagram data, we'll be able to, at the end of the course, do things like find out which one of our users is a power user, or an influencer is what they're called, I guess, meaning that they have the most comments, the most likes on each one of their posts on average. So who in our database is getting, on average, the most likes and comments? Or we could do things like which hashtag generates the most traction. And to do that, we would need to analyze all of our hashtags and then take all of our photos that have those hashtags, group them together, figure out which one of those hashtags generates the most likes. So there's a lot of stuff that we can do with these aggregate functions. They form the backbone of a lot of the questions and analysis that we'll do throughout the course. All right, I'm rambling now. I'm going to go away. Hopefully you enjoy this section. It's important. I say that a lot, but it really is. And of course, we'll have a bunch of exercises throughout the course, or throughout the section, and especially at the end. And I'm trying to keep those interesting. Look forward to those. If you don't, just remember it's a database course. I'm trying my best. It's databases. All right, I'm done. Alrighty then. Welcome back, everyone. In this section, we're kind of continuing with the trend of focusing on selecting our data, on reading it, if we're going back to CRUD. In the last section, we saw things like sorting with order by, using limit, and so on. In this section, we're going to focus on what are called aggregate functions. And basically, these are built-in functions in MySQL that will allow us to aggregate or combine data to get meaning out of it. So by the end, we'll be able to do things like find the average page length of all of our books, or find the average page length for each author. So, let's say we'd be able to tell that someone like Carver, who writes short stories, maybe has shorter books compared to David Foster Wallace. And that's just average, but we'll see how to do other things like count, sum, min, max, and a bunch of others. And they're known as aggregate functions because they work on aggregated data. So yeah, let's get started. It's time to learn some more stuff. And it will definitely 100% be the most fun thing that you've ever done. Let's get going. The first thing we're going to take a look at, the first one of these aggregate functions, is called count. And it does pretty much what you would expect, at least in the way that I'm going to show it to you now. We're going to revisit count in the next video once we introduce what's called group by, but for now we're just focusing on count on its own. And what it will do is count whatever you tell it to count. So here's an example. How many books are in our database? If we wanted to do that right now, you could do a select star from books and manually count, which technically that would work. But if we have, Amazon's database that has millions of books, that would be a lot of work. That would take at least a couple thousand Mechanical Turks to do. So that's not ideal. Instead, we can use count. And it just looks like this. Select count star from books. So let's try it, and then we'll discuss it a bit more. So here I am. I'm using the same database, just double checking, Bookshop. So we can do a select star from books. And like I said, we could go through and count. And you can't just rely on the IDs, of course, because we could have deleted some. So just the highest number of the ID is not a reliable way of knowing how many books are in there. Because when you delete something, those IDs don't change. They don't shift down. So instead, we do a select count. And we'll put star here, which basically will count every row, the entire row. So select count star from books. And we get 19. So that tells us there are 19 books. And we could verify that. Let me just speed this up as I count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, so there were 19 books. So we can trust this count. It's right. And that's one way of using count, just to check how many things are in a table in general. A more specific way of using it would be to do something like this. How many author first names are in our database? And it's not 19, we know that now, because if we do a select author F name from books, we have some authors who are in here multiple times. Neil Gaiman is in there twice. So it's going to count them twice. It's just going to count everything here. So if we did this, select count author F name from books, is it really going to be correct? And the answer is no, as I just said, but let's just try it. Select the count of author L name from books. Or we're doing actually F name, aren't we? And it tells us there are 19 author F names. And that's technically true. There are 19 F names in here. I want to know how many unique first names are in there. And fortunately, there's a way of doing that. And it relies on distinct, which we've already seen. So we just put distinct inside of that count. So select count, distinct author F name from books. Let's try it. Select count, distinct author F name from books. And now it tells us 12. And I won't make you sit through me counting it, but there are indeed 12 first names that we have in our database. So instead of 19, it's now decided, okay, there's only one here, and there's one here, and there's one here. So that's the basics of using count, along with using count with distinct. Now I do want to show you a bit of an edge case here. Let's say I wanted to know how many unique authors are in my database. So that means first name and last name. So if we do our select count, and let's just do author last name first from books, we get 19. As you would expect, there's 19 rows. Every row has a last name. But we know that there are some duplicated last names. And if we just look at those, just do this very quickly, it's the same problem that we had with first name, right? We had Foster Wallace, we have Eggers, and we have Gaiman. So if we use that distinct, select count distinct last names, maybe you can see where I'm going here. If I hit enter, it tells us there's 11 distinct author last names, which is true. There are 11 distinct last names, but that doesn't mean there are 11 distinct authors. Because if we go and do a select author F name, comma, author L name, so if we look at both first name and last name from books, remember that we have Dan Harris and Frida Harris. So when we're selecting distinct last names, it treats this as the same because Harris is the same as Harris. So if we wanted to know how many distinct authors were in there, what we could do is do author L name, comma, author F name. And now it's only going to return distinct rows where first name and last name, or last name and first name, are distinct. And that gives us 12, which in our case is the same as just doing this right here, as we just saw, if we only do author F name. But that's because we don't have any duplicated names or any duplicated first names in there. We have David Foster Wallace, but we don't have, I don't know, David Johnson or something. So this would be problematic if we had multiple Davids. So then we could use this where we're doing distinct author L name and author F name together. And the last thing we'll do is this question here. How many titles contain the string the, THE? So if you'd like to make this a little bit of a mini exercise, go ahead and try it. How many titles contain the in the title, or how many books title contains the? And the answer is that we need to use like alongside with count. So let's do it now. We're going to do a select, and let's just start by selecting the books, the title from books where title like, and then this is where we need those wildcards, THE, we need a wildcard on either side. All right, and here we go. We've got the namesake, the king, the circle, the amazing, the lobster, the bardo. Great book, by the way. So there are 6 of them here, right? Yes. So if we wanted to do that with our code dynamically, not by counting ourselves, we would just replace that with a count. Select count from books where title is like the, and it tells us there are 6. All right, so I just wanted to show you, you can combine it just like you can with any other of the things that we've seen. So, substring or concat or upper, they work the same way. In this case, we're just selecting count. All right, so that's count. Next up, we're going to go a little bit off the rails and talk about something called group by. Brace yourself. It's refreshing. Let's put it that way. Okay, so next up, we're talking about something called group by. And group by is going to be essential to everything we do in the rest of this section. And I'll warn you right now, take a deep breath, that it's a little bit weird. It's different than the things that we've seen so far. And in fact, for me personally, it's a challenging one to teach because, like I just said, it is different. It's not just a single little function that we can throw in there, like concat or upper, where we get a nice immediate impact, where we can see, okay, that was uppercased, or that was concatenated, or that's a count. Rather, we have to use it alongside some other functions. So it's going to take a little bit to explain, so hang in there. And just know that we're going to get there. There is a payoff, and it is very useful. It's kind of the core of aggregating our data. It's how we can do things eventually, like average or sum, or find the minimum or the maximum, and so on. So here we go. This is a little blurb that I wrote about group by. Group by summarizes or aggregates identical data into single rows. So it's actually pretty self-explanatory, the name group by. We can say things like take all of our books and group them by the year they were released, or group them by the author last name. Or take all of our T's, or actually let's say take all of the movies in our database and group them by genre. And that on its own is not that useful. But then we can say things like group them by genre and tell me how many each genre has. Or group our T's by variety, like green tea, white tea, black tea, and so on. Group our T's by variety and find the average sales price for each one, for each variety, that is. Or add together all the sales for each variety and figure out which tea type is selling best. So we'll get there in time. But for now, let's start with a little example. Again, here's a reminder. Stay with me, please. Let's say we're working with a very small subset of our book data. So I just grabbed 5 books. So when we do select title and author L name from books, right now we'll get 19 in our actual database, but this is a fictional database where we get 5 books. We've got The Namesake by Jhumpa Lahiri, Norse Mythology by Neil Gaiman, American Gods by Neil Gaiman, Interpreter of Maladies by Jhumpa Lahiri, and A Hologram for the King by Dave Eggers. All right, so we get these 5 books out when we just select. Just like that. We don't do anything fancy. We're just getting title and author last name. So then we introduce group by. And we'll talk about the syntax in a little bit. But all that we've done, this is the exact same line as before. Select title and author last name from books. And we've added on at the end, group by author L name. And I've just done it on the second line just to make it so that this is all easier to read. Again, it doesn't matter. So group by author last name. And what we get looks like this, which is bizarre. It's probably not what you would expect. It's not what, to me, makes sense on a visual level at least. It does make sense once you learn what's happening, but on a visual level, it looks like basically it's only just giving us the unique authors, like Lahiri, Gaiman, and Eggers, and then just picking their first book title, right? So we're getting The Namesake for Lahiri, Norse Mythology for Gaiman, and A Hologram for the King for Eggers, but then we're missing these 2 books. And that is what's happening. That's what we're seeing here, which isn't really useful. Why would you want that? So what's actually happening is that even though it just prints out The Namesake by Lahiri, it's basically grouping based off of last name. And so it creates one big, let's call it a super row with all of Lahiri's information, or all the books written by Lahiri. So that's The Namesake and Interpreter of Maladies. And it treats that as one row. And it does the same thing for Neil Gaiman. And then the same thing for Eggers, and there's only one Dave Eggers book in our data set. So even though this is all that we see, behind the scenes, they are grouped together in these super, mega, whatever we want to call them, rows. And that's important because the data is now grouped, and we can do things like this. Count how many books each author has written. So our query would look something like this. Select author last name, comma, we don't have to have this here either, but select the author last name, comma, count star from books grouped by author last name. So it's going to group them like we've already seen. And then when we do a count star, it's not going to count every row in our entire table. What it's counting is for each of these mega rows, how many sub rows are in there. So basically how many things are under Lahiri. And in this case, there's 2. How many things, how many books are grouped under Gaiman? 2. And how many are under Eggers? 1. So then what we get spit out when we're actually selecting the author last name and the count is this. Lahiri, 2. Gaiman, 2. Eggers, 1. So we're only getting started here with group by. I'm going to now dive into Cloud9 and do some more. But just know that we will be using group by to do things like average. So once we have, let's say, grouped by authors, we could average the page count, like I said, or the average year that they wrote a book. Or we could find the first year they wrote a book using min, which we'll see in just a moment. Or we could sum the total page count, for instance, for every author. So group by is very important and versatile. For now, we're only using it in conjunction with count. So now let's dive into Cloud9 and do just that. So let's start with something simple like select title, comma, author, name. Let's do actually first name and author, last name from books. So no count or anything like that yet. So we have a much bigger data set, right? Let's do a group by now. Group by, and we'll do author last name. And we're going to just do the exact same thing. I want to know how many books each author has written. And we will run into problems, I'm just telling you now, with this Harris, right? Because we have two different Harrises, Frida Harris and Dan Harris. But when we group by last name, it just treats them as one. So it will say Harris has 2 books, which technically is true. The last name Harris has 2 books. Okay, so if we do this and just hit enter, it's not useful. I don't know why you would ever do that, honestly. It just is giving you sort of a preview of the mega rows, if you will. Basically, it's just taking the first book by Carver, the first book by Harris, but we don't see how they're actually grouped. So it's not that useful. It's not useful at all, honestly. So what we want to do is, rather than just title, author, first name, author, last name, let's do count star. And remember, count star in this case is referring to the grouped rows. So it's going to go to each of those grouped rows and count how many rows have been grouped together. Oh, and this is kind of a mess to look at. So let's actually get rid of title and just do author, first name, and last name. Now we can see. So Raymond Carver has 2. Don DeLillo has 1. Dave Eggers has 3. David Foster Wallace has 2. And then, as I mentioned, we have this problem with Harris because it says Dan Harris has 2, but that's not true. Dan Harris has 1 book. Frida Harris has 1 book. So to get around that, of course, we can do the same thing where rather than just doing group by author name, hopefully you've seen that this is something that's kind of standardized across MySQL. We can do author name as well. So it will group where both of these are unique. So then we do that, and everything else is the same. Raymond Carver has 2, Dave Eggers has 3, Foster Wallace has 2. But if we go down here, we now have Dan Harris with 1 and Frida Harris with 1. All right, so just to show you another thing that we could do, we could also group by released year. So, I mean, we could group by title, of course, but we don't have any books that have the same title. But we do have a couple books that have the same year. So let's say we wanted to get a nice printout that shows us in 2017, 1 book was released. In 2016, 2 books, or however many books were released. So we can do that pretty easily with just a select. And let's do released year, comma, count, star. So if we just do select released year from books, you can see, where's an example? I think 2003, we've got at least 2 2003s. And I know there's a couple more. I hope there's a couple more. So let's say we wanted to condense them all together and then put a count next to it as well. We would do that just like this. Select released year from books. We would group by released year. And rather than only selecting the released year, we also want to select count star. Let's hit enter. Now you can see we've got 1945, 1 book. 2001, there were actually 3 releases. 2003, there were 2 releases. So you can see that it's working. And if we want to get really fancy, go ahead, move on to the next video if you'd like. But I'm just going to show if we want to get fancy and print it out nicely, we can combine it with concatenation. We could do something like this. So rather than just selecting the count, we could do let's see, a select concat, and we're going to concatenate the released year, comma. So let's add a string before. So I'd like it to say like in 2010, 2 books released. Or 1 book, I guess. In 2001, 3 books released. I actually want that string. So we can do in the released year, comma, the count, comma, books released. And technically, just to make sure, let's add parentheses around the S because there's, in a lot of cases, one book released. So I don't want to say one books. Anyways, so let's make sure we have our correct parenthesis here. Select the concatenation of in the released year. We probably want a space there, don't we? This is where it gets kind of annoying that we're not using a separate file. So in 2001, let's say, space 3 space books released. And then lastly, to clean this whole thing up, let's add an as, and we'll just call this as, let's just say year or something silly. We hit enter, and we get this nice little table. In 1945, 1 book released. In 2003, 2 books released. In 2001, 3 books released. Okay, so that's it for now, at least, with group by. We're going to be working with it in every video from here on out in this section. Like I said, we're going to move on to things like min and max, average, sum, fun things. Hopefully, sort of fun. Congratulations if you made it through this video. Like I said, it's a little bit weird. It's different than what we've done before. Hopefully it wasn't too boring. Okay, so next up, we're going to continue on with 2 new functions. And they go together, they fit well. They're min and max, minimum and maximum. And they do what they sound like, what their name says. They help you find and identify minimum values in a table or maximum values in a table. And we can use them on their own, and we can also combine them with group by to get further insights. So we're going to see how to do both. We're going to start off by using min and max without group by. So we can do things like find the minimum released year in our entire table. So, what was the first year any book was released? And to do that, it just looks like this. Select min, released year, in parentheses, from books. So just like we did with count, where you could just count all the books if you wanted to, you can just use min on its own. So let me show you how to do that now. Go over to Cloud9, and we can just do a select min, released year, from books. And 1945 is the earliest book that we have released, or the earliest year that a book was released. We could also do something like select min pages if we want to see what's the shortest number of pages. And that's that. It tells us 176 is the shortest. So, of course, maximum works the same way. So instead of min, we just type max, M-A-X, and it does the same thing. So here we're finding, well, it doesn't do the same thing. It works in the same way, but it does the exact opposite. It's going to tell us or return the longest or the highest number of pages. So if we do that, we'll just recall that last line and just change it to be max. 634. That is our longest book. And we could do the same thing with year if we wanted to. 2017 is our most recent year. It's the highest number year. So that's the very basics of max and min, or min and max, however you want to say it. I do want to call your attention to something sort of weird. What if I wanted to get the title of the longest book, not just the number of pages like we have here, just finding out that 634 is the longest. Isn't that useful? What if I wanted to know what is the book, what's the title, who wrote it, the year it was released, any other information? Well, you might think you could do this. Select max pages, comma title from books. And if we try it out, select max pages, comma title from books. It says that the namesake is our longest book, and it has 634 pages. And while yes, 634 is the maximum pages in our entire database, the namesake is not 634 pages. And in fact, if we just do a select, and let's just do title, comma pages from books, if we find the namesake, you'll see that it's 291 pages. And the one that is 634 is The Amazing Adventures of Cavalier and Clay. So that's a problem. Here's a nice little graphic I made. It's the largest emoji that I could make on these slides for some reason. So I'm just going to go ahead and insert a much larger one now. Post-production, very fancy. So how do we get around this? There has to be a way, and in fact, there's multiple ways. In the next video, it's a bit of a cliffhanger here. In the next video, we're going to see a couple options, including a preview of a more advanced method, something that we haven't seen just yet. But there is a way to do it using what we already know, something we learned a couple of videos ago. All right, next video. Okay, so what we're discussing in this video, in case you didn't see the last video that leads into this, is that there is a problem with trying to do something like this. Select max pages, comma title from books. If I want to find the title find the title of the longest book or any other information along with the maximum pages, it doesn't work. And what it's doing right now is actually returning, is first finding the longest pages, the maximum pages, which is indeed 634. But then when I ask for title, it's actually just giving me the first title, the namesake. And the reason that it does it, it's kind of complicated and weird, but basically you can think of it as SQL or MySQL is executing this, and it finds the max pages first, which is independent from this. So it finds this, 634, and there's only one row that it's preparing to print out. So then we get comma title, and there's only one spot to fill, so it just takes the first title. So these are independent of one another. They're not connected, unfortunately, but there are ways around it. So the first thing I'll show you is something a little weird. It's not weird overall, it's just weird to you at this point because we haven't seen this before. It involves something called a subquery, which we'll return to later on in the course, but I wanted to just preview now. And basically what it lets us do is run one query inside of another. So it looks like this. Select star, in this case I did star, although we could just do title, but select star from books where pages equals, and then this is the weird part, parentheses, and inside the parentheses we have another query. Select, in this case I did min pages from books. So what's going to happen is that this will actually execute first. Select whatever we have here. So let's say min pages, I believe is 129, or in our case, max pages would be 634. So it's going to find that and return 634 here. And then this will run. Select star from books where pages equals 634. So let's try it out now. And I'll show you basically manually what's happening. So think of it as doing a select max pages from books, just like this, which is 634. And then copy that and do a select, and let's do a, we'll do star, select star from books where pages equals 634. So it's a two-step process. And you can see, even though our formatting's a little screwed up, we get The Amazing Adventures of Cavalier and Clay, which is indeed the longest book, 634 pages. So we can do that all at once, or at least in one line of code with, if we just recall this, select max pages from books, that will be our subquery. And so that's kind of going to be a fill in the blank. So we'll have a select, and let's just do title and pages this time, from books where pages equals the result of finding the max pages. So it's doing what we just did, but in one line of code. And now you can see we get The Amazing Adventures of Cavalier and Clay, 634 pages. So we could also do that with min. And if we just replace this, you'll see that Raymond Carver's what we talk about when we talk about love, short story collection, great short story collection if you like short stories, is the shortest book, 176 pages. So that's all we'll talk about with subqueries, or that's all I'll show you. But as you can probably imagine, there are other uses for them. But there's a small problem. It's not really a problem, but there's something to consider, which is this is a little bit slow. In our case, it's not that slow. It's not slow at all because we have a very small data set, but it's effectively running 2 queries. So each one of these is run independently. So when we hit enter, when this executes, like I said, 2 things are happening, 2 separate queries that are going to take time, each one of them. Every time you do a select, it takes time. And there's a faster way if you are worried about speed, and it involves something we've already seen. So there's nothing new, no fanciness, no top secret, advanced features, subqueries, or anything like that you haven't been introduced to yet. There's a way of doing it using what you've already seen. So that way is using order by. So what we could do is just order by pages in ascending order. So do a select star from books, order it by pages ascending, and then just limit 1. So chop everything else off and just take the first one. And that will give us the exact same result, but it's not going to take as much time. It's not going to be as difficult for MySQL to run because it's only selecting one thing and it's only running 1 query. So let's try that. We'll do a select, and let's just do title and pages from books. And instead of doing our where pages equals blah, 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 we'll just do our order by. And then we want to order by pages ascending, limit 1. And we get the exact same result that we got before with our longer query that involves a subquery. And we can do the same thing with min. And to do that, we just change our order. And yes, it still bothers me that 4 letters, DESC, but ascending is only 3 letters, so inconsistent. But if you remember that DESC for descending, you'll see that the longest book is, yet again, The Amazing Adventures of Cavalier and Clay. Okay, so that was a bit of a tangent, but it's important to address because I think a lot of people, myself included, I remember when I was learning this stuff, setting out and thinking that you could do something like select min, let's say year, comma title, comma, let's say stock quantity, and that it would go find the minimum year and then the corresponding title and stock quantity. And that's not the case. That's just not how it works, as we've seen. So I just wanted to point that out and highlight a couple of solutions just so that you're aware going forward. Things aren't always as intuitive as you would hope. Okay, next up, we're going to continue with min and max and use them in conjunction with group by. All right, so I know you've been dying in suspense, waiting to see how you use min and max in conjunction with group by. Well, it's finally time. So the way we do it is really similar. It's basically identical to how we did count when we used that along with group by. So let's take an example problem first. Something like this. Find the year that each author published their first book. So we want something like, Raymond Carver and his, I don't actually know this, but let's say that in our database, his first book was published in sometime in the 80s, I believe, 1981, let's say. And we want to do the same thing for, let's say, David Foster Wallace, and his first book in our database was published in 1999 or whatever it is. Don't quote me, please. And so to do that, basically what we're doing is finding the minimum release year, but we can't just do this, right, where we do a select min release year from books, because that only gives us the absolute minimum. We want to group all of our books by author, so unique author, and then find the minimum release year for each one of those. So we need to use group by and min, and it looks like this. And yes, I know it looks kind of long, as this emoji tells you. It might be a little confusing. Basically, let's focus on the important parts first, which is this right here, and then the group by statement. Now remember, when we do group by, I'm doing author L name, comma, author F name, because we have 2 authors who have the same last name. And so I don't want, I believe it's Frida Harris and Dan Harris. I don't want their books grouped together. So we're separating it out. So this is going to group all of our authors together, make those different groups. I call them super rows or something like that. And then for each one of those, we're going to find the minimum released year, as well as the author first name and last name, because if we just find the minimum released year, it's not that helpful to see if that's all we print out. We want something like Raymond Carver 1980 rather than just seeing 1980. So let's give it a shot. Make some space. We'll do a select author F name, comma, author L name, comma, min, released year. And then I'll do it on a separate line from books, group by, and we want to do that double author L name, comma, author F name. Let's hit enter. Here we go. So we got Raymond Carver, and the minimum released year for him is 1981, which I think is what I just said, or what I guessed. Let's say Dave Eggers, and we've got 2001, David Foster Wallace, 2004, Neil Gaiman, 2001, and so on. We can see the minimum released year for each author. And just to, hit this twice, that's annoying by doing it on separate lines. If I had left off, here, let me finish this, from books, group by, and let's just say author L name. If I just left it at that, everything looks the same except for our two Harrises. Dan Harris, 2014, Frida Harris, 2001. Well, now all we have is Dan Harris in 2001, which is not true. He never released a book in 2001. Frida Harris did, and that's because we're grouping everything by Harris. And so it puts Dan and Frida together. So that's why we need both. And so we're going to continue using that group by author L name, comma, author for F name quite a bit as we progress through these group bys in the next couple of videos. Okay, so we could also do something like find the longest page count for each author. It's very, very similar. We just need to use max. So that's going to be a select max pages from books, group by, and then our same author L name, comma, author F name, just like that. However, we just do that and it's not very useful. So let's go and add in select author F name, comma, author L name, comma, max pages. Now we can see Raymond Carver's longest book is 526. Neil Gaiman's is 465. John Steinbeck is 181. He only has one book in there, I believe. George Saunders is 367 is his longest pages. So that's the basics of min and max in conjunction with group by. Obviously, you could group things differently. We've been doing a lot of grouping based off of authors, but we could group things by the year they were released, or the quantity we have in stock, or whatever we have, whatever available pieces of data we could group by. But grouping by author makes a lot of sense for calculating some sort of meaningful data. Next up, we're going to continue on with some of these aggregate functions, and we're going to, in particular, focus on sum, which will allow us to add things together, and average, which allows us to calculate averages. Oh, wait. I forgot I made this slide. I ended the recording and everything, started editing, and then I remembered I also have this slide here of a nice cleaned up version that just shows you can use things like max and group by along with concat. So all that this does is the same thing. It finds the longest page count for each author, but rather than just printing out this mess here, it's not really even a mess, but what it does is it combines some data and it uses aliases so that we have author and longest book as our column headers, and concat to put together, as you've already seen, the author's full name. So just copy that, run over here, paste it, and there we go. We get author, longest book, and we have a full name here and their longest book. Yep, that's it. Now we're actually done. I promise. Alrighty then. It's a little enthusiastic. Next up, we're going to talk about sum, which is another built-in function. It does what it sounds like. I know I say that a lot, but it sums together data. It adds things together. Very exciting. It actually is pretty useful. You can do things like, sum together all the profits, all the sales that you've made, or your entire payroll for a given month, let's say. you can find some important information using sum. For instance, you might want to sum all the pages in our entire database. So this is following the same pattern as what the last couple videos have. We're going to show you how to use this function on its own without group by, and then I'll show you at the end of the video how to use it with group by. So, okay, sum all the pages in the entire database. It's pretty simple. It's just a select sum pages from books. And it tells us 6,623. And that's all there is. We could do silly things like sum, oh, go away, Siri. All right, we're back. So we could do something silly like a select sum released year. And that's just going to add together all the years in our database. Let's see, 37,996. Very important insight we just gained. Okay, so that's all there is to summing things on its own. Now let's see how we use it in conjunction with group by. It works the same way as what we've seen before. Basically, we group things together by whatever, let's say, author or, I don't know, year. And then we select what we want, and we can use sum to help us select. So select all the pages, or sum all the pages each author has written. Let's see which author cumulatively has written the most number of pages. Whew. So we'll start with a select, and let's do the same thing with author F name, author L name, and then we'll sum pages. So we'll do that from books, and then we need our all-important group by author F name, author. Actually, we need to do L name first, and then F name, just like that. And you can see, looks like Dave Eggers has the most, 1,293. Raymond Carver, 702. John Steinbeck only has one book, so it's only 181 pages. And that's pretty much it to sum at this point. We could, of course, do the same thing with, let's say, adding the release year for their books. Also a very insightful piece of information that we need, but we can see people who have multiple books, like Raymond Carver, there's multiple years added together. Yep, that's pretty much it. Okay, so that's sum. Like I said, you may end up using it if you're, I don't know, dealing with sales data or payroll, any sort of information where you're summarizing things. Actually, I just used it recently when I was compiling my taxes. Probably going to bore you to death with this, but I have a database that has sales data for every week for one of my projects that I have going on. And I just wanted to figure out exactly in a given year how many sales, or not how many, but how many dollars I'd sold in that entire year, and just add all those values together. I didn't want to, manually enter them into a calculator. So it was just a matter of using select sum. And I actually did a select sum with a group by because I grouped by year, because I have sales going back, I think 2016, 15, and 14. So I only wanted 2016 for my tax season. Anyways, if you're still there, thanks for making it through that. I know taxes are not the most interesting subject, but yeah, sum can be useful sometimes. Oh boy, I'm going to end it now. That was just bad. Next up, we're talking about AVG. AVG. Hang on. Next up, we're talking about average. And as you might have guessed, because I've said this for pretty much every video in this section, it does what it sounds like. Actually, that's a lie. It sounds like AVG, but what it does is average data. So it will sum things together and then divide them based off of how many things it added together. So it's pretty useful if you're trying to do things like find the, average sales for something in a given month, or find the average price of something in a database, or the average, anything, the average number of users or the average number of followers that your YouTube videos have. I mean, averages are pretty useful in general. Think of all the times in your life. Hopefully, I don't know, maybe you never average things, but I feel like it's something I find myself doing. It's a lot of what teachers do is find averages average scores, average grades. Okay, well, let's just get back to this. There are a lot of uses for averages. It's not a perfect way of getting insight. I don't want to say that, the average is this amazing, all-encompassing piece of data, but it can be useful. Anyways, so how do we use it? Also, as you might have guessed, I'm going to show you how to use it on its own first, and then how to use it with group by. By now, we'll be able to do this pretty quickly, and it should serve as review. So we could do something like this. Calculate the average released year across all books. And that's very simple. We do a select AVG, average released year, from books. And as you can see, we get 1999.7895. And it's important to note, yes, there's a decimal, and it goes out to 4 places here. We'll talk more about different types of data types, in a coming section, where we'll talk about the differences between integers and the ways of storing decimals. But for now, it's important that you notice when you do average, it doesn't round things up to a whole number. It gives you 4 decimal points. We could also do things like select the average page count from all of our books, which is 348.5789 pages. Okay, so now let's see how to use it with group by. That's a more common application. How do we do something like calculate the average stock quantity for books released in the same year? So this is a little bit different. We're not grouping by author in this case. We have a couple of books that were released in the same year by different authors. And this is sort of arbitrary, very arbitrary, but how do we calculate the average stock quantity for books released in the same year? Looks like this. Select AVG, average stock quantity from books, group by released year. So let's try it. Select average, and we want stock quantity from books, group by released year. Just like that. Not that insightful to look at, let's be honest, but maybe we could do something like this. Let's print out the release year, the count, how many books were released that year, and then the average year. So it will look like, or the average stock quantity, excuse me. So we'll have released year. And then let's just leave it at that. Released year and the average stock quantity. And if I do that, you can see 1945, 95 is our average quantity. 2001, 134 is our average quantity. Yes, not that useful. I totally agree. But I just want to mix it up because we've been doing a lot of group by author L name, author F name, and it gets kind of old. So we can group by other important pieces of data. But of course, we could do something like this. Select, let's do our good old author F name, author L name, and average. Let's do average pages written by every author, or each author. From books, group by author L name, author F name. Oh boy, it's a little bit too eager there. What's our problem? Looks like I'm missing a comma right here. Okay, so you can see the average pages written. We saw how to select the min and the max, as well as the sum. Now we have average. Also, it's important to note that someone like, let's see, John Steinbeck, who we know has one book, 181, it still adds the 4 decimal points. And that has to do with the data type that this is. And basically, I'm just going to punt that one until we talk about data types. But I just wanted to highlight it here. You still get those 4 decimal points, even if it's an even integer. Even not meaning, okay, that was a bad choice of words. Not as in even and odd. Let's say as a whole number. There we go. All right, so that's average, and that actually wraps up the section on, or the new content on these aggregate functions. So we saw count, well, we saw group by, and then count, min, max, sum, and average. All different things that we can do on their own or in conjunction with group by. All right, so now we're going to get another chance to practice it. Hopefully you're looking forward to that. And if you're not, it's still good to do. It's like, vegetables. You just got to eat them. I hope I don't offend anyone if you're a vegetarian. All right, welcome back. It's me and my cat. Can you purr? Say hi. Meow. That was my cat, I promise. So in this video, we're now going to spend some time, or you're going to spend some time getting some practice with the different functions we just saw. Things like count, min, max, sum, and average, as well as using them with group by. So in this video, I'm just going to lay out the challenges or the exercises, and then in the next video, we'll talk about solutions. So the first one is to print the number of books in the database. So, don't just do a select star from books and then manually go through and tabulate or count them. Write a single line that will print out the number of books in the database. And then once you've done that, move on to this one. Print out how many books were released in each year. And I have to say, the wording on some of these is not great, but I kind of struggle to figure out how to explain this the best way. Basically, group things by year that they were released, and then just print out how many were released that year or each year. So it should look something like 2005, 1, 2006, 2 books, 1945, 1 book. Now those numbers I just made up, so don't worry about those numbers, but basically that's the idea. You should have the year and then a count for how many books were released that year. And then, next up, print out the total number of books in stock. So there's a stock quantity, and every book has a stock quantity. So print out the sum. I just gave it away. Well, print out the sum of all of the books in stock. So just add together all the quantities. And then find the average released year for each author. So you'll need to go through, group things by author, first or last and first name, and then find the average year that they were released for each author. So your results should look something like Raymond, and then Carver, and then the third column should be the average released year. Let's say that's 1985.2 or something. Next up, find the full name of the author who wrote the longest book. So full name here is in a different color because it's a little different. This one, you'll need to use one of the tricks that we saw in that video where we talked about min and max and that issue. God, my cat's being a nightmare. Hey, come on. Blue. No. Oh my God. She's just knocking everything off my desk. Blue. Okay, so where was I? The idea here is to not just find the longest book or the page count for the longest book, but actually print out the name of the author, the full name. So you'll need to use concat, full name. We want first plus last name with a space in between of the author who wrote the longest book. So you need to find the longest book and then use that to find the author, basically. And there's a couple ways of doing that. If you remember the min and max video, the second min and max video, where I talked about some of the problems, or one problem in particular that arises when you try and print information like title or author based off of something being min or max. And then the last challenge here is to print this data out. So we should have the year is released. Notice that we have an alias for all three of these. So the year, like 1945, the number of books released in that year. So, 1. But then here we go. In 2001, there were 3 books. And then the average number of pages for those books released in that year. So I won't tell you how you need to group things in this case, but hopefully you can figure that out based off of this image. All right, I gotta take care of this cat situation. Oh my God. And then in the next video, we'll have a solution. Okay, so in this video, we're just going to go over the solutions to the exercises I introduced in the previous video. And the first one here is to print the total number of books in the database. So we'll need to use count. And all that we'll do is write a select count star from books, just like that. And we get 19. All right, and that's it. The next one is to print out how many books were released in each year. So we'll need to use a group by released year, and then use count in conjunction with that. So let's do a select, and we'll just do count star from books group by released year, just like that. Now on its own, this isn't that useful, so I'll go ahead and add in select released year, comma count, so that we get the year it was released and then the count. You can see most years have one book released. 2001 has 3, 2003 has 2. All right. So the next problem, print out the total number of books in stock. So this one, you'll actually need to use sum, and you'll need to sum all the stock quantities, which is something I guess we haven't really used. Oops, that's not how you spell from. We haven't used stock. Oh, my cat. You gotta chill out, Blue. So stock quantity is not a piece of data that we've used very often, but it is here. We've neglected it a little bit, but it is there, as you can see. So we just want to add them all together. And that's just going to be select sum stock quantity from books. There we go. We have 2,450 books in stock. So the next problem here is to find the average release year for each author. So we'll need to group by author, and then we'll need to use average, AVG, to calculate the average release year. So let's give it a shot. Average release year for each author. So we'll need to do a select average and then release year from books group by, and then we're grouping by author. So we'll do L name, comma, author F name. Again, because of the Harris issue. What are their names? Dan Harris and Frida Harris. Okay, so if we do that, oh my God. My cat again. Oh boy. Well, I've taken care of that. And I don't mean, wow. Apparently I have not taken care of it. All right, hang on. So back to the problem at hand. This works. We're getting average years, but to make it a little bit better, we should also add in the author F name, comma, author L name, just so we can make a bit more sense of the data. So now we can see Raymond Carver's average release year is 1985. Let's see, Neil Gaiman's is 2006.6667. All right, so that's all there is to that problem. Now we get to the one that's a little different. Find the full name of the author who wrote the longest book. So there's a couple ways of doing it. The way that doesn't qualify as a solution, the two-step process, would be first to find the longest book. So that would be select max pages from books, like this, 634. And then, at this point, we can make a second query, select, and we want to concatenate first name and last name. So we do concat author F name, comma, author L name, and we want a space in between, like that, from books where pages equals 634. And there we go. We get Michael Chabon. However, we want to do it in one step. So we can either do the subquery route. So we'll do select concat author. However, instead of, we'll do from books, but instead of just doing where pages is 634, we'll do where pages equals, and then we use parentheses for the subquery. Hopefully you remember this part. And then in here, all that we do is write our query. So that's going to be select max pages from books. And we get the same thing. Michael Chabon. And then there's the other way of going about it, which is to not use max at all and circumvent that, which is actually faster to use order by and then limit it to 1. So we could do the same thing, select concat author F name, author L name from books, and then we just do an order by pages ascending limit 1. And I believe I have that backwards. We want the longest book, not the shortest one. There we go. So we want it in descending order so that we get the longest one at the beginning. And that's going to be 634. So if we get rid of this limit 1, and actually if we get rid of the limit 1 and let's do pages, comma. All right, so you can see now we've got 634 all the way down to 176, and I had it backwards. Okay, so both are valid ways of getting the solution. This one is a little bit, it's a little faster because we're running one query. This version is more complex, more advanced, I guess, but I would definitely stick to using this when possible, using order by. All right, let's move on to our final challenge here. Make this happen. So we've got a couple things going on. We've got a year, so things, let's see, we've got a year, the number of books in that given year, and the average pages for all those books for that given year. So things are grouped by year, and we have 3 aliases going on. Okay, so let's give it a shot. So we'll start off by selecting year, or released year, and giving it the alias of year. Then the next thing is the count. Remember, we're going to have a group by at the end. So we're doing all of this, writing the 3 things we're selecting before we actually have the group by. But at the end, we're going to have group by released year. So this here, number of books, is count. It's a count of the number of books released that year. So I'll indent and just do count star as. And I need quotes here because we have that octothorpe, I think is what that's called, the hash symbol, as well as a space. So we need quotes for our alias if we want to match this. Then we have average pages. So it's going to be the same thing as far as our alias is concerned. So we need average number of pages as AVG pages. Is that correct? There we go. Okay, from books, and I'll indent this one too, group by, and we want to group by released year. Hit enter and pray. And it looks like it worked out. 1945 had 1 book, 181 pages long. Take a look at 2001. There was 3 books, and the average number of pages is 443 and a third. All right. So that matches what I had here, which means that we got it right. Don't ask why you would do this. Just don't ask. That's it for this section. And I'll see you in the next section. Hello again. Welcome to the next section. So first of all, hopefully you can see me. I am wearing camouflage. I know that can make it a little challenging, but I am here, not just a floating head. With that said, this section is I keep saying important. Everything's important. But this section is really taking us back to basics in a way. We're talking about data types. So if you remember way back, section 3-ish, I mentioned that we would come back to data types when I introduced varchar, however you want to say it, and integers are 2 data types we've been working with, which are great. They're very useful, but there's a big world outside of those. What about things like decimals? How do we store currency, price information where we have information after the decimal? How do we store things like dates and time? Wait, where'd my watch go? Things like dates and times. There's a lot of information that we need to store that doesn't neatly fit into varchar or integers. So this section is all about introducing and surveying those kind of different data types. And I could have done this early on in the course, but I've done it in the past like that. in person, and I find that students get too bogged down just worrying about all the data types when really they need to be focusing on things like create tables and insert statements. That's the focus of SQL and MySQL. We can add new data types easily. So that's what this section is. We have the 2 we've been working with. Now we're adding a bunch more. A ton of exercises here. Nothing complex with our data. We're not using any brand new data set. All we're going to focus on are the data types. We'll see, in particular, we'll focus on dates, times, date times, timestamps, all this terminology. It gets a little crazy, but hopefully we can simplify that in this section. All right, see ya in the next video. Okay, so we're moving on now, and it's time for a brand new section. In this case, we're spending some time revisiting something we've already discussed, which is data types. So very early on, one of the first videos, once we got everything set up and installed, one of the first videos was on very basic data types. And we talked about how data takes different forms, and you have text and numbers, and I kind of left it at that. We talked about varchar and int, our 2 first data types, but I showed you that there are a bunch more. Well, now is a time that I promised we'd revisit. We'd return to those data types and go into a bit more detail in depth around some of the important data types. So we're still not going to go over every single one because a lot of them are just not used. And some of them are very, very similar with tiny differences that honestly won't make that aren't relevant to this course. So what we're going to do is focus on what will have the highest impact for you, what has the highest impact in my developer life and the people that I know and have to talk to and about how they use MySQL. So basically, it boils down to a couple different data types and a couple different broad categories. So the first category is text or string data types. And then we'll also talk about numeric data types. We have a lot to talk about there because we've only worked with ints. We need to talk about how we store decimal points or how we store, non-whole numbers. Can't remember the term for that. And also, we need to talk about how we store things like dates and times. Really important part of using a database is typically, at least in web applications or applications in general, you're usually storing some sort of date and time information about when a transaction happens, when somebody signs up for your site, the last time something was updated, and so on. So we'll be discussing that as well. But for now in this video, we're focusing on storing text. So as I mentioned, we've already seen varchar or varchar, however you want to say it. I think most people actually say varchar, but I don't know. I say varchar. Doesn't really make sense, I guess. You say character, not character. But all right. So we've already talked about it. It's what we've been using to store text. But there's also char or car, which is an entirely different, separate data type. Now they both store text, but there's one really key difference. Well, what is that difference? Char has a fixed length. So when we specify, let's say we're working with our books table, and we want to have a column called title. We could have, right now it's a varchar in our existing books table, but we could specify it's a char and give it a fixed length of 5 for title. And what that means is that every title that we add in is going to be 5 characters. So if it's greater than 5 characters, if it's 10 characters, it's going to be truncated. It's going to get chopped at that 5 character mark. And if it's fewer, you'll see in a moment what it does. It actually adds spaces to make it 5 characters. So char will always allocate the same amount of space for every row or every instance of that char versus varchar can vary. And as you can see here, if we did something like char 3, only 3 characters are allowed in this example. So this is taken straight from the documentation, some really boring explanatory text, but it has some important things to know. The length of a char column is fixed to the length that you declare when you create the table. We've already discussed that. The length can be any value from 0 to 255. So the longest char, whatever, that you could have is 255 characters long. When char values are stored, they are right padded with spaces to the specified length. So that's kind of what I was explaining. If we have a 10 character limit, let's say char 10, and let's say I insert something that is only 5 characters, it's going to add 5 spaces after it on the right side of it. pad it with these just spaces to make it exactly 10 characters. However, it's kind of confusing because when you go to look at that string, when you select it back and it's retrieved, those spaces are actually removed, as you can see here. When char values are retrieved, trailing spaces are removed unless blah, blah, blah. There is a way to get them to stay there, but I'm not sure why you would want that to happen. The only reason that I want to point that out is that I think it helps you understand, or has helped other students that I've worked with understand how the fixed length works. If you think in memory that it's actually storing something the same size every time, it's always 5 or always 10 characters, and you can't get around that. So if you give it something shorter, it will elongate it with spaces to make it 10 characters. If you give it something longer than 10 characters, it's going to truncate it to make it 10 characters. So why does it matter? Well, char is faster for fixed length text. So there's not a ton of uses in my experience day to day for using char unless you know for sure that something is fixed length. So I tried to come up with some examples, like state abbreviations is one, at least in the US, where we have 2-letter abbreviations for every state. There's no reason to make that a variable length of varchar. You can save space and time essentially by using char. Or a yes or no flag, Y or N, or any sort of like binary. It doesn't even have to be binary, but something that has a fixed length. So you could do sex in this case if you were doing where a pound or an animal shelter. We're keeping track of animals and their sex. You could use M and F. However, if we wanted to do things like male and female or unknown or whatever other options, those aren't all the same length, so it makes more sense to use varchar. So you could probably come up with some other situations where this would make sense, but typically we use varchar because it gives us a lot of flexibility. Otherwise, use varchar. So there's a table here that I actually took this from the docs. I just kind of blew it up and added it into my slides, but it's from the documentation for char and varchar. And what it's showing you here, for a given value, let's take AB. If we have a column with data type char4, you can see that it adds the 2 spaces, so it's actually stored as AB space space. And if we store the same thing, the string AB, in a column with varchar4, so varchar instead of char, it just stores AB. But what I want to call your attention to is not just how it's stored, but also the storage size, how many bytes it takes up. So if we look at char, when we declare char4, every single string that we insert into that column will always be 4 bytes. And you can see over here, whether it's an empty string, it will convert it to be 4 spaces. If it's 2 characters, it adds 2 spaces. If it's 4 characters, it leaves it alone. If it's more than 4, it truncates it. So we have a fixed size here. However, with the varchar 4, the same values all have different storage sizes. So they're unchanged when they're stored. We don't get spaces added. We don't get anything truncated, which is good. But you can see that our storage size does start to starts to grow as the length of these strings grow. Now, it's not a one-to-one thing. So it's not like if we have a 10-character string here, it's going to take up 10 bytes. But there is a difference. That's all that matters. With that said, to be honest, that difference won't make a big difference. Let me put that another way. That difference is insignificant for most applications that I have ever worked on. If you are working on some giant app, you work at Bank of America and you've got, tens of millions of customers and hundreds of millions of records, that does make a significant difference. But if you're working on a personal project or your own hobby application, you don't really need to fret over this sort of thing. In fact, it's something, sort of a common strategy that a lot of people would say is just get something working, and then when it comes time, you can optimize things. So if you start to realize, well, this one thing is becoming kind of slow, this query I'm writing, or whatever it is, maybe it makes sense for me to make this a fixed length and convert it to a char. Okay, so that's the difference on paper. You can go ahead and skip to the next video. I'm just going to show you in practice what it looks like. So I'm going to hop over to Cloud9, and first thing I'll say, I'm working in just a new database I made, basically just a testing database. I didn't want to muddy the waters with our inside of our bookshop database. I wanted to leave that alone. So I just made one called new testing DB. If you want to follow along, just make a new database. Hopefully remember how to do that. Call it whatever you want. I'm just going to delete it at the end of this anyways. So I'm going to create a table here. And all I want to do is have two different columns, one that's a char, one that's a varchar. We'll just do dogs, let's say. Create table dogs, and we'll have name, which will be char of fixed length, 5 characters. And then we'll have breed, which will be varchar, and let's just say 10 there. Okay, just like that. And we'll go ahead and hit enter. And I'm missing a comma. There we go. Okay, so we have that dogs table. Now let's insert some simple data. So the first thing that I'll do is insert into dogs. And remember our syntax here. It's been a little while since we've inserted. We've been doing a lot of selects. But we need to have our values. And the values that we'll pass in, we're going to start with something that is less than 5 characters. So for a name, let's say Bob. And breed will also be something short. Let's say, well, what is a short dog breed? Beagle, I guess. I don't know. Okay, so we'll do that. And we'll do one more here. This time we'll have a name that's exactly 5 characters. Let's call it Robbie, spelled that way. I apologize for unoriginal names here, just trying to work with the constraints. And breed here will be Corgi. Okay. And we'll do one more, and this time we'll have a long name. How about Princess Jane? And Princess Jane is a, man, I'm totally at a loss here. What's another breed? Let's go with Retriever. Did I spell that right? I never remember. All right, forgive me if that's spelled wrong. Okay, so first thing first, right off the bat, notice we got a warning on this last one. Why do you think that happened? Well, it's because Princess Jane exceeds the limit that we've set for our char, which is 5 characters. So now if we do a simple select star from dogs, you'll see we have Bob, Robbie. They look good. They look the same, unchanged. And Princess Jane, unfortunately, has been truncated. So unfortunately, we can't actually tell that there are those trailing spaces because they are not actually here when the text is retrieved. Remember what that giant blurb of text said. It said that they're stored with these 2 extra spaces in our case because this is 3 characters and we set up a 5-character fixed char. So there in memory are going to be 2 spaces here, but when it's pulled back out and displayed to us, they're chopped off. Robbie is unchanged because Robbie is 5 characters long. Princess Jane, unfortunately, is cut off. However, when we look over here, Beagle, Corgi, and Retriever, varchar works how you expect. It's a variable character length. Let's just do one more example here with Princess Jane. Yeah, we'll just have another Princess Jane and a long Retriever, blah, 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 blah. Now, when I do a select star, notice again what happened. This is what we expect to happen. We've already seen this, how varchar works. It still has a maximum length that we can provide. In this case, we did 10, I believe. Yes. So it can work similarly to a char in that sense, where it will truncate things. So just to wrap up at the end here, char, again, is faster for fixed length text. So if you know something is always going to be the same size, use char. However, if you have any doubt, use varchar. And again, the difference is relatively insignificant for most of the things. And I don't want to be presumptuous, but most of the time, it's not going to be a deal breaker. Okay, so moving on, we're now going to discuss numbers in the next video, not this video. Okay, so next up in this onslaught of data types, we're going to discuss some important numeric types. So there are quite a few. We've already discussed int. We've used it quite a bit. It works with whole numbers. So it's useful if you're working with things where you need them or want them to be whole numbers, where decimals don't matter. So we know how int works at this point. However, there are a bunch of other data types that MySQL comes with. We're not going to talk about every single one. We're just going to talk about the ones that will matter the most. And in my opinion, those are, or the first one is decimal. So decimal is what it sounds like. It's a number that includes a decimal afterwards, or how can I put this? I don't think that's the right way of saying it. It's a number that includes a decimal point and something after it, or it can include something after it. So when we create a column, we actually provide two arguments, and we'll talk about those in just a moment. But the important part here is that it's a way of creating a column that will store numbers that include decimals, something after the decimal point. So what are these two numbers we're passing in? Well, on this next slide, I have a handy little graphic here. When we run, or when we create a column, let's say, let's call it price. This is a price of let's work with books, or books price. We have two different arguments. The first one, 5, tells MySQL the maximum number of digits that our number can have. So that actually includes both before and after the decimal point. And then the second number is how many digits come after the decimal point. So another way of looking at it is something like this. Here's the maximum number we can store in a decimal 5,2. So it's 5 digits long. 2 of those digits are after the decimal point. And if we hop over to the documentation, which I'll try and hold my tongue, but I definitely find to be occasionally subpar, it does an okay job here explaining it. So the declaration syntax for a decimal column is decimal m, d. M is the maximum number of digits, the precision. It can go up to 65. D is the number of digits to the right of the decimal point, also called the scale. I've never heard anyone actually use those terms, but I guess it's good to know. And it has a range of 0 to 30. So there can be no more than 30 digits after the decimal point, which in most cases is going to be plenty. I mean, way, way, way more than you pretty much ever need. So that's the gist of decimal here. It lets us store numbers that have decimals, but we do need to specify roughly what those numbers need to look like. So we'll create a very simple table, let's say a generic item. So items, and all we're going to have is a price. We won't even worry about a name or anything. So we'll have a column called price, which is a decimal. And let's go with what we saw there, 5,2, just like that. Okay, so we have that now. Let's insert a couple things and test it out. So insert into items. The first one that we'll do, well, we need to specify price and then values. And the first one will be just a whole number. Let's say 7. Just like that. Okay. Then let's do a long whole number like that. See that we get a warning. Then let's do 34.88. Then let's also do a 298.9999. And finally, let's do 1.9999. Okay, so now let's do our select star from items and see what we have. Okay, so the first thing that you'll notice is when we inserted 7 without a decimal, it added those 2 decimal places for us. And again, that's because when we created the table, we said there are 2 places after the decimal. So it adds those in, even if it's a nice whole number. This next one is a bit weird. We never inserted 999.99. we inserted 7987654. So what's happening here is that this is much larger than the maximum number allowed. The maximum number allowed, as you can see here, is 999.99 because we specified it's 5 digits total with 2 coming after the decimal. So that gives us 999.99. So good to know. When you do this, if you create a number that's too large, it's going to just put the largest possible decimal given the constraints you set up. Then next up, we have our 34.88, which looks just the same. And then we have 298.9999, which you'll notice here is actually rounded up. So it's rounded to 299, and that's because we specified rounding to 2 decimal places. And when we do that, it's going to round up, and that will round up, and so on. Well, actually, it's on this one here. It will round up to 299.00. Same thing applies here, where we have 1.9999. So that's the basics of the decimal data type. Pretty commonly used. I'll be using it throughout the course. With that said, there are other data types that we can use to do the same thing that we're going to talk about in the next video, and we'll discuss why and when you would use each one. Okay, so we discussed the decimal type, and you've already seen the int type, but we're focusing on the decimal type, or we did focus on it. But like I said, there's a bit of competition. So there are other types that we could use to represent similar data, which is to say numbers that are not whole numbers. So there's also things like float and double. So we're going to talk about those in this video. The differences, I'll have to be upfront, between all of them are quite technical. They have to do with how things are stored in memory. It would be difficult to explain without going all the way into how binary works and base 10 versus base 2 and how things are stored in memory. So I'm going to kind of skim over some of this because the honest answer is that it doesn't, or the truth is that it doesn't really matter. All that matters is that you know functionally what the difference is. But if you do want to learn more about the difference between them, there are some good resources online, and I highly recommend that you check out some YouTube videos. And I would love to link you to a specific one. However, I've had some copyright claim issues, so last time I did that, I'm not going to do it now. If you're curious, you can research it. But essentially, like I said, it boils down to how they're stored. So the big question is, what's the difference between float and double, let's take them as a unit, and decimal? And if we go to the documentation, there's a page that lays it out relatively plainly. It says the decimal data type is a fixed point type and calculations are exact. The float and double data types are floating point types and calculations are approximate. So we've got fixed point and floating point. They are different. That has to do with how what I was describing, how they're stored in memory is different. That's not as important. Just knowing that they are different is important. However, the side effect of how they're stored is that float and doubles are approximate, which seems kind of weird. It doesn't seem like you would ever want to use them if they are not exact. But essentially, they're approximate. And decimals are exact. So to boil it down, float and double will store larger numbers using less space. So that's an advantage. They can take gigantic numbers, things that you can't store in a decimal, and they'll use less space. However, that comes at a big cost. It's a big but. It comes at the cost of precision. So it doesn't mean that your numbers will be wildly inaccurate if you're using a float or a double, but it does mean that they're not going to be as accurate as a decimal. So here's a simple table that it just basically takes information from the documentation. Floats will have precision issues after around 7 digits. So if we had something like this number here, we could run into a problem where this 1 might not reliably be 1 when we retrieve it. It might change. And that could be problematic if you need it to be precise. But if you're working with gigantic numbers, something like this, or let's even add in something like this 1 at the very end isn't going to be a deal breaker most of the time, depending on what you're working with. With that said, it's really important to know that there is a difference, and there's a lot of kind of classic bugs and issues people have run into. Lots of blog posts around floating point math problems, floating point math issues and bugs. Doubles are basically the same thing as a float. They're just bigger. They have larger capacity. However, they take up more space in memory. As you can see, 4 bytes versus 8 bytes. A double, however, is more precise. So it's precise to roughly 15 digits rather than just 7. So if you do use one of these, it's better to use double. Which brings us to the question, what numeric data type should you use when you're storing information that has a decimal? And the answer, at least in my opinion, is you should always try and use decimal unless you know that precision doesn't matter. So if you're doing things like financial data, prices, if you're a bank, you need that precision, absolutely you need to use decimal. Otherwise, you can get away with floats or doubles. But for the most part, I'll be using decimal. It's kind of my preferred data type when we're working with decimals. Oh, and before I forget, well, actually, I already forgot, but this is after I recorded the video. I'm going and adding this in. I wanted to show you that you can actually see the inconsistency, the impreciseness of using floats and doubles as well. So I'm going to create a simple table, and I will just call it, let's go with thingies. Why not? Create table thingies, and all that it's going to have in there is a price, which will go with float. Okay, so then we'll do our insert into thingies, and we'll do what we need to do, price, values, and let's start with a simple one. Let's do 88.45. And if we select that out of there, good, we get 88.45. But we'll run into problems if we start making more complex, longer numbers. So let's do something like 8877.45. And that should still work. And if we select it out, you can see it's unchanged. Remember, we're working with 4, 5, 6 characters here. And if we go back to that table that I had, it says around 7 issues we run into precision problems. 7 characters we run into precision problems. So if we do something a little longer now, 8877665544, and we hit enter, notice how it got stored. So it doesn't just truncate it, doesn't chop things off, but it only stores the first 7 digits, and then it just puts these empty tens places, well, not tens places, but it multiplies by 10, adds zeros essentially at the end. So we end up with this, which is very different than this. And if we instead had this as a double instead of a float, we would have that precision extended out to 15 characters. So it is significant, and it makes a big impact depending on what you're doing and what you need. So that's why I recommend using decimal, where you can control exactly what you need and how long you need things to be. However, if you're working with gigantic numbers and you don't need to be that precise, you can use double or float. But typically, my rule of thumb is if you need to use one, use double rather than float, because you have 15 characters, 15 places of precision rather than 7. You get double the precision. Okay, all right. So we've made it through that war zone of string and number types in particular. The number types are always a bit hairy, but we're moving on to something equally finicky, dates and times. Often the bane of many programmers' existence, having to deal with time zones and synchronizing things across the world and daylight savings, and it's just a nightmare. Leap years. Fortunately, MySQL makes it relatively simple for us. I'm going to show you how in just next couple of videos. So this is going to be a series here, not just a single video. And in fact, in this first video, I'm just going to give you a quick overview of the 3 important data types that we'll take a look at. So the first one is called date. And what it does is it just stores a date without a time. So the format looks like this. year dash month dash day. So 1999 dash 11 dash 25 or something. So as it states here, that stores a date but no time. So there are instances where you may use this, things like a birthday, if you're asking a user to sign up and specify their birthday. Most users don't know the time. Well, I don't know. I don't know the time I was born. I know a lot of people do, but it doesn't matter. At least for most websites, it doesn't matter what time someone was born. You just need that date. Another option is the opposite, the time. So time is another data type that stores values with a time but no date. So out of the three I'm going to show you, this is the one I use the least by far, because there's not many things that you just need to store a time. Maybe if you're, I don't know, if you're working with reminders, maybe or working, I'm at a loss really, but basically you store times, and the syntax, the format is hour dash, colon, minute, colon, second. And the final data type, and the one that I use by far the most out of all of them, is date time. Not very creative, I know, it's just date plus time. It does what it sounds like, which I also realize I'm saying way too often in this course, but it stores values with a date and a time. And this is pretty useful. You get both. And like I said, this is what I use the most. So when you're doing things like, I don't know, when a user signed up for your site, or when something was last updated, when a profile picture was last updated, or when somebody commented on a Facebook post, those are all stored with date times, because just having the time on its own isn't that useful. So let's go with this Facebook example. If I comment on someone's post, Facebook doesn't just store the time that I commented, 10:39 p.m., let's say, because it's just not that useful to them. I think what Facebook does, it displays things like how many days ago or hours or minutes ago something, I commented. It will say Colt commented 3 seconds ago, 20 minutes ago, 2 days ago, last month. And it needs more than just a time to figure that out, right? It needs a time and the day. So date time, very, very useful and used all the time in applications. And a really common use case in programming in general is when you have a column, or let's say a row in a database, in a table, and it's created. You often want to just store the date and time it was created, so that you can then go and sort things based off of how new they are and how old they are. So very easy, if you're working on comments, for example, going back to Facebook comments are displayed in the order that they were written and posted. So you need to store that created at time. So that's where date times come in. And the format is also what you probably expect. Year dash month dash day, which is the date part, and then a space, hour, colon, minute, colon, second, which is the time component. Okay, so we talked about those three. We didn't see them in action, but we saw that they exist: date and time and date time. And again, I use date time the most, will be using it the most. It's the most versatile and the most useful. So now that you've seen the three data types we're talking about here around dates, which are date, time, and date time, let's hop over to Cloud9 and just try them out briefly. So what I'm going to do is actually make a new table. And in this one table, I'm going to use all three types, three different columns, of course, so that we can compare and contrast how they work. And you'll see that they're pretty similar, honestly, which is why I didn't want to make three separate videos, because it would be pretty boring. It'd be a lot of repetition. So let's go ahead and do this. Now we're going to make a table called people. And in people, we're going to work with, we'll start with name, which will just be a varchar. So somebody's name. Then we're also going to have birthday as a date, birthday as a time, and birthday as a date time. Of course, we can't just call it birthday 3 times. So we'll start with birth date is a date. Then we'll have birth time is a time. Finally, birth Date time is kind of annoying. Let's just do DT is a date time, just like that. Okay, so we have that table now with name, birth date, birth time, and birth DT. So we're not going to spend a lot of time adding data in, but let's insert at least 2. So let's do an insert into people. And we'll start with name, birth date, birth time, birth DT. Okay, just like that. And then on a new line, this is going to be the worst part. So let's make up a date. Well, a name, first of all. Let's say Padma. And then the birth date. Remember, we need that year, dash, month, dash, day format. So we will do 1983 dash, let's do 11. So that's the birth date. Then the birth time needs to follow hours, minute, second. Well, hour, colon, minute, colon, second. So let's say 10:07, 35. And then if we want to be accurate for the date time, we would basically combine these two. So we would have 1983-11 space in the same time. Okay, so that's kind of annoying to type. You're usually not doing things like this, to be honest, but let's just make sure we don't have any typos. We're not missing any quotes. We'll soon see. Oh boy, we do have a problem. And this is a silly one. We're missing the values keyword. Hopefully you caught that before me. Okay, so I'm just going to recall that and just change some information. So we have 2 people in there. So we had Padma. Let's put Larry, who was born in 1943. And on December 25th, on Christmas. At, let's do 4:10:42. And then we'll just copy this so we don't have to retype that whole thing. I apologize. This is a little bit painful to sit through. We're not doing much. But we need some data to work with. Okay, so that should be sufficient now. Just make sure that matches up. All right. So now we do a select star from people. We have 2 people in there, and then we're storing birthday information 3 different ways, although they're not equivalent, of course, because we have just the date, just the time, and then the date and time together. So now that we have this data in there, we're going to focus for a couple videos, pretty short videos, on how we can work with this data. There are some functions that come with MySQL, and we've seen a bunch of them, but there's some that work with dates and date times, and we're going to focus on those to do things like format our data nicely. So how do we format dates? How do we get the day of the week based off of someone's day they were born? Things like that. How do we print out a nice version? This is a little bit ugly. And then also, how do we do math with dates? Now, we're not going to do any heavy-duty math, but things like calculating how many years it's been from 1943 to now, or how many days since Padma was born, those sort of things. And we'll be able to do that now because we have this data in here. So thanks for sitting through that. I know it's probably a bit painful. Hey there. So I have a small confession to make at the beginning of this video. This is not my first time recording this. I recorded this about a month ago, along with all the other videos in this section, and something happened. I didn't save it correctly. I maybe accidentally deleted it. My cat stepped on the keyboard. I have no idea. But the original video here is gone. And normally that wouldn't be a problem. It's happened before, or I just re-record a section because I'm not happy with it. That's not too bad. It's easy to do. But since this has to do with dates, and in particular, it has to do with these 3 date functions that I'm going to show you. Basically, they give us the current date, the current time, and the current date time. You'll see in the videos following this one that the code that I ran when I was recording it the first time resulted in different dates and different times than what you'll see right now. So it's not a big deal at all. It's just evidence that I recorded them on different times, but I wanted to just let you know what to expect. Okay, so in the last video, we inserted these 2 where we manually created or basically wrote out the dates, the time, and the date time. And then in the initial recorded version of this video, this is the new person that I inserted. And this birth date, birth time, and birth date time were all done using these 3 functions here that give the current birth or the current date. So at the time it was April 21st, and the time was 7/12, and this was the date time. And so I used these to generate this. So in the next video, you will see this person with toaster, birth date, April 21st, and so on. But in this video where I'm actually showing you the creation, I'm having to re-record it. So there's just a small discrepancy. Other than that, everything else will be the same. So let me show you these 3 methods here. They're really useful, simple things, but cur date gives current date. As I said, cur time gives the current time. And then now gives current date time. So let's try one of them just on their own. If you did something like select cur date, you'll see that I'm actually recording this on 5/12, May 12th, so not quite a month later, but a couple weeks later. So if we do the same thing with cur time, we get the time. And then if we do now, we get the date time. So using them on their own is not useful really, just to select the current time. It's much easier just to look at your watch. But they become useful when we use them in conjunction with insert statements. So things like when we're inserting a new user and we want to save the time that the user was inserted. What we could do is basically write an insert into, and we'll do people. Let's do our select star from people. Okay, so we'll do insert into people, birth date, birth time, and birth date time. And so I think the hypothetical story I gave was that Toaster was my son, my first son, and he was born exactly at the moment when I hit enter. So we'll do the same thing here. Inserting into people, birth date, birth time, birth date time. This will be my new son, and this one's name is, let me actually add name as well. Oh boy, I'm really bad at naming things. You can tell I named my cat Blue, which is Blue Steel, by the way, if you didn't catch that. Okay, so I'll name him Microwave. And then rather than writing out the giant date here, what I'll do instead is for the birth date, I just say cur date. And then for the birth time, I'll just use cur time. And then for birth date time, I use now. And out of all of these, I end up using now the most often because, as I've mentioned before, we use date times a lot. Okay, so if we just run this right now and insert that, and now we do our select star from people, you can see that Microwave now has the date, the time, and the date time that reflect exactly when I inserted this just a couple of seconds ago. And that's pretty much all there is to these 3 nice little functions. Another way that we use them, by the way, is not just to insert data with current dates and times and so on, but also to compare data to the current time. So I'll show you how to do some basic date math. We'll be able to figure out, how long ago something was compared to now. And so we need to be able to refer to now, or we want to figure out how many dates, how many days somebody was born ago compared to the current date. So we need that current date in order to help out with that math. Okay, so the last thing I'll do here just for continuity's sake is delete Microwave so that we have Toaster, Larry, and Padma, which is what I had in the original recording, so that the next video here hopefully will be relatively seamless. So I'm getting rid of my son. I'm sorry, Microwave. I failed you. Okay, so now he's gone, and we're back to these 3. All right, so that's cur date, cur time, and now. All right, welcome back. So in this video, we're continuing with dates. Not the most exciting topic potentially, I know, but an important one nonetheless. So we're talking about formatting dates. Right now we have dates, times, date times, all stored in a somewhat clunky, condensed, but difficult to read, at least for human, difficult to read format. Just not very nice. So how can we extract things out of, let's say, a date time? How can I convert that so that it says something like April 21st, like the full month name, followed by a space, 21st 21st, and then the full year, rather than, 2017-04-22. So we're going to do that. First thing I want to show you, though, is that in the documentation, there's a pretty massive list of date and time functions. And I will be honest with you, most of these I never use, and you likely will never use. That won't stop me from showing some of them to you, and I'm going to try and highlight which ones are most important. And the first few I'm going to show you, I don't actually think are that important, but they are nice to know that they exist. And they're a set of these one-off little functions. I'm not sure even what to call them, but basically there's a group of them, at least in my mind, I group them together. Things that will extract an individual piece of information, like day, or day name, or day of month, day of week, day of year, hour, month, minute. So let me show you what I mean. So I'm going to hop over to Cloud9, and we have a select star. Let's only work with birth date for now. So we'll do select name, comma, birth date from people. Okay, so instead of displaying the date here, or the entire date, what I can do is use some of those things that we talked about, whatever that group is. Let's try day. You'll see what it does. So rather than birth date, I'll select day of birth date. And all that it does is extract the day. So if we compare, actually what might be better is if I keep birth date and I just add in an extra column with day. So it's extracting the day, 11, 25, and 21. So there's other things we can do. Let's just go with this list I have up here, day name. And this is a bit more useful. There are times when you want to do this. As you can see, we're extracting that. So turns out this is a Friday, this is a Saturday, and this is another Friday. I know some people can figure this out mentally. There's a whole trick to doing it. I'm not one of those people, so we just have to trust it, that this is indeed a Friday. Moving right along, we can try day of week, and you might wonder, how is that different? Well, it gives you a number. So a Friday is a 6, a Saturday is a 7, a Sunday is a 1, and so on. Then we also have day of year, and that will tell us, starting from the beginning of the year, how many days was it until, oh boy, messed up the parentheses. Here we go. Until that date. So for something on Christmas of 1943, it was the 359th day of the year. Oh my God. Blue, come on. Blue. And this, of course, takes into account things like leap years. So important to know. With that said, these also apply to date times. So if you tried to do it on time, if we start right there, instead of doing birth date, and you tried to do birth time, well, there's going to be an immediate problem, which is we're not storing day of the year or day information at all. But just to show you, we don't get an error, right? We get warnings, but we don't get something that breaks everything. We just get null. It doesn't work. But we can do it on a date time, and that's what, like I said, I use most of the time. So if we do birth dt instead, you can see that it's giving us the correct numbers here, 359, 111, and so on. So we can use all of the ones we've seen, day name, but there are other things too, briefly, that work for date and date time, so things like month. So that tells us the month. What else is there? I think there's a month name. Yep. So if you want the full name of the month, there we go. And then lastly, when we're working with the time, so if we go and change this to birth time, there are a few methods that apply here. We can do things like hour, if we want to extract the hour, or minute. Now, I don't end up using time on its own that often, so I don't really end up using these minute or hour or second on their own ever, really. So that's part one of formatting dates. Imagine if you wanted to do something like this. Instead of just printing out, the day or something, we wanted to say April 21st, 2017 at, 6 p.m. maybe. Or we don't even need that. Let's just say April 21st, 2017. So how would we take this date, that would be 2017-04-21, and convert it to this? Well, we could use what we've already seen and do a giant concat. I won't make you do this entire thing, but basically we could extract the month name to get this, and then concatenate that with a space. And then this part's a little trickier, right? It's going to be a pain, honestly. You would have to have some logic that I haven't shown you how to do yet, because you don't always add ST after a number. What if it's the 23rd? So that's a little bit more complicated. So let's reduce it to this. So for that, we would want to get the day, right? And then we want the year. So you could do a giant concat. Basically, we would take all of these for birth date. This is going to get messy. And the point is that there's a better way. But imagine you're doing this. So we have a concat, month name of the birth date, comma, with a space, comma, the day of the birth date, comma, another space, comma, the year of the birth date. This is a bit of a mess. But let's see if it does work. So we'll just select that from people. There we go. November 11, 1983, December 25th, 1943, or 1943, April 21, 2017. So it does work, but this is not a great way of formatting dates. And in fact, there's a much better way, which you probably gathered because the way that I set this up. There's an entirely separate method or function, that we can use, which is called date format. So date format is really, really useful in my opinion. I use it all the time. What it does, it looks a little intimidating looking at the documentation, but what it does is it allows us to format things nicely and powerfully. We have a lot of different things that we can do. So these are called specifiers over here. There's a table of them, and they're basically little symbols, little shortcuts that allow us to specify what we want from that date. So let's say we're working with a date time, and if I want to get the month name, I use %, capital M. And if I want the month number, then I use %, lowercase m. If I wanted to get the day of the week as the weekday name, I use %, uppercase W. If I want the day of the week as a number, I use %, lowercase w, and so on. So what we do is combine them together in a string. And when you pass it into date format, it will take a date and then this string of how you want to format it, and it will spit out a nice answer for you. So here's an example. Excuse my fridge there, or my ice maker, I guess, being noisy. So we've got date format of this date time here. It works on date times and just plain dates. So here's a date time though. My fridge making so much noise. Okay, I think it's done. So we have this date time, and we're formatting it with this, which looks a little bit like gibberish. But we have %, W, which gives us the day of the week as the word, the name of the day of the week, and then a space, which gives us that space. Then we have %, M, which is the name of the month. So we have October, and then another space, and then we have %Y, which gives us the year. So really useful and versatile. I'm just going to copy this one over just run it so that you can see what happens. If I hit enter, we get Sunday, October 2009. But we're free to put whatever we want in here. So we can do dashes. Not that it really makes sense, but if we put dashes there, it still puts the important information here that we specified, but now they're separated by dashes. So it gives us some freedom. We can do, group them together like that if we wanted to, put commas, or we could put an entire word before or after. We can do whatever we want. So this is really, really useful. If we go back and select, let's work with date time. So we'll do select date format, and then we're working with birth DT, and then some string that we'll provide in just a second. We'll come back to that from people. We can start with something really simple, like just getting the day of the week as we'll do day of the week first as a word. So uppercase W. We could do something like was born on a Friday, a Friday. But as you saw, there are a bunch of other things that we can do here. We can work with hours and minutes. We can work with seconds, month names, tons and tons of things. It's really versatile and very useful. And typically the things that I end up doing with it are just formatting dates so that they look like, at least in the US, where we put the month first, followed by the day, followed by the year. So that's pretty simple to do. Think about how you would do it, though, if you want to give it a shot. How do we take this and change it into that? So we can do that now. All that we want is the month number, right? So that's %M, I believe, followed by a slash, and then the day, %D, followed by the year, which is %Y. Let's see if that works. Almost. If you notice, I use lowercase y, and that gives us the two, I don't know what you call this, the abbreviated year, the last two digits of the year. So we want uppercase Y. And I just happen to remember that, but if you couldn't remember how to do it, you can consult this. And we'd find it, where's that? Year, numeric 4 digits versus 2 digits. So let's wrap all this up. We talked about a lot of different ways of formatting dates. I frankly don't use these that often, like I said, because you can do the same thing using date format. I should mention there's also a time format. It works exactly the same way. You just pass in you pass in a different formatter here. So you're not going to be able to get month, day, and year from a time, but that you can get hours, minutes, seconds. But like I said, I'm not working with times as often. And if I am using a time component, it's within a date time. So I might do something like this. And let's just do hour and minute. And we'll put a colon there. And there you go. So I'll do something like that, but I'm rarely working with just a time, but there is a time format if you do need to do that. Okay, so back to where I was wrapping up here. There are all these weird one-off functions. I don't use them though because you can just replicate it using date format. And it's much easier for me just to remember one function, date format, rather than 15 separate functions. So that's the basics of formatting dates. Next up, we're going to talk a bit about doing math with dates. All right, welcome back. So in this video, we're going to talk about date math. How do we add dates, subtract them, figure out how many days are between two dates, for example, or how many minutes, or take a current date and add, 10 minutes into the future or something like that. It's a pretty common thing to do, especially when you're dealing with comments or blog posts or some sort of information where it makes sense to display how long ago something was created. On Facebook, I think I've been over this before, but Facebook will tell you this, you commented on this 10 minutes ago, and then you come back the next day, it will say 1 day ago. And then a week later, it'll say a week ago. And then at some point, it transitions over just to the date. It will say December 5th or something. So you can accomplish that by using some of the tools I'm going to show you in this video. Now, we're not going to spend a ton of time on date math because it's not the most exciting thing. Also, date math sort of sounds like, like at the end of a date, fighting for the check, figuring out who pays for what. Anyways, yeah, it sounds like a bad band name or something. Date math, though, in our context, there's two main functions we're going to talk about. And the first one is pretty simple. It's called date diff. No underscore, it's just date diff. It stands for date difference. And what it will do is it takes two dates. So here's an example one, a date time, which I should highlight. Pretty much everything in MySQL that has date in the name will also accept date time. So, okay, here's a date time, and then here's a date. And when you subtract them, it turns out they're 1 day apart. So this always tells you the number of days. So it's not going to give you minutes or seconds or months or something. It gives you days. And then if you wanted to, you could turn that into months or something. However, its primary purpose is to give you the number of days. So let's try it. We could do something like this. Let's work with our star from people. Let's work with that. And let's figure out how many days ago each person here was born. So it would be something like select date diff. And then we want to take now and subtract birth date. Hopefully that makes sense. We're taking now. We could also do cur date. It wouldn't make a difference because we're not working with the time part of now, but I like now. It's a short, easy to remember thing. So select date diff now, or comma birth date. So that will take current date, subtract birth date, and find the number of days. Let's try it. Okay. So let's make this a little bit clearer. Let's do select date diff, and we'll also display name and birth date. Here we go. So Padma, born in 1983, 12,215 days ago. Larry, born the longest ago, 1943, is 26,781 days old. And then Toaster, who was just born today, is 0 days old. All right, so that's all there is to date diff. The next thing we're going to take a look at is date add, and there's a little bit more to discuss there. If we just look through the docs, date add, conveniently right below date diff. We've got another table here, like we did when we had date format. There's a bit to discuss. So what this allows us to do, it is kind of the bread and butter for date arithmetic. So we specify a date, so date add, and there's also a date sub for subtract, but we're just going to work with date add for now. So we give it a date or a date time, and then a comma, and then this sort of weird syntax that basically specifies what we want to add. Do we want to add 10 days, 1 year, 4 quarters, or 3 quarters, how about, 18 months, 10 microseconds, whatever it is. The way that we specify it is using the interval keyword. And then we pair it with one of these units and then put it all together. It looks something like this. So if we have this date time, or actually let's take a look at this example here. Date add, here's a date time. And if you want to add 1 second to it, you just have to say interval and then second, which is the unit, and then how many seconds. So it follows that format. Interval 1 day. And then it gets kind of weird when there's things like minute, second. So this will do 1 minute, 1 second. Add that to this date time. Pretty nuanced thing. I've never had to use these ever, but good to know that they exist. So let's give it a shot. Let's work with, why not? Let's do months. So we'll go here. We'll do a select And let's do date time this time. So select birth, date, time from people. Just take a look at what we have. All right. And now let's try also doing a date add, birth, date, time. And we want to add 1 month. So we have to say interval 1. And if you can't remember, you can go over here, month. It's pretty straightforward. Okay. So as you can see here, we go from 1983 11/11 to 1983 12/11. Or here 1943 12/25. Here's a significant month. Whoops. Where we went from Christmas of 43 to January 25th 44. So we can also change that over and do things like, rather than 1 month, what about 10 seconds? You'll just have to trust that that works. We can look at it, but I won't spend time in this video doing that. We could also do things like 3/4. And you might be wondering, okay, that's great. What if I wanted to do, multiple things? Like I wanted to add 1 month and a year. Or I wanted to add, 10 years and 2 seconds. Well, the easiest way to do that is with 2 separate date adds. You can't just chain them together like this, 2 second or something. That doesn't work. However, there's a nice shortcut that I'll show you right now, which brings us to our third way of doing date arithmetic, which is just with the plus and minus sign. So if we go back to the docs, you can actually see that rather than using date add or date sub, which I didn't go over, but it works the same way as date add, except it subtracts things, you can just use a date and then the plus sign and then the interval expression, and a date and a minus sign. So we could rewrite what we did as, if I go back here, this one where we added 1 month. All I need to do, if I get rid of the date add, is just do birth, date, time, plus sign, interval 1 month. As you can see there, it still works. Or I could do, let's subtract 5 months. And this takes us back 5 months, 5 months, and 5 months. All right. So the only other thing that I'll show is that you can chain them together this way, so that you could do something like take a date time and add interval 15 month plus interval 10, let's do hours. And if you take a look, we're not only adding 15 months, but if you look at the time portion, we went from 10 to 20, 4 to 14, 19 to 5. So we're adding 10 hours successfully. So this is my preferred way for doing date math. I will say though, it's not that often that you're doing things like adding 15 months or adding 10 hours. More often than not, I'm actually using date diff and finding how long ago things were relative to now, relative to current time. Okay, so that's pretty much it for date math at this point. The last thing that we're going to talk about in the next video is how we set up timestamps. So a new topic, how do we automatically store when a row is updated, what time it was updated at? So we'll see that in just a sec. All right, so this is the last bit of new content around dates and date times and times. I admit that this section is a bit of a doozy or a pain, or I don't know, it's maybe not the most exciting thing. With that said, this is a really important topic, what we're going to discuss here. And it's something that you'll be doing all the time, or probably will be doing all the time. I do it all the time, which is adding in timestamps to our tables. So when we say timestamps, there's two things to unpack. One is that that's a generic term that just refers to storing information, metadata about when something is created or updated at. That's sort of a standardized name across programming languages or across just in programming in general and in app development. Timestamps refer to basically saving information about when you create a post or when you insert something into a table. However, in MySQL, timestamp is also a data type. So yes, I know it's the last video in this section, but I'm actually going to show you another data type. So hang in there. Fortunately, this data type is really simple, and there's only one case that I recommend that you ever use it. Okay, so there's a page called the date, datetime, and timestamp types. We're going to ignore date. We've already talked about that. Let's compare datetime and timestamp. They both do the same thing. They store date and time information, but there's two differences. If we read the description, datetime is used for values that contain both date and time parts. Yes, we know that. The timestamp is used for values that contain both date and time parts as well. So they're identical in that sense. But the main difference comes down to the range of times and dates they support. So if we look at date time, it goes back to year 1000 and all the way up to year 9999. Timestamp, on the other hand, only goes back to 1970 and up to 2038. So that's really important to note. If you are working with something where you're storing dates that may go back very far, like if I'm trying to think of a good example, but things before 1970, certainly you might have sites where you're storing a birth date, and you might have users who are older than that and they're born in the 60s or the 50s. So timestamp would not work. Same thing going forward. If you're working with dates and date times where you need things to be further into the future, past 2038, then you're not going to want to use timestamps as well. But for what we're talking about, just saving when something is created or when it's most recently updated, we don't need to worry about that being before 1970 or after 2038 because it's right now or when our app is up and running. Now is relative, but basically it's not going to be past 2038. And we're not changing those dates. All that we're going to do is store information. So timestamp is a good data type to use there. And you might be wondering why use it in the first place. Why does it exist if there's already date time? The answer, like so many things in MySQL, is that it just takes up less space. I believe it's 4 bytes compared to 8 for date time, or it might be, it's double to use date time compared to timestamp. I believe it's 4 and 8. So it's easier. And if you're doing something, every time you insert something into a row, you are updating something. That 4 versus 8 makes a difference if you're working with thousands and thousands or millions of records. So now that we've got that out of the way, just to summarize, they store the same type of data. This one is smaller. Timestamps take up less space, but they have a more limited range. So use date time for everything except for what I'm about to show you. Okay, so let's hop over to Cloud9. Here we are. And I have a simple schema going to create a table called comments. Comments is very simple. It has 2 fields. The first field is called content, and it's just the content of the comment. Things like great article or I made $1,000 a week working from home. Learn how. Email me, or whatever spam comment there is. And then this is the important part: created at, which is a timestamp. First thing to notice. It could be date time. Just want to make that clear. You can do that. It will work. But we're using timestamp because this is basically what it's intended for. And it takes up less space. So just setting it to timestamp on its own is not that useful. This is the key part. Setting the default value to be now. So whenever it's created, take that now, that current time, and put it in timestamp. So if we run this schema right now, and we insert a few things. So let's do insert into comments. All we need to insert is content. And what we'll do is just insert our first one. I'm going to do them separately so that they have different timestamps. So the first one will be LOL, what a funny article. Something silly like that. Then let's do another one. Like, I found this offensive. Okay. So now if we do select star from comments, you can see LOL, what a funny article, created at, already filled in automatically, today's date, the time, 36 seconds. Compared that to I found this offensive, same date, same time until we hit seconds. It was created 10 seconds later. So that's created at, and of course, that's really useful. I would show you how to sort them. However, they're already sorted here, as you can see, because the order I'm putting them in is sorting them. But let me just try one more. Let's do just some gibberish. Select them all. And now we can do things like order by created at. And that will order them basically the way they're ordered now, but we can reverse that. Change that to descending. Now we have the most recent comments up top. So that's created at using default now along with timestamp. But what if we also wanted to store any time a field was changed? There's an easy way to do that as well. Just scroll down, magically hidden here. So instead of calling it created at, I made a new field called changed at. And the first part's the same. It's a timestamp and it sets a default value to be now. But then we get this on update, which we haven't seen before. And frankly, this is really the only time I ever use it. Or I don't know, I'm trying to think if I ever used it in another capacity. Pretty much this is the only way I've seen it used. On update, current timestamp. So what this is saying is that when the row is changed, so if content is changed, then update changed at to be the current timestamp. So we could put something different here. We could put 3, although that's a problem because it's not a timestamp. But if we made this an int, I could do something ridiculous like this. And every time that comments a row is updated, it will change that to be the number 3. But there's no reason to do that whatsoever, so I won't. So if we run this, I called it comments2, by the way. I'm not pointing that out because I think it's original, but just so that you're aware, it's a different table. If I now, let me just use the same comments that I've already run and just change it to be insert into comments2. So here's the first one. And our next one will be just LOL, LOL, LOL. Okay, and now we do a select star from comments2. You can see changed at is filled in because we created them. And let's just do one more. This time will be I like cats and dogs, just to please everybody, unless you're a bird person, I guess, or you hate animals. So they're ordered by default because this is the order we added them in. There's no other way that they would be ordered, but let's try updating one. Okay, so let's update this gibberish here to say something else. It's been a while since we've done an update, but hopefully you remember. So we're gonna want to update comments to set content equal to, and let's say this is not gibberish, something like that. And then we need to specify where content is currently this mess of gibberish. Okay, so if I update that, notice what we had before, 20, 30, 18. The date's not going to change. 20, 30, 18. Now if I do a select star, it's changed to 20, 33, 02. And so now if we order things by, what do we call it? Changed at, you'll see we now have a new order. And so that's really important to take note of, is that if you want to not only track when something was created, but when it was updated, you can use this setup here. So we have timestamp default now. On update, oh, one thing I didn't talk about, current timestamp. You could also put now here. The reason I didn't is just to show you can also use current timestamp. It's just another shortcut. I prefer to use now just because it's, like I said a couple times, short, simple, easy to remember, but current timestamp does the exact same thing in this case. Okay, so this is something, a bit of a recipe that you'll probably return to. It's worth knowing. You'll see me use it as we go in this course and some of the other schemas that we create as things get more complex. It's important, it's useful to store that metadata about when things are created or when they're updated. Okay, we're done. Okay, so we're at the end of this section, and as always, it's your turn to put it into practice, as you can see by these giant letters. So we've got a couple of problems here that cover basically everything we talked about. Well, not everything, but all the big things we talked about in this section, all about data types. So strings, text data types, numeric data types, and then date and time information and ways of working with those dates with some of the more common date functions. So there's a couple of exercises here. Some of them involve writing code. Some of them are fill in the blanks. And some of them are just, I don't know what you would call this, free response, like this one here. So let's get started, and then in the next video, we'll have a solution. So this one, what's a good use case for char or chair, or no, not chair, char or car, that data type. So when would you use that instead of, or in lieu of varchar? So you can use one of the things that we talked about, or come up with your own. You don't have to write it down. Just come up with something. Next up, fill in the blanks here. So we've got a table that I'm creating called inventory or inventories or whatever, some sort of something that we're storing, books or toys. We've got an item name. What data type should that be? There's not necessarily only one workable answer, but there's one better answer. Price. So what data type should price be? And not just the type of, or not just the name of the data type, but what are you going to put in those parentheses? And as a note, all of our prices are less than $1 million. Not equal to $1 million, just to be clear. They're less than 1 million. So how would we represent that with our data type? And then quantity. That's a number as well. What data type makes the most sense there? Okay, then moving on. What's the difference between date time and timestamp? There's not just one difference, but when would you use one versus the other? How are they different? We talked about it. We looked at the documentation for both of them. So hopefully it's not too hard. Next up, in Cloud9, print out the current time using MySQL. So just the time. Then the next question is to print out the current date, but not the time. So just the date. And then once you've done that, print out the current day of the week, the number of the day of the week. So if it's a Saturday, it should be 7. If it's a Friday, 6, and so on. So just print that out. And then do the same thing, print out the current day of the week, but this time it should be the name of the day of the week, like Monday or Tuesday. So the English name of the day of the week for today, the current, whenever you're running this, print out the day of the week. Next up, print out the current day and time using this format. So month slash day slash 4 digits for the year. And then once you've done that, we have another one. Print out the current day and time using this format, which I wasn't sure how to actually boil this down to a nice little formula like we have here. So I just gave you 2 examples. So we have the full month name, January or April. Then we have this, which there's a name for it. I think it's the anglicized, anglicized digits or something. It's in the documentation, so we didn't cover this. You'll have to dig around to figure out how you format it this way. But with the day of the month, like 2 or 1, but instead of just the number, we want this anglicized version, so 2nd, 1st, 3rd, 10th, and so on. And then at, and then the time. And for the time, we just want hour, minutes. Okay. After you've done that, we have one final thing. Create a tweets table, and the tweets table should store the content of a tweet. So that's going to be text, and I believe, 140 characters, and then a username, and we don't need a character limit for that. Let's say 20 characters, but that's not that important. And then we also want to store the time the tweet was created. Okay, when you've done that, pat yourself on the back. Okay, so this is the solution video to our data types problem set. First one here. What's a good use case for char? So there's not a ton of times that I end up using them, but remember they are fixed length, so we have to specify exactly the length of the char that we want for that column. So we often will use it for text that we know 100% has a fixed length. So the one that I've used a couple of times is state abbreviations. If you're doing sex, like M or F, or perhaps you're working on a project where, I don't know, let's say you're working with companies and you want an abbreviated name for every company that's only 5 characters or 4 characters long, then you could use char as well. Hopefully you came up with something better than me, something new and original. Next up, fill in the blanks of this schema. Okay, so there's a couple things to talk about. Item name is text. It's going to be something like, I don't know, Cabbage Patch Doll or baseball hat. And that should be a varchar, most likely. I mean, you could get away with using a char, but there's no reason to do that because it's not fixed length. So it makes more sense to do varchar. And then quantity, I'll skip price for a moment. Quantity makes sense to be an integer. We are never going to have partial items in stock. We're not going to have 2.5 Cabbage Patch Dolls, hopefully, unless there was some sort of massacre with the Cabbage Patch Dolls and a chainsaw. We're hopefully only going to have whole numbers of them. So we'll use int, but price is a little trickier. And so I added this note. Price is always less than $1 million. Okay, but price is not usually or not exclusively a whole number. We want to allow for cents. So we're going to want to use a decimal. Now you could use a float or a double, but as we discussed, decimal is better for monetary stuff because it's more precise. You don't have to worry about losing precision as you get into longer numbers. Okay, so then the question is, what do we put here? It's not just decimal on its own, right? We don't just do this. We have 2 numbers we pass in. And those 2 numbers, if you can remember the names, I believe the first one is precision and the second one is scale. Don't quote me on that though. But basically it's a total number of digits followed by the number of digits after the decimal. So we can start with the number of digits after the decimal, which when you're working with price or monetary information, it's pretty much always 2. So then the question becomes, how many total digits do we need? And if I said it's always less than it's always less than 1 million, that means that our highest price we could have is 999,999.99. So if that's the maximum price, then all we need to do is count up the total number of digits. So that is 3, 6, 7, 8. And that's our answer. Decimal 8, 2. Next up, what's the difference between date time and timestamp? So I have the documentation open for date time, and timestamp. And the first thing I'll say is that there's a couple of differences. There are a few technical differences as far as how they're stored and the ranges that they support. And then there's a big difference into how they're put into use most of the time. So both of them, let's start off, they both store date and time information. So they store the date and then the time. However, there's a big difference in the range that they support. So timestamps have a much smaller range. If you remember, we went over this. Where is that? Timestamp has a range from 1970 to 2038 versus date time goes from year 1000 up to year 9999. So that's one significant difference. The other is the size or the memory they take up. A date time is roughly twice as large as a timestamp, which brings us to the final difference, which is how they're actually put into practice. And typically, timestamps are used, at least in my experience, exclusively when we are trying to add metadata about when something is created or updated to a table. Otherwise, I use date time. Now, that doesn't mean that you can't use timestamp. If you wanted to use timestamp to store birthdays, you could, but you could run into problems if you have, people who are born before 1970. So again, the key differences really boil down to the ranges they support and then how much memory they take up. Okay, moving on. Print out the current time. Finally, some code. So to print out the current time, it's just a matter of cur time. And we need to select that. There we go, 16:08:13. Yours, of course, will differ, most likely. Print out the current date, but not the time. So that one, we want to do cur date. As you can see, April 22nd, 2017, still my birthday. Print out the current day of the week. Okay, so this one's a little bit different. There's a couple ways of achieving this. The first one is to use select day of week, and then we could either give it the date, cur date, or we could use now. So today is a Saturday, so it gives us 7. Just to show you, I can replace this with now, which is a date time, and I also get 7. But there's another way we could do this, which is to use date format. And if we go to the documentation here, and we find this date format, if we scroll down, somewhere on here is day of the week. Where is that? Here we go. Day of the week, %W, lowercase w. So we could use that, do select date format now or cur date, comma, and the string we want is just %, lowercase w. And actually, I didn't know this until now. There is a difference. That's kind of fascinating. If we read this closely, it says day of the week, 0 is Sunday, and 6 is Saturday. So these are not equivalent, actually. Day of the week, Sunday is 1 rather than 0, and Saturday is 7. So I guess if we wanted these to be equivalent, we would need to do a +1 and shift everything by 1, or shift everything down 1 if we're using the previous. Interesting. No idea why that's the case, but it is what it is. So the next thing is to print out the current day of the week, but I want the date name, day name, Monday, Tuesday, Wednesday, and so on. I wouldn't expect you to remember this, but there is a day name that we can use, like that, select day name, or we can do our format date, or date format. I always mix up the order there, but it's date _ format for now. And then we just have to figure out how we get the day of the week name. So if we go to the docs, it's right above. Weekday name, Sunday to Saturday, %, uppercase W. So if we switch back, just change it to an uppercase W, now we get Saturday. Okay. Next up, print out the current date and time using this format. Month, / day, / year. Okay. So we'll need to use date format, and we can just use cur date, or we can use now. I like to use now typically, but we're not actually using the time information. So why don't we just use cur date in this case, just to show you we can. And then the way we want to format it, if we go to the docs, we want, first of all, was the month. So we want month numeric, which is %. Oh no, that's not what we want. What we want is down here, this month numeric 0 to 12. So we get m, lowercase m, %, lowercase m, /, and then we want day of the month numeric 00 to 31, because we want those 2 digits always. So that's lowercase d. So we have lowercase m / lowercase d, and then for year, we want 4 digits. So that's uppercase y. So let's try that. %, lowercase m / %, lowercase d / %, uppercase y. Oh, semicolon. There we go. And that works. Next up, print out the current day and time using this format. It's a bit different. I want the month name, and then the anglicized day, at, and then hours and minutes. So let's start off with what we know. We're going to need to use date format, and we need to use now because we need date and time rather than cur date, which gives us just the date. Then our format string, first thing we want is the month name, which is right, where are you? This is abbreviated month name. Here we go. Month name, uppercase M, So we want uppercase M space, and then the anglicized version of the day. And where is that? Here we go. Day of the month with English suffix. That's what I was trying to say. So it's uppercase D. Okay. Let's just see if that works to start. There we go. April 22nd. Followed by at. No years necessary. So at, and then hours and minutes. So again, hours. We have upper or lowercase h if we want. I guess I didn't specify if we wanted 24-hour time or 12 hours. So either of these will work. I'm just going to do lowercase h colon, and then for minutes, it's lowercase. Well, let's see. I is going to give us. There we go. That will work. Lowercase I. Okay. So lowercase h colon lowercase I. There we go. April 22nd at 4:15. Great. Now moving on to our final problem. Create a tweets table that stores the tweet content, a username, and the time it was created. So the tweet itself can vary in length, so it should be a varchar, most likely. A username could vary in length as well. And then the time it's created could be a date time. It could just be a time if you wanted it to, but what makes the most sense, as we discussed already, is to use timestamp. And we want to set the default to be now. So let's try it. Let's hop over here. And the first thing we want is a create table tweets. And then we're going to have tweet content. So we could call that whatever we want. I'll just call it content. And that will be a varchar up to 140 characters. Then we have username, which will also be a varchar up to 20 characters. And then finally, we have created at or tweeted at or time or whatever you want to call it, which will be a timestamp. And then the important part is default now or default current timestamp, but I like to use now. So let's try it, see if it works. Make sure we have the right commas in place. Semicolon. And good thing we tried it. I'm missing parentheses around now. Let's add the semicolon in as well. Okay, make some space. Now we run it, and it appears to work. Let's just make sure by inserting one tweet. So we'll do content, username. Remember, we don't need to insert created at manually. And let's see, content will be, this is my first tweet, and username will be coltscat. Okay, let's do a select star from tweets. And you can see we have created that in there as a timestamp. Works perfectly. Just double check by inserting something else. Let's just change it slightly. This is my second tweet. Now if we select star, two different timestamps, just a couple seconds later. Okay, now the hardest part. Pat yourself on the back. You made it through. Siri, can you say hello?
Hello, it's me. I was wondering if after all these years you'd like to meet, to go over everything. They say that time's supposed to heal ya, but I ain't done much healing.
Okay, thank you, Siri. Can you just say hello, not sing it?
Hi, Colt wants me to say hello and welcome to the next section.
Thank you, Siri. So as Siri said, hi, welcome to the next section. This section is all about logical operators. So if you come from a programming language or have any programming experience, you have probably stumbled across logical operators. Things like logical and logical or. There's a bunch of others, but those are the primary two. If you have no idea what I'm talking about, don't panic. That's what this section is all about. So this will either serve as a review if you know how to program or if you know logical operators, and it will serve as a way to show you how they work in MySQL, or it will serve to both introduce them and to show you how they work in MySQL. Either way, they're really powerful. I'm not going to say they're important, they are important, but I'm just overusing that phrase in these videos. Everything's important here. but these allow us to string together different queries and make more complex selections. So if I were to give you a really contrived, idiotic example like cars, and I want to select all cars based off of a color, right now all we could do is select all cars that have a color of exactly blue, or a color that contains the word blue, like, I don't know, sky blue or seashore blue or something like that. That's fine. But what if you also wanted to select all cars that were blue or that were red? Again, I said contrived and silly, but the idea is we can string things together. So rather than having to do two queries, we could put them together. Or if we go to our books example, which by the way, we're about to finish with, this is the last of that section, last of our books data, we could make more complex selections like select all books that have a price below $20 and at the same time, we have 50 copies in stock. Or we could do something like select all books written by a certain author before the year 1990. So two different components, right? We could select all books before 1990, select all books written by a certain author, but put them together, we need to use a logical operator. All right, I'm rambling a little bit, I apologize. This section is on logical operators, lots of exercises, of course, like always. Hopefully they're enjoyable. If not, well, like I said, it is a course on databases. So I'm trying, I really am. Yeah. Okay, I'm gonna stop.
Welcome back.
So in this section, we're gonna focus on what are called logical operators. Actually, we're focusing on operators in general, and most of the ones we're gonna work with are logical operators. That distinction doesn't really matter though. I'm just gonna call them all logical operators. And they allow us to add logic into our SQL statements. So up until this point, we've seen things like, which allows us to select things based off of, text looking or containing certain strings, matching patterns. We've seen how to do things where we can check, select all books where the title is exactly Lincoln in the Bardo, or where release year is exactly 2013. But there's a whole slew of other things that we'd like to be able to select based off of, and that's what we're going to focus on in this section. So we're going to see how to do things like select all books not published in 2017. Right now, we don't have a way of doing that. Or what about select all birthdays between two different dates? So not just all birthdays that are exactly, April 22nd, 1990 or 1992 or whatever it is, but between those two dates. Or select all items, so this is some table I made up called items, all items that are in stock and priced below 1999. So that's two different things. We know how to select all items that are in stock, but there's a second component, which is not only do they need to be in stock, but they need to be priced below 1999. And right now, we don't know how to do that either. With that lengthy introduction out of the way, let's take a look at some of our first ones. So the actual first one we're going to look at is called not equal. And it looks like this: exclamation point and an equal sign. So we've seen how to do things using equal sign, right? We've done, select, let's do title, comma, released year from books where, and let's do released year. So where released year is exactly 2017. So we've seen how to do this, with the equal sign. We've been doing it all the time. However, what if I want to do the opposite? I want all books that were released in any year excluding 2017. So what we want to do is basically replace that equal sign with a not equals. So we could do this. Select title from books where year is not equal to 2017. If you're familiar with any programming languages, you've probably come across this not equals. It's a pretty universal way of writing not equals. So let's give it a shot. Recall this and just replace it with not equals. And now you can hopefully see that we get everything back except for Lincoln in the Bardo. And of course, if there was more than one book released in 2017, then we would get any book back or all books back except those books from 2017. So we can see that it's gone. We could do the same thing, but instead of working with release year, what if we do it with author? So let me just start over here. Let's select title, and author last name from books. And we'll start just with all of them. And then let's select where author last name is exactly equal to Harris. So we have those two Harrises. Where author L name equals Harris, just like that. And we get those two. And by just flipping the switch here, that exclamation point, we now get everything except those two. Okay, so hopefully you get the point by now. Not equals works like you would expect. If you're not familiar with the exclamation point, it might take a little bit of getting used to, but otherwise, it's pretty straightforward. It's the opposite of equals. Awesome. So that's the first one that we're taking a look at, but we have quite a few more. Next up, we're going to talk about something very similar, which is not like. Okay, so we saw not equals, which is the opposite of the equal sign. Now we're going to look at not like. And as you probably guessed, not like is the opposite of like. So just to review, we haven't used like all that much, but it is a pretty common and important one. It allows us to match patterns in strings usually. So we can do things like select, let's do all titles, and we'll just do title from books where title like, and we can do things like, we'll start off, how about all books that start with the letter W, just like that. And if we just do W on its own, remember that doesn't really give us anything unless it's an exact match of the letter W, but we use the percent sign there as a placeholder. And now this says all books that start with the letter W and anything afterwards, or we could expand that to be any title that has the letter W. Okay, so that's it for review. That's how like works. We match these patterns, and anything that matches this pattern, where these are placeholders, the percent signs mean anything goes there. Anything that matches this will be returned. So all of these contain a W somewhere. All right, so that brings us to not like, which, as you have probably surmised by now, it will do the opposite. So here's an example. Select all books with titles that don't start with the letter W. So rather than the exclamation point equals, like we had for not equals, we just use the word not space like. And then in this case, W percent sign means something that has a W and then anything after that. And then we're negating that with not. So this in effect says select all the book titles that don't start with the letter W. So if we go back, recall this, which gives us these. Well, actually, let me get rid of the percent sign at the beginning. These are the three books that start with a W. What we talk about when we talk about love, where I'm calling from, and white noise. And if we go and just add NOT, now we get all book titles excluding these three. All right, so that's it for not like. Hopefully you liked that rather than not liked it, I guess. All right, well, let's just move on. So next up, we're moving on to the next subset of logical operators. There's a group that fits together nicely, which you're probably familiar with just from middle school or early school years. And those are the greater than and equal to, greater than or equal to, less than, and less than or equal to. So 4 operators, very similar and pretty useful. So this is the greater than operator in MySQL. It's pretty standard. What is this called? The alligator bracket? I don't know what to call this, honestly. I just call it the greater than bracket. It's pretty universal across programming, and it allows us to do things like select all the books released after a certain year. So select all books where release year is greater than the year 2000. And typically we're working with numbers. I'll talk about strings in a little bit, but typically we're working with numbers. So an example, earlier today, I was looking on Airbnb to book an Airbnb, and they have a filter that allows you to set a minimum price or a maximum price. So if I wanted to, I could have gone in and said, I only want to book Airbnbs that have a price greater than $50 a night or something, to filter out the $20 a night couches in some person's living room. So that's powered behind the scenes, most likely by a greater than sign. So now let's give it a shot on our own. if we hop over here, let's start by just selecting all titles and released year from books. And let's just order by released year. Just ordering it will let us see, when we remove things, it will make it clearer rather than having them just be jumbled. Okay, so we've got 1945 up to 2017. Now, if I want to go ahead and do what I showed you, which is select all the books released in the 2000s or after the year 2000, all I need to do is add in where released year is greater than 2000, just like that. And if we look, we lost everything from here on back. So from Cannery Row to The Amazing Adventures of Cavalier and Clay. Important to note that 2000 is not included, which we'll get to in just a moment, but everything greater than 2000 is. So that gives us all of these books from American Gods down to Lincoln and the Bardo. As you can see, here we go. So that brings us to greater than or equal to, which works exactly the same way, except you add in this equal sign afterwards, which makes it, rather than greater than, it makes it greater than or equal to, which means that it's inclusive. So if I just change that and do where released year, rather than greater than, is greater than or equal to 2000, now it includes the year 2000. Let's do one more quick example. Let's do a select title and stock quantity from books. And let's say that we're going to do a sale because we have some excess stock in some of our books. Any book that we have more than 100, including 100, let's say, so 100 or more copies in stock, we want to select and we're going to discount them. So how do we select those? Well, it's pretty straightforward. We're just going to select title and stock quantity from books where stock quantity is greater than or equal to 100. And there we go. These are the books that we're going to discount. All right. Okay, so there's one other small tangent I want to talk about. It's a bit of a diversion away from the tables and books that we've been working with. This has nothing to do with any particular data. But if you try running something like this, select 99 greater than 1. What do you expect? Well, go ahead and try it if you'd like. I'll go and type it over here. Select 99 greater than 1. If we hit enter, we get the number 1 back. All right, so if you're familiar with other programming languages, you've probably come across Boolean values, true or false values. And that's what MySQL is replicating here. So the way that it works in Boolean logic is it actually works with the numbers 0 and 1. So we know that 99 is greater than 1. That's true. And so we get 1, which is equivalent to true. Basically, this evaluates to 1, which you can think of as evaluating to true. So if that's confusing you, let's try something. Let's change 99 greater than 1 to is 99 greater than 5, 6, 7. Oh, I just lost it. Here we go. We know that that's false. And you can see we get 0. So the reason that I'm showing this to you, well, there's two reasons. One is that it will help us going forward with some of the other things I'm going to show you. When we can start chaining things together, you'll be able to evaluate them and kind of do some exercises on your own first. But the other thing, and the more important reason, is that this is what's happening behind the scenes. When we have something like this right here, where stock quantity is greater than or equal to 100, you can almost think of it as MySQL going through every stock quantity and plugging it in here and trying, okay, is 100 greater than or equal to 100? 1, yes. Okay, so keep that one. Is 23 greater than or equal to 100? 0, no, false. So get rid of that one. And it does that, going down the line. That's kind of the humanized version, if you will. But it's evaluating to these numbers, but those numbers are just bits in memory. But the concept is the same. So if you'd like, let's wrap this up with just a really simple exercise. I'm going to type up a few things, and I'd like for you to evaluate them yourselves. Okay, so I typed up a couple of examples here, and I'd like for you to just either mentally try these or actually try them yourselves. And remember, you'll need to actually run select, and you'll need a semicolon. But what's the result that you expect? And there are a couple of straightforward ones, and then I threw in 2 string ones at the end, basically to give myself a talking point at the end. I want to talk about why this happens and if you should care. So go ahead, I'll throw up a thing on the screen that says you should do it, and then in like 2 seconds I'll be back. All right, I'm back. So first one, 100 greater than 5. Is that true? Well, yes, I believe that to be true. Just to double check, it gives us 1. That means we're in the clear. Negative 15 greater than 15. Is that true? Well, no, I don't think so. And we get 0. All right. 9 greater than negative 10. That seems like it should be true, and it is. What about 1 greater than 1? Well, I don't think 1 is greater than 1, so it's false. However, if there was the equal sign, of course, it would be true. All right. Now, these two. String comparisons with greater than, less than is notorious in all languages for 1, being annoying and confusing, and 2, differing radically between languages. So the advice that I would give to anyone is to just avoid ever having to do anything like this. There are ways around it, but I just wanted to show you what happens. So what do you think? Is the lowercase a, it comes before b, so is it greater than or less than b? And in some languages, it is greater than. In others, it's less than. In MySQL's case, MySQL, if we hit enter, we can see that A is not greater than B, meaning that it's less than B. Although technically, that statement is logically wrong because it could be equal to B, but as you can see, if I add that equal sign, it's still false. So we know definitely A is less than B. Okay, so that brings us to our last one, which is a bit tricky. Uppercase A greater than lowercase a. And if we run that with a semicolon, you'll see that it's false. So uppercase A is not greater than lowercase a. So then does that mean that it's lower? Does uppercase A come before lowercase a? And the answer is actually, if we change this just slightly to be greater than or equal to, you'll see now it's true. So that tells us uppercase A is equivalent to lowercase a in MySQL's eyes. And we've seen that before. When we do something like, well, let me just type it again. Select author, lname, where author lname equals, if we do eggers like this, and of course I add in the all-important table name from books. So if I do this, and let's also do title just to make it easier to see what's going on, it matches just fine. But I can also do this with lowercase e, and it works just the same. Or I can do eggers like that with 2 uppercase g's. So the way that string comparisons work in MySQL is quite odd. And if you're familiar with other languages, it's very different from pretty much every language I've worked with. So just something worth noting, that case doesn't actually matter. All right, so now we're talking about less than. We just talked about greater than and greater than or equal to. So this one should be much shorter. In fact, the total time that it will take will be less than the previous video. Yeah. So it works the same way, although it does the opposite. If you're familiar, again, it's just the less than bracket, the angle bracket, I think is what they're called. I just remembered that. So shift, and then on most keyboards, it's a comma. So we can do things like this. So rather than selecting all books released after 2000, we just switch it to the less than sign, and I'll select star from books where released year is anything below the number 2000. So if we try that, select title and released year from books, if we do all of them, and let's do our order by again, released year, just to make it easier to see where we have missing gaps. Okay, so we want all of these to disappear, or excuse me, we want all of these to disappear, and we only want to select these 5. All we need to do is add in our where released year is less than 2000. And there we go. Okay, so that's pretty much all I'll say about it for now. Along with that, of course, we have less than or equal to, which works the same way that greater than, well, it doesn't work the same way. It works in the same way that greater than or equal to does. So if I wanted to include the year 2000 for whatever reason, I just need that equal sign after the less than sign. And now we get the same 5 books plus the one that was written in 2000, Amazing Adventures of Cavalier and Clay. That's pretty much it. I will throw up a few exercises here if you want to try evaluating them. And then we're moving on to some more interesting and complex operators. All right, so I'm back here. I typed up a couple of quick exercises. Go ahead, try these out. I'll throw up that same graphic again, and I'll be back in 1 second. Okay, I'm back here. So let's go through these quickly. The first one is 3 less than negative 10. Well, I don't think so, but let's verify. You can see 0 meaning false. It's not. Is negative 10 less than negative 9? Yes, it is. It's lower than negative 9. Is 42 less than or equal to 42? Oh, need to add a space there. And as you would expect, we get yes, we get 1 true, because 42 is equal to 42. And now on to the odd string ones. Is the letter H, lowercase, less than the letter P, also lowercase? And if you remember to the last video how this works, H comes before P, and they're both lowercase, so yes, this should be true. And it is. Okay, so this final one is uppercase Q less than or equal to lowercase q. Well, this should be review from the last video, because remember that case doesn't matter. So we see that yes, indeed, it is true. Uppercase Q is less than or equal to lowercase q. And if we get rid of the equal to, this is basically a duplicate of what we just did in the last video, but I just want to hit this home, that it is not lower, it's not greater than, they are equivalent. Well, that's a minus sign. There we go. They're equivalent, as you can see. We get true, or 1. Okay, next up, moving on to much more exciting, much bigger and important logical operators. So in the last video at the end, I mentioned that we're about to move on to bigger and better operators. And this is the first of those. It's called logical AND. You'll also see it as just 2 ampersands. So what it does, it's sort of a step up in operators. It allows us to actually chain together multiple pieces of logical information, multiple operators together, and basically it necessitates that all things are true, all conditions are true. Now that sounds like gibberish, so let's put it in practice. Let's see what I mean. So here's an example. Let's say I wanted to do something like this. Select books written by Dave Eggers that are also published after the year 2010. So individually, these are each straightforward tasks. I color-coded them to show you. Select books written by Dave Eggers. We know how to do that. We also know how to do select all books published after the year 2010 using greater than, what we just saw. However, to put these together, we need to use logical AND. So here's the first part. Select books written by Dave Eggers. It would look like this. Select star from books where author LName equals Eggers. And then to select books published after the year 2010 would look like this. Select star from books where release year is greater than 2010. So to put them together, we use AND. Okay, so as I mentioned, we can either use the word or the text AND or 2 ampersands. And it looks like this. Select star from books where author LName equals Eggers and release year is greater than 2010. And that's it. So basically we just take the 2 where clauses and shove them together with the word AND. And what this means is that both parts have to be true in order for it to be selected. So it will check, is this author's last name Eggers? If it is, then it will move on and say, okay, and was it released after 2010? If it wasn't, then it discards it and it doesn't select it. However, if both parts are true, then we see the results. So let's try it. Okay, so let's start off by selecting title, author LName, and release year. And I'm just working in this document. I'm just going to copy and paste in, but I'm just putting a record of it here to make it easier for me to edit as I go through. So select title, author, LNAME, and release year from books where, and we're just checking where author last name equals Eggers, just like that, with our semicolon. And you can see we have these three: hologram for the king, the circle, and my favorite, heartbreaking work of staggering genius. And then we have release year. So for some reason, someone comes into our bookstore and says, I really like Dave Eggers, but I only like his later stuff, which I would disagree with. I think his earlier stuff is better. But let's say someone says that. Well, then we would do something like select, and I'll actually just copy this and change the where clause to where release year is greater than 2010, which we already know how to do. This should be review. Now this gives us all books released after 2010. And then to combine them is where we use logical and. And release year greater than 2010. Okay, so let's check that it works. You can see we only get 2 results because both of these things have to match. So author has to be exactly Eggers, case insensitive, and release year has to be greater than the year 2010. And just to show you, we can replace this with double ampersands, and it works the exact same way. There we go. Okay, so that's the basics of and. We'll use it all the time. It's important when it's anytime you need to chain together things, if you're trying to search based off of two criteria. So a common example might be something like select star from products. Let's say we work in a toy store where brand equals Lego. But when you're on a store, online store, often there's like an option that will say, show out of stock items or don't show out of stock items. So we could do something behind the scenes like where brand is Lego and in stock equals true. That way we wouldn't be showing the customer any Lego products that are also out of stock, which is frustrating when you see that. So that's a pretty common use case is when you're working with a value, a Boolean yes or no value like in stock or is active user or something like that. Okay, so the last thing that I'll address here is if we go back to this sort of problem set things like 1 less than 5, but rather than just doing one on their own, I'm going to give you a couple here where we're going to chain them together with and I'll give you a first example here. So 1 greater than 5 and 7 equal to 9. So what does this whole thing evaluate to? Remember, both sides have to be true. So let's take either side. We'll take this one. Is 1 less than 5? Yes, that is true. Is 7 equal to 9? No, that's false. And that immediately nullifies or falsifies, the entire thing. Both sides have to be true. Just to double check, let's give it a shot. Select. And you can see 0, false. Okay, so just like before, I'm going to take a moment, fill out a couple of problems, and hopefully you'll stick around and give them a shot. All right, I'm back. So I have 3 simple problems, hopefully simple, that I typed out. Go ahead, give them a shot, and I'll be back. All right, what do you know? I'm back. So let's go over these quickly. The first one, remember, both sides have to be true. So start with the first one. -10 greater than -20. Is that true? Yes, it's larger than -20. How about this? Is 0 less than or equal to 0? Yes, because 0 is equal to 0. Therefore, we have true and true. So this whole thing is true. Let's try it out. Yep, we get 1. Okay, moving on. We have, is -40 less than or equal to 0? And yes, I know I had a negative sign here. I apologize. That was an accident. That's wrong. So hopefully you didn't spend too much time panicking about that. Is -40 less than or equal to 0? That's true. It's smaller than 0. And I used the English version, and. 10 greater than 40. Well, that's actually false, which makes the whole thing false, unfortunately. So let's try it. And we get 0, which means false. Finally, is 54 less than or equal to 54? That's true. 54 is equal to 54. And is A equal to A? Uppercase. Lowercase a equal to uppercase. By now you should remember they are equivalent. So there's true on both sides. And we get true. All right. So the last thing I want to highlight about and is that we're not limited to just 2 components like we saw here. Where author LNAME is Eggers and release year is greater than 2010, we could do 3. We could do 20 if we wanted to. There's probably an upper limit at some point, but typically, if you're working with anything more than 3, there are other ways of doing it, or you may need to change your table structure, which we'll get to once we talk about tables in more depth, and we talk about joins in particular. But in this case, I could do something like this, where author last name is Eggers, and release year is 2010, and title contains the word novel. Don't ask why, but let's say we have a needy customer who wants a Dave Eggers book, only likes his later work, and wants it to be a novel. And the way that she knows or he knows it's a novel is that it contains the word novel in the title. Well, if we go back to what we had here, let's just copy this and duplicate it and add another condition. And I'll do them on separate lines now. So I'll do ampersands for that one, but then I'll do AND for the last condition, which is title, like, and all that we want is percent novel, percent, semicolon. So let's try that. And there we go. We get hologram for the king, a novel, because, okay, first part, author name is Eggers, release year is greater than 2010, 2012 is, and title contains the word novel, so all 3 are met. So this is the only result we get. So that was just to show you that it's not limited to 2 conditions. Next up, we're going to talk about another kind of sister or brother operator, which is logical OR. All right, so we're moving on to logical OR, which, as I just mentioned, is like the brother or sister to logical AND. And if you've worked with any programming language, you're most likely familiar with and or, logical and logical OR. So logical OR you can either write out as OR, or just like we could write AND for and, or we can use these 2 pipe symbols. So these are not uppercase I's or L's or 1s. They are the pipe character, which is usually located above the right return or enter key. You have to hit shift most often to hit it. So it's 2 of them together, just like it was 2 ampersands for and. It's just symbols. It's pretty standardized, or very standardized across all programming languages that I've worked in. Ampersands for and, pipes for or. But you can also use the phonetic or the spelled out version OR. So before we dive into exactly how it works, let's try something. So we had this in the last video. This selects all books written by Dave Eggers, released after the year 2010. But what if we just change the ampersands to the OR pipes? What do you think will happen, first of all? So I'm just going to copy this so we don't have to type this all again. And just change the ampersands here to OR. And I'll hit return so it's clearer what's happening. So if we read this, if you just say the word OR here, it makes a bit more sense. Select title and author name and release year from books where author name is Eggers or release year is greater than 2010. So if we run it, what we'll get is all books written by Dave Eggers and all books where release year is greater than 2010. So rather than both sides of this having to be true, just if either side is true, we'll get the data. So we get all the books by Eggers, including this one, A Heartbreaking Work of Staggering Genius, which came before 2010. But then we move on to the second part, which MySQL selected all books that were released after 2010, regardless of the author name. So it's a way for us to specify 2 things, either of which we want to be true, or both. So in the case of A Hologram for the King, it is both written by Dave Eggers and it was released after 2010. or same thing with the circle here. But 10% happier, for instance, was only this part was true. Released year is greater than 2010 because author name is Harris, or Saunders in this case, or Gaiman. Okay, so again, that symbol right there, I forgot I made this nice little slide, this animation. That change of symbol is very, very important. It changes the meaning entirely from the statement. So if we have two conditions with an ampersand between them, or three, or any number of conditions with ampersands, it means that both sides must be true in order for the whole thing to be true, as we've seen already. However, with the OR operator, it means only one side must be true for the whole thing to be true, or both sides can be true as well. And I know that's a bit odd to talk about in this way without actual examples. So if we hop over again, I'm going to do the same thing I've been doing the last couple of videos. I'm going to type up a few example exercises, and then we'll go over solutions. Okay, so I'm back here. I've got just three this time, that I'll use logical OR. So try them out, and then I'll be right back with a solution. And I'm back already. Okay, so first one here, 40 less than or equal to 100. Well, that part's true. 40 is less than 100. So it doesn't matter what's over here. This whole thing is true because we only need 1/2 to be true. It happens that -2 is not greater than 0, but that's irrelevant because the left side is true. Moving on to this one, 10 greater than 5, is that true? Yes. So it doesn't matter what's on the right side, but that happens to also be true, so the whole thing is true. So we get 1. And this last one, bit of a curveball, is the letter A equal to the number 5? Well, that's not true. However, this side says 3,000 is greater than 2,000. That is true, so the whole thing is true. As we can see, we get 1 for true. Okay, last thing before I forget, just like with AND, we can chain OR together as many times as we want, so it doesn't have to be something like this. So if I go back to this example, select title, author, name, release year from books, where author name is Eggers, or release year is greater than 2010. So let's try adding an OR here, and I'll spell it out this time. And let's say not only do we care, or do we want to select things written by Eggers or release year greater than 2010, we'll also add another OR, which is stock quantity is greater than 100. So books that we have a lot of stock in as well. And let's also print stock quantity, just like that. Let's copy this whole thing, paste it, semicolon. And if we look, see it makes a slight difference because we also get this David Foster Wallace story collection in here, which was written in 2004, which normally wouldn't make the cut with our previous version, but because we added stock quantity greater than 100, it's in here because stock quantity is greater than 172. So for some of these, for instance, a hologram for the king, all 3 parts are true. It's written by Eggers, it's released after 2010, and it has more than 100 copies in stock. But then, like for David Foster Wallace and Oblivion, only one part is true, the last part. So it just goes to show you that only one component, even if we have 3 different conditions, only one part has to be true for the entire thing to be true and for it to be selected and spit back to us. Okay, so that's logical OR. One thing that I will point out that I know you're probably dying to get on with this video, but you can combine OR and and we'll see how to do that in a little bit. So moving right along, our next operator we'll take a look at is called between. And between is pretty straightforward. It allows us to select things based off of 2 values, an upper and lower range. So I can say I want to find, all people who have a birthday between April 20th of 2017 and April 22nd of 2017. Or I want to find all books, that have page counts between 100 and 500 pages. So we actually can do this already using what you know. So before I show you between, how can we accomplish the same thing using the tools that we already have, things that we learned in this section already? Because if you take a moment to think about what being between 2 values actually means, it's really just a combination of greater than and less than. So how do we combine two different conditions? Well, logical and. So let's try an example again. Just to reiterate, if I wasn't clear, we're doing it without the new between operator. We haven't seen that yet. We're doing it the longer way, if you will. So select all books published between the years 2004 and 2015. And that includes 2004 and 2015, just to be clear. Okay, so to do that, we use logical and to join together two different conditions, two components. So select title and release year, blah, 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 that doesn't matter, from books where release year is greater than or equal to 2004 and release year is less than or equal to 2015. So both parts of that have to be true, meaning that whatever the book is that's selected, or all of the books that are selected, are somewhere between 2004, including 2004, and 2015, including 2015. So I won't make you watch me type this whole thing. I'm just going to paste it over here. But let's start off by just doing select title and released year from books and just check, we know this, but just to verify that there are things outside that range. And now, if we paste in using the ampersand, and operator, which of course could also be written this way, if I could type correctly, you'll see that we get things that are between 2004 and 2015, and we know that it's inclusive, as you can see, because 2004 is here. And if we hadn't included that equal sign, then it would not be there. Okay, so really what I'm trying to show you is that you don't need a fancy between operator to accomplish this. You can just do it using good old-fashioned logic, using greater than and less than and a logical and. However, there is an operator between that will make it easier. So it looks like this. The syntax is between and then some value and some other value. This and here, I get it, it could be confusing when we also have this and this one, but they are different. So this and is paired with between, always. So here's an example. Select title and release year again from books where released year between 2004 and 2015. So this does the exact same thing as this right here, but we don't have to use the greater than equal to, less than equal to. We don't have to write release year twice. All we have to do is say where release year between 2004 and 2015. And in my opinion, this is much easier to read, much easier to remember if you're trying to do this. Between is a pretty straightforward thing to recall. It does what it sounds like. So let's try it out. Just copy it. I'll bring it here so we have a record in the notes. And then I'll just paste it in. Select title, release year from books, where release year between 2004 and 2015. And as you can see, we get the same results that we did when we used this version. It's just a little shorter and cleaner and easier to understand, in my opinion. And again, it is inclusive. We have 2004 there. And one thing to keep in mind is that there may be times where you don't want it to be inclusive, and there's not an easy way just to do that. Well, there is an easy way, but it basically just means change this number. If you want it to be 2005 to 2014, you could do that. But there's no easy way to, do between non-inclusive like here, where we can just eliminate the equal sign. Okay. So one other thing is that not between is also a thing. And it's pretty straightforward. Basically, it does the opposite of between. So we could say, I want all the books that have a page length that is not between 100 and 500. And that gives us everything less than 100 and everything greater than 500. So here's our same example. If we do select title and release year from books where release year is not between, so all that changes is we add an OT before, not between 2004 and 2015. It takes that range from 2004 and 2015 and does everything outside of that. So I'll just paste it here and then paste it in again. And now you can see, let's do an order by. Now you can see we have everything up until 2004, and then everything after 2015, but nothing from 2004 up to 2015. They're gone. These are just the leftovers. Okay, so that's pretty much it for the basics of between and not between. So before I let you go, there's one small side note I just want to bring up. It's not crucial to understanding between, but it's just something that the documentation mentions, so I figured I should also mention it. If we go to the docs for between, there is this note at the end. For best results when using between with date or time values, use cast to explicitly convert the values to the desired data type. So we haven't seen this cast, I'll talk about it in a moment, but what it lets us do is convert from one data type to another, from a date to a date time, for instance, or from a string, a varchar, to a date. For example, if you compare date time to two date values, so we're trying to say if some date time is between two different dates, it's best to convert the date values to also be date times, just so that you're working with the same kind of consistent data type. If you use a string constant, such as 2001-1-1, in a comparison to a date, it's better to cast the string to a date. So let's just take a look at how cast works first. And it's pretty simple. So let's take something like this, 2017-05-02. That right there is not technically a date, right? That's not considered a date data type. It's just text. Even though it looks like a date and it can be treated like one. MySQL is smart enough to figure that out if we pass it into a date function, like days or months or format date, but it's not actually a date. But if we wanted to make it an actual date time, we can cast it. And this will work its magic. Now just casting it like this won't do anything. I have to say what to cast it as. So let's cast it as a date time. And we won't see anything unless we have select here. So what this will do is it takes the first thing, whatever it is, and it tries to convert it to a date time. So if there's just, the number 99 or something, that will cause a problem. But in this case, this is easily castable to a date time. But you might be wondering, okay, the date part is easy to cast. What about the time part? Well, it just picks 0000 for you. So it's now considered a date time. So basically what the documentation is saying is if you're working with dates and you're trying to compare them and you're working with between, for example, it's best to use cast to make sure that all the data types are the same. Now, it actually, this is kind of confusing. It will work most of the time just fine if you don't, because MySQL is smart enough to figure out what you want, but it can cause problems. So it's just best to do that. So I'm going to switch over to that testing database I made with this wonderful name, use testing DB. And the only reason I'm doing this is so that we have some date data. So we have a people table, and they have a birth date, birth time, and birth date time. So let's say I want to select people who have a birth date time between two dates. Let's say between 1980, let's do January 1st, 1980, and January 1st, 2000. So I'm going to write it up here. But the basics would be select name, and we'll do birth date time from people, where birth date time between. And if we just do this, 2000, or what I say, 1980-01-01 and 2000-0101. If I just do this on its own, first thing that we're doing here is these are strings, right? These aren't even dates technically. It's text. But if I do this, it still works. And that's what I was mentioning. It's kind of weird is that it works fine enough because MySQL is smart enough. It figures out, okay, this is a date time. We're trying to compare it, see if it's between these two things. What are these? Well, they're not date times, but we still can handle it. There's some contingency code written back in MySQL to make that work. But it's much smarter and more fail-proof to do this. Cast this as date time. And I'll do this second part on a new line. And cast this as a date time as well. So that we're working with date time, date time, date time. And you won't see a difference here, but you can rest easier can sleep better at night knowing that you're doing the right thing. Okay, we're done. Alrighty, so next up, we're talking about a new operator called in, I-N. And what it does is it allows us to provide a set of values, 2, 3, 10, 50 different values, and then check if a given column is in that set. So basically, let me put that in an easier to understand way. Say we wanted to do this. I want to select all the books written by Carver, Raymond Carver, or Lahiri, Jhumpa Lahiri, or Smith, in our case, Patty Smith. So we know how to do that right now. I mean, if you listen to how I just said that with these ors, we would say select all books written by Carver, or by Lahiri, or by Smith. It would look something like this. Select title and author last name from books where author last name is equal to Carver, or author last name is equal to Lahiri, or author last name is equal to Smith. So this works. I'll come on over to Cloud9. First thing I'll need to do is switch databases. I'm using the new testing DB, so I'm going to use Bookshop again. Okay, so now I'm going to use this. Select title and author name from these three, or from where author is one of these three. If I paste that in, you can see we get all the books by Lahiri, Smith, and Carver. Perfect. However, as you probably guessed, there's a better way to do it. In will make it much easier and much shorter. So it looks like this. Select title and author from the first book, or from books, same thing, where author last name is in, and then in parentheses, we pass in a comma separated list of values. So if author name matches anything in here, it will be, the row will be selected. So it's really straightforward, very simple to use. It basically goes from this, multiple lines, and look at how much repetition we have. Author name equals, or author name equals, or author name equals, and condenses it down to this. So let's try it out. I'll paste this down here so you can just compare. If we paste it in, you can see it does the exact same thing. And the other good thing is that, as we add in more conditions, or more authors in our case, this continues to get much longer every time. This is really just a very simple change if we also want to add in another author. Very easy. So it's pretty useful. You're not limited just to working with text. So I'll just duplicate this just to show you. We could do select title and released year, where released year is in, let's say 2017 or 1985, just like that. And if we paste that in, we get these two books. All right, so that was just to show you it doesn't have to be strings. You can work with numbers as well. As you probably guessed, maybe you didn't, I don't know, but there's also a not in, and it works just like not between worked compared to between. It will do the opposite of in. So let's say, this is a really dumb hypothetical, but let's say I'm really superstitious and I have a problem with even numbers. And I go into the bookstore and I tell the clerk this, even though I promise I'm not superstitious and I don't have a problem with even numbers. If anything, I really like even numbers, if you can. But I go into the store and I say, I want to get all books that were not published in even number years, 2000 until 2016. So I want to exclude 2000, 2002, 2004, and so on. Well, I could do this, which is kind of a nightmare, where I'm basically using logical ands and not equals. So remember, I'm going to have to go back a few slides here. When we were doing this version here, before we talked about in, I was doing equals and or. So author name equals Carver, or author name equals Lahiri. But when we negate it and I do the opposite, I need to negate the equals with a not equals, and I flip the or to an and. Which, when I say it that way, I realize it may sound a bit more intimidating than it is. Basically, logically, if we step through this, what I'm saying is I want to select all the books where release year is not 2000, and it's not 2002, and it's not 2004, and it's not any of these. So anything other than these values. And or wouldn't work here. It has to be and. Okay, but the point is that this is a mess. It's obnoxious. It's gigantic. If I do copy it over and I try running it, you'll see we get all books from odd number years. But there's a better way. We can use not in, which works just like you'd expect. Rather than saying in, we just say not in, and we provide that list, that set of values. And in this case, I've just passed them all in. Notice the difference there, massive difference. And if we run this, whoops, we get the exact same result, but much, much shorter and much easier to add onto or change. Now, some of you might be thinking, well, this still seems really silly. There's a couple things that we can change. One is that I only want books released after 2000. So right now, I'm basically saying I don't want any even years in the 2000s, but we're still getting even years, like 96. Is there any others? I guess it's just 96. So what I could do is I say that I only want books released after 2000, and it would just look like this. So the only reason I'm showing you this is so that you can see how to use logical and in conjunction with something like not in. So all that we're doing here is selecting books where they're released after the year 2000, including 2000, greater than or equal to 2000. So that's going to narrow it down significantly. And then within that subset, we only want ones that were released in years that are not contained here. So the odd numbers, the odd 2000s, 2001, 2003, and so on. So as far as why you would do this, let's say that I have tastes in literature and I only want recent books from odd years. And let's do an order by. There we go. So we get 2001 all the way up to 2017. All the modern books with odd years. But there's still something more. And it doesn't require us to use in or not in. Because if you look at this, this is pretty repetitive. Well, repetitive is the wrong word. It's long, and there's a pattern here, right? So there has to be a better way to express this. And what I'm going to show you here has nothing to do with in or not in, so it's a bit of a tangent, but I feel that it's worth talking about. If you're familiar with programming, the solution here is to use an operator called modulo. And basically, this is also known as the remainder operator. What it will allow us to do is test if something is even. So how do we know if something is even in general? Well, it's divisible evenly by 2, right? If we can divide 2 into a number and there's no remainder, that means that it's even. So 4 divided by 2 is 2, and it's just a whole number, so it's perfect. But 3, or let's say 7 divided by 2, is not a clean, even division, so that means that it's not an even number. So there's a way to do that. It looks like this. So the percent sign is known, as I said, as modulo, the remainder operator. So if we just focus on that part, this is saying release year divided by 2, the remainder is not equal to 0. So if we plug in 2000 right here, 2000 divided by 2, the remainder of that is 0. But if we plug in 2001, the remainder is not 0, the remainder is 1, meaning that it's odd. So again, this is above and beyond what you need to know, but I just figured it would come up in the comments if someone saw this gigantic mess here. Someone would probably say there's a better way, and they're right. It just happens to not use in or not in, which is the whole point of this video, but I figured it was still worth talking about. So what we're doing, selecting the same stuff, title, release year from books. First thing is the same, only selecting books that are released after the year 2000 or including the year 2000. And then they also have to be odd years. So released year is not, or released year mod 2 is not equal to 0. 2 does not divide cleanly. And I'll paste that in just so we have a record. Run it. And you can see now I only get the same exact